My name is Victor and I am one of the authors of Technique.com. Technique.com is a website for Linux users and for those who want to learn Linux. And this series in this video is for those who want to learn Linux or become a Linux administrator, or for those who want to write the RHCSA 8 exam. Your success is absolutely guaranteed after completing this course. And you should also go through the RHCSA 8 exam practice questions before you write the exam. So you can either go through this practice questions from where my mouse is. You click on this link and it takes you to the page, or from the YouTube channel you click on playlist and you click on RHCSA 8 exam practice questions. So you also have the opportunity of reading the documentation of the questions, or you watch the video. However, if you don't have the basic knowledge of Linux, you should go through the Learn Linux from Scratch series where my mouse is. You can click on this place, or you come to the playlist here and click on Linux tutorial for beginners. They are the same thing, so it's either Learn Linux from Scratch series or Linux tutorial for beginners. Alright, so there's actually a playlist for this series on this YouTube channel, which is the RHCSA 8 course. Alright, but for those who love just one long video, we have decided to give you a long video. And if you love short videos like I do, because it makes me assign days to the playlist or chapters I want to study, like, it makes me plan myself very well, then you can follow the playlist right here. So for example, when you click on the playlist, all right, you have the chapters from the top to the bottom, all right, and you can follow the playlist here. Okay, and another benefit of the playlist is that you get a direct link of a particular chapter to the website in the description section below. All right, so it's gonna help you when you want to do the class activities coupled with the exam practice questions, and that's for those who want to write the exam. So for example, if I click on this chapter and I come to the show more here description section below, so you can see that when I click here, it's going to take me to the documentation of this particular chapter. All right, so I guess I have a slow internet. So this is the documentation. So I can either use the documentation if I love reading, or I watch the video. Okay, and from the documentation you can also click here, and it's going to take you to the RHCSA 8 exam practice questions. All right, so please subscribe to our newsletter on the website, or you subscribe to this YouTube channel so that you can always get updated. Don't forget to turn the notification button as well, and please comment and like our videos. It propels us to do more. So there are other good courses that are coming up, so don't just watch or download this video. You need to subscribe and drop your comments so you can encourage us to do more. All right, so thank you.
Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, I'm going to be taking you through the RHCSA 8 series, alright? And I'm going to be talking about how to create users and password users in Linux. If you don't have a basic knowledge in Linux, it's better you go through the Learn Linux from Scratch series, where I have talked about Linux from basics. That course is actually for those who don't know anything about Linux and who want to start learning. And that series has been made to tutor you from scratch in a way that you will easily understand everything about Linux, right? And that series is also for those who are already exposed to Linux but left it for a while and want to revise to grasp Linux again. Not to waste too much of our time, so let's go to the main reason why we're here. Users' account on Linux goes a very long way, and it's just more than users logging in and logging out of the system. And every services or processes running on Linux machines runs as a particular user, and the user can be assigned a non-interactive, interactive, a no login and login sure. We will understand this better as we continue. As an administrator, it is your duty to always create users and manage them on the system. And it is also your duty to create their passwords and manage their passwords, which we're going to see how to do now. And at the end of this lesson, I already have the RHCSA 8 simulated questions, what they call DOMs, and we're going to look at those questions and solve some problems. All right. Okay. Linux users are stored in the etc password file. Let's go ahead and check the file. All right. So you can see every Linux user here. Look at the second to the last user, spelled Oluwatomisin. That's actually my second name. Go ahead and try to pronounce that name. I'm sure you get it wrong if you're not a Yoruba. A Yoruba. Yoruba. There are fields in this file that you need to understand. The first field, which is the first column, right, is the username. The second column, which is X, represents the password. Of course, the password can't be displayed. Moreover, there is a password file in the location etc/shadow, which we're going to look at as we continue. The third field represents the user ID. Every user has a unique ID, right? And the unique ID for this user is 1000. The fourth column represents the group ID. Well, a primary group ID in RHEL, when a user is created, a group for that user is also automatically created, which has a ID too, and the primary group name is the name of the user. So in this case, the group ID too is 1000. All right. This field, the fifth field, represents a comment section or a jQuery. So that is if you create a user and you want to know the department of the user, for example, all right, you can just put finance. All right, so it's just the comment section for you to be able to easily identify the user. This field, the sixth field, right, is the home directory of the user, which is /home/Oluwatomisin. The home directory of a user is explained in the Learn Linux from Scratch series, where I took my time to explain the Linux file system hierarchy and structure. All right, so that's why I've said you should go through that series if you don't have fundamentals of Linux. All right, so the last field, which is the seventh field, represents the user's shell. In this case, the user's shell is bash. All right. And the command used to create a user, right, in Linux is user add. Now that we understand all of this, in the next video, we're going to look at how to create users in Linux. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to continue with our RHCSA 8 series and we're going to be talking about how to create users in Linux and password users in Linux. In the previous lesson, we've talked about the important fields in the etc password file. We looked at the password file and we looked at the attributes of that file. We looked at what jQuery is, what a user ID is, right? And so in this lesson, we're going to talk about how to create users in Linux and how to password users in Linux. We're also going to talk about how to change a user's password in Linux. I'm also going to talk about how to manage user's password expiration. Okay, so if I want to create the user Victor, for example, I'm going to use the command user add Victor. So let's check the etc password file again. All right, so you can see the username Victor. Okay, like I explained in the previous video, look at the attributes of this user. But what if, for example, in your organization, it's been said that you should give the user Victor a user ID? Then how do you go about it? You should know that you should always make use of help when working on Linux systems. For example, if you forget about commands and you need help, always refer to your man pages, or you can use the command user add hyphen help. All right. So when you look at these flags, you can see what each flags means. So this is the Jekyll's I talked about, right? This is used to create a field, right? A Jekyll's field for your user. Okay. And if you also want to create a user ID, right? Look at the flag here, which is hyphen U. Here you can specify a user ID for a specific user. So for example, let me create another user and let's specify the department of that user as well as the user ID. Okay, so if I'm going to create another user, say I'm going to create a user technique. All right, so I'm just going to specify the user ID. I can say user ID should be 20000, that's 20,000, for example. Okay, and also if I want to specify the J codes, I'm going to use the flag hyphen C. I'm going to say, let's say technique is in the IT department. And I can also specify a shell for this user. I can say, and the flag for a shell is hyphen S, right? So I can say bin slash bash, right? Okay, sorry, the technique should be here. This should all be in the middle, right? So I'm going to create this user technique. Okay, so let's check the password file again. We can see the user technique here. We've specified the user ID to be 20,000, which we have. Just as I've mentioned before, that when you create a user, there's always a primary group that is always created too, and it has the same ID as the user ID. So this is the primary group for TechNeed, right? And we've also specified the JCOS, which is IT, and this is the home directory, and this is the shell for this user. All right, so to password a user, you're going to use the command password. So if I'm going to password the user Victor, I'm going to use password Victor. I'm going to specify the password. All right. Oops. Okay, I'm going to retype the password to confirm. All right, so I've been able to create a password for the user Victor. Let me just clear the screen. To change the password for a specific user, we also use the same password command. All right. So for example, if I want to change the password for the user Victor, I'm just going to do this and it's going to prompt me to enter the new password, and I'm also going to verify the new password. Okay, so I'm not going to do this. So let's talk about how you can force a user to change their password in the next login, right? So for example, say you want to expire the password for the user Victor. Okay, you can use the this same password command, or you use the chage command. Okay, so let's use the password command. Like I've always told you, you can do this if you don't know the command, or if you've forgotten the command, you can always do this, or you use the man page. Okay, so if you look at all these flags, you can see the E flag, which says expire the password for the named account, and this can be done by a root user only. So for example, if I want to expire the password for the user Victor, I can do this, and then that means that the next time Victor wants to log in, Victor will be prompted to change his password. So let's also say Victor will be resigning on the 4th of January 2020, and I need to disable his authentication by expiring his password for that date. I can use the chage command, right? So to do this, I'm going to use this command, which means expire on this date. Okay, 01, all right, 04, that's 4th of January 2020. Okay, then Victor. All right, so this means that on the 4th of January 2020, Victor will not be able to log in into the system anymore. So in the next video, we're going to talk about managing groups, creating groups. We're going to talk about the primary and the secondary groups and how to manage groups in Linux. And you can also check the playlist for the RHCSA 8 dumps, right? I have, when you check the playlist, then you can look at some problems and then try to solve the problems. And that's if you're going to be writing the examination. And if you're also studying just to study and just to be an administrator without writing the examination, you can also check out the problems. It's very effective, you know, and that would tell you that you've actually learned and you know what you're doing. So thank you for watching and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I'm one of the authors of technique.com. Today we're going to continue with our course. We're going to look at how to create groups, add and remove users from a group in Linux. In our previous lessons, we've looked at how to create users and how to password users and expire a user's password. All right. So in Linux, there are basically two types of groups, and we have the primary group and the secondary group. So what is the primary group? Before I forget, if you're writing a Linux exam, all right, just scroll down to the end of this website. I'm going to be dropping the link to this website in the description section below. All right, so you can just pick the dumps, which is the practice question of the kind of exam you want to write. So, for example, this is RHCSA 8 dumps. All right, so we're going to be updating it with the LFCS dumps and the SUSE Linux practice questions as well. All right. Okay. So what is a primary group? When a user is created, a primary group for that user is also automatically created. So which is the same name used in creating the user. So, you know, in our previous lessons, we were able to create some users, and for us to be able to see the attributes of the users, we will check the etc password file. All right. So this is one of the users we created. This is a user Victor. So when this user is created, okay, automatically a primary group for this user too is created. You can see the user ID for Victor to be 1001. All right. So the group information is stored in etc/group file. Okay, so if you open this file, you can also see the group, which is Victor. So the primary group is automatically created and has the same ID, which is 1001, as the user ID Victor 1001. Okay, so when you create a user, okay, a primary group is automatically created also, and this is done for security purposes. All right. And no user can have more than one primary group. All right. So, like if you create the user Victor, is automatically a member of its primary group Victor. So no user can have more than one primary group, but users can have more than one secondary group. Okay. So let's look at what a secondary group is. All right. So a secondary group is the second, third, n group that is added to a user. All right. So in other words, the secondary group is the other group a user is added to. So the user Victor can be added to another group. For example, can be added to the group finance. That finance group will be a secondary group. The Victor can also be added to a group HR. You know, that's a secondary group that for the user Victor. So a user can be added to more than one secondary groups. So let's understand the group attributes. Let me just clear my screen. All right, so the group information file is found in the etc group file. All right, so you can see the group HR department. This first field represents the name of the group, all right, while the second field is the password field, all right, and the password can be found in a location etc shadow file. We're not going to look at that in this lesson. And the third field is the group ID, which is 2001. This is the group ID. And the fourth field, the fourth and the fifth this one, having the name Oluwatomisin and Victor. All right. So this field are the names of the users in the group. So like the Oluwatomisin is the user in this HR department group, while the another user, which is Victor, is also a member of this HR department. All right, so let's look at some groups and users management related commands. So for example, we have the group add command. This command is used to add or to create a group. Okay, so we also have the user mode command. This is used to modify users account and add users to a group. We also have the group del command. All right, so this utility is used to delete a group. We also have the user del command. This is used to delete a user from a group. We also have the password command, password command. This is used to password or change a user's password. We have the group mode command. This command is used to modify the group settings. And we have the new group command. All right. So this is used to log into a new group. Okay, so having understood the concepts and terminologies behind creating groups on Linux, so we're going to look at how to create groups and manage groups with examples in our next lesson. All right, so thank you for watching and please subscribe to this channel. Bye for now. Hi everyone. So welcome back to the second section of this video. So we're going to be looking at how to create and manage groups in Linux with examples. So don't forget that if you're writing a Linux examination, just scroll down to the end of this lesson. I'm going to be dropping the link to this website in the description section below. All right, so just click on the exams you want to write. So, for example, if you're writing the RHCSA 8 exam, click on the RHCSA 8 DOMS, which is the practice question. If you're also writing the LFCSA or the SUSE Linux exam, we're going to be updating it as soon as possible, so you can come to this website to click on the practice questions. All right. Okay, so to create the group finance, use the command group add finance. All right, so the group has been created. We can confirm in the etc group file. Can grab this to finance. So you can see the group created and the group ID to be 2002. All right, so you can also do this to see all the groups in this system. So you can see all the groups here and you can see finance as well. Okay. Now to add the user Victor to a group, this can be done in two ways. All right. You can use the user mode command to do that. So this is user mode. Don't forget, I've always told you to always use your hyphen up to get help on the system, or you use the man page to get up on the system. In our previous lessons, we talked about how to use man pages, right? So you go to the Learn Linux from Scratch, which is Linux tutorials for beginners to know all of this. All right. So to add a user rather, the first method is using the user mode command. So this is user mode, right? All right, followed by the A, which means add a user, followed by G, append, all right, or add a user, followed by G, which is the group, all right, followed by the name of the group, which is finance, then followed by the name of the user you want to add to the group, which is Victor, all right. So by doing this, you've been able to add the user Victor to the group finance. So you can see the user Victor added to the group finance. Another method you can use is to go into this group, right? When you go into this group, then you can add the user you want to add to this group by using the comma, and then specifying the name of the user. All right. For example, if I also want to add the user technique, I'm just going to do this. So there shouldn't be a space here. All right, so I'm just going to save the file, and then I've been able to add the group. All right, the group technique to the, the user technique to the finance group. All right, so if you also want to remove a user from a group, this can also be done in two ways. The first way, just as we added, okay, let me just quit this. The first way, just as we added the name, the user to the group, all right, you can also do that by removing the user from the group. So for example, if I want to remove the user technique, I'm just going to do this, and I'm going to save the file, all right? Then I've been able to remove the user technique from the group finance. All right, so the second method to use is use the G password command, all right? So this is going to delete the name Victor from the finance group. All right. So that has also been removed. If you do this, you can see that no users are in this group anymore. All right. So also to create a group with a desired group ID, yes, you might want to create a group with an ID rather that you don't want the system to automatically give you an ID. So what you need to do is to use the command group add. Oops, sorry. Group add, then followed by the group ID. You can call it, for example, 49, whatever ID you want to call this. Then I can just give it an IT group, for example. All right, so if I do this, so you can see the IT group with the user ID, with the desired user ID. If you want to change a group ID, for example, the group finance ID, all right, you're going to use the command group modification or group modify, followed by the ID -G, then followed by the ID. Let me see, for example, 242424. 343434. Then followed by the group, okay, finance. Oops. So I can see what. Okay, so it should be small g. All right, should be this. All right, so let's confirm. So you can see that we've been able to change the group ID for finance. To know the group ID a user belongs to, you can just use ID. For example, ID Victor, which will tell you the groups Victor belongs to. So for example, you can say that Victor belongs to Victor, all right? And Victor also belongs to the HR department group, okay? So to change the primary group ID for a user, you're going to use the command group mode, all right? All right, so -G, let me say 422 Victor. Okay, so let's see ID Victor. So you can see that I've been able to change the primary group ID for the user Victor. This is the same way you also change a secondary group ID. All right. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor, and I'm one of the authors of Technique.com. Today, we're going to continue with our course, and we're going to be looking at how to set and manage permissions in Linux. All right, so permission is very important in any operating system operation. As an administrator, you will always want to safeguard the system against attacks, both externally and internally, and as well protect the system from accidental occurrences such as deletion of critical files or running of critical scripts that can break the system. So you need to be very conversant with permissions in Linux to do that. And also, as the owner of a file or member of a group, you may also want to grant different kinds of permissions to your files. All right. So in Linux, every file has an owner and a group owner as well. So to fully understand how permission works in Linux, let's look at the attributes of a file. Okay, so let's look at the file etc tab. Let's use -r. Okay, so you can see this file, and when you see a file like this, the first line of the file, this dash means that this file is a file. So what I mean is, if you see a D, it means it is a directory. So if I list, for example, if I do this, we can see directories and files. So the first line means it is a directory, while if you see dash, it means it is a file. All right. So we're looking at the fs tab file. So the second line, let me just go back to the website so I can show you clearly. The second line, second, third, fourth, fifth to the end represents permission, and they are grouped into three. So if you come here, you can see here where my mouse is. So you can see the read, write, and the dash, which means nothing, right? We also have that's grouped into the 1 2 3 is the first group, right? Then the 4 5 6 here, dash r dash, sorry, r dash dash, that's read nothing nothing, is also grouped, is also a group on its own. While the 7 8 9 read nothing nothing is also a group on its own. So the first group means user. So it means that it means the user permission. Sorry. So if you have read, write, execute, for example, it means the user can read, write, and execute. So in this case, we have read, write. So the first group means that the user can only read and write. You understand? And the last line, they cannot execute because the execute line is nothing, right? So the user of this, the owner of this file can only read and write. All right. So the second group, which is 4 5 6 here, means that it represents the group owner of the file. So it means that the group owner of this file can just read, cannot write and execute, right? Because that is dash dash. And the third line here means that others. The third line means others. So other people that will be accessing this file, they can only read, they cannot write nor execute. So I say again, first group means user, second group means group, while third group means others. So you can just use the acronym UGO, all right? That's a name actually in my country, UGO. So UGO, all right? And how do you know the owner of a file and the group owner of a file? So when you check here, you can see that the next line after the permission will show you the owner of a file, which is root here, and the next line after the owner of the file will show you the group owner of the file, which is root also. So the owner of this file is root, the group owner of this file is also root. So you can see it here, number 10, that's the owner, while the group that owns the file is number 11, that's root. All right. Okay, quickly, if you're writing the RHCSA exam or the LFCS or the SUSE Linux exam, you can scroll down to the end of this website, then you can come and click the practice questions of the exams you want to write. All right, and we're going to be updating the website from time to time. Okay, so in the next video, we're going to look at how to change file permissions in Linux. Thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the second section of this video we're going to be looking at how to change file permission in Linux. All right, and if you're going to be writing the RHCSA or the LFCS or the SUSE Linux exam, just scroll down to the end of this website and come and click on the practice questions of the exam you want to write, just to practice before writing the exam. We're going to be updating the website from time to time. You can also click on the class activity after you're done with this study, with this lesson. All right. So I'm going to be dropping the link to the website in the description section below. When a directory is created in Red Hat 8, by default, the user will have read, write, and execute permission. The group and others will have read and execute permission only. So let's do that and let's see. All right. So you can see that the user will only have the read, write, and execute, while the group owner and others we have read and execute permission only. So this means that the owner of the file can do whatsoever they wish to do, while the group owner of the file and others can only change directory into this directory. They can also list the content in this directory. They can view the content of the files in this directory, but they cannot edit the content of this file, of this directory. So for a file, let's create a file. For example, just do search technique. All right. So for a file, let's list this file. So you can see that when a file is created, by default, the user would have the read and the write permission only. All right. Then the group and others, we have read permission only. So this means that the user can read and edit the content of the file, but cannot execute the file. So for group and others, for the group owner and others, it means that they can read or view the content of the file, but they cannot edit or execute the file. All right. So if you've not been doing this often, and when you set a file, a permission on a file or a directory, it's advisable you do a test so you can be very sure about it. For instance, a read and write permission only on a directory doesn't mean that the group owner of the file will be able to cd or change directory into the directory, let alone edit the files in the directory. So let's see what read only, write only, and execute only permission do before we start changing the permission of a file. So when you have a read only permission in Linux, all right, for the owner of the directory, which is the user, the group, and others, it means that they cannot change directory into the directory, and listing the directory also won't display the whole directory attribute. It will only display the file name. You can try that. All right. So a read only permission on the file for the user, the group, and others, it means that they can view the content of the file, but they cannot edit it. All right. So let's talk about the write only permission of a file. So the write only permission on a directory for the user, group, and others, it means that they cannot change directory into that directory, and they cannot even list the content of that directory at all. So for a write only permission on a file, for the user, group, and others, it means that they can view the content of the file as well as even edit the file. So for the execute only permission in Linux, all right. So for on a directory, for the execute only permission on a directory, for the user, group, and others, it means that they can change directory into the directory, but cannot list the content of that directory at all. And for execute only permission on a file, for the user group and others, it means that they cannot even view the content in the file at all. So you can just create the file and create a directory and try all of this. In the next class, we'll look at the command that is used to change permission. All right, and we're going to look at changing permission in absolute and symbolic mode. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, welcome to the third section of this video. We're going to look at how to change permission in Linux using the absolute mode. Alright, so the command that is used to change permission in Linux is the chmod command. Alright, so let's understand the absolute mode. So the R means read and it has the number 4. The W means write and it has the number 2, while the X means execute and it denotes the number 1. So whenever you use the number 4, it means read. Whenever you use the number 2, it means write. Whenever you use the number 1, it means execute. And so you can also sum up these numbers together. So for example, if I have 4 plus 2 plus 1, which is 7, so that means you are given a permission of read and write and execute. So if you also have 4 here plus 2, which is 6, that is a read and write permission. If you have 5, the number 5, if you had 4 plus 1, that is 5. So that means you have a read and an execute permission. And if you have the number 3, 2 plus 1 gives you 3. So that means you have a write and an execute permission. And if you have number 0, 0 is nothing. All right. So number 7 means read, write, execute. 6 means read and write. 5 means read and execute. 4 means read. 3 means write and execute. 2 means write. 1 means execute and 0 means nothing. So that's why you always see the letters on the attributes of a file like RWX, which is read, write, execute, RW dash, which means read and write only, then R dash X, which means read and execute only, then R dash dash, which means read only. So you can use this table. I've been able to come out with the table. I'm going to be posting a link to this website in the description section below if you want to look at this table. It will give you an insight of how to use how to how to set the permission using the absolute mode. All right. So let's see an example. So I have a file called Amazing Love. All right. So you can see that for the owner of the file, which is the user, it's read write permission only. Then for the group, read permission only, and for others, read permission only. So for example, now to give the user, group, and others full permission, which means that if I'm to give the user, group, and others read, write, and execute permission, what I'm going to do is to use the command chmod, which is used to change permission. All right, so we've ascertained that 7 means read, write, and execute. So I'm giving the user read, write, and execute. I'm giving the group read, write, and execute, and I'm giving others read, write, and execute. So that's chmod 777 on the file Amazing Love. Then I'm going to press my enter key. So let's look at the file again. You can see now that the permission of the file has changed. There's read, write, and execute for the owner of the file, which is user. Don't forget, in the first video, I mentioned UGO, which is an acronym that you can quickly use to remember. So for the user, you have read, write, and execute. For the group, you have read, write, and execute. And for others, you have read, write, and execute. So and you can see that the file has even changed to green. Okay, so let's do another one. Let's let's give the user read, write, and execute permission. All right. Let's give the group read and write permission, and let's give others nothing. So we don't want others to have any permission. So what we're going to do is to use the command chmod. All right. So we're giving the user read, write, and execute, which is 7. We are giving the group read and write permission only, so which is 6. If you look at the sheet I showed to you, 4 means read, 2 is equivalent to write. So if you add 4 plus 2, that is 6. All right. And for others, we are saying we're giving them 0. All right, which is nothing. So on the file, Amazing Love. All right. So let's look at the permission again. You can see that the permission has changed. For the group, we have the read, write, and execute. For for the user, we have read, write, and execute. For the group, we have read, write only. All right. Then for others, we have nothing. They don't have permission. They don't have anything, so they cannot do anything on the file. So this is how you change permission using the absolute mode. Next video, we're going to look at how to change permission using the symbolic mode. All right. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, welcome to the fourth section of this video. We're going to look at how to change permission in Linux using the symbolic mode. In the previous video, we've looked at how to change permission in Linux using the absolute mode. All right, so permission in Linux can be changed using symbols, and if you see the symbol U plus R, so U plus R means you're giving a user, which is the owner of the file, a read permission. All right, so if you use U minus R, which means that you're removing the read permission from the user. All right, so if you use the U plus W, it means that you're giving the user a write permission. If you use the U minus W, it means you're removing the write permission from the user. The same thing as the execute permission. The plus sign means you're giving the permission to a user. If it is you, of course, then the minus sign means that you're revoking the permission from the user. And don't forget that in the first video, we mentioned the acronym UGO, U which stands for user, G which stands for group, and O which stands for others. So for the group also, if you're using the plus sign and you're using the R, it means that you're giving the group a read permission. And if you're using the minus sign, it means you're revoking the read permission from the group. All right, so the same thing is applicable to others as well. So let's look at example of how to do this. So for example, let's look at the file Amazing Love. All right, so you can see that the file for the user, we have the read, write, and execute permission. For the group, we only have the read, write permission, and for others, we have nothing. So, for example, to give the user, group, and others full permission, that is to give the read, write, and execute permission. All right, so using the symbolic mode, we use the command chmod. Then U, which means user. All right, just as we've said, plus read. Okay, so I can do plus read, then the name of the file, you understand, or I can just do this all at once, read, write, execute, and I can use the comma sign. All right, and say group. Also, I also want to give the group read, write, and execute, and I can also do comma and O, which means others, plus read, write, execute, and the name of the file, which is Amazing Love. All right, so if I list the attributes of the file, you can see that the permission has changed, and we have the full permission for user, group, and others. Don't forget, I can say U minus R Amazing Love or U minus W Amazing Love, but I've just decided to use all at once here. Okay, so let's see another example. To give the user read, write, and execute permission, and to give the group read and write permission only, and to give others nothing. So we use the command chmod. All right. So the user, we're giving the user read, write, and execute permission only. All right. And we're giving the group the read and write permission only, and we're giving others. All right, we're revoking others. We're giving others nothing, so that means we're revoking the permission read, write, and execute. and the name of the file, which is Amazing Love. So let's see again. So you can see that the user and the group all have read, write, and execute permission, while others have nothing. All right. So using the symbolic mode can be relative. Always check the file permission before changing the permission. All right. So some files you need to use the minus, which is the negative sign, while some files you need to use the plus sign. All right. So this is how you change file permission using the symbolic mode. Thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the fifth section of this video. We're going to look at how to change the user and group ownership of a file. In the previous video, we've looked at how to change the permission of a file using the absolute and the symbolic mode. Alright, so quick one, if you're going to be writing the RHCSA or the LFCS or the SUSE Linux examination, just scroll down to the end of this website and come and click on the practice questions on the dumps of the exam you want to write. We're going to be updating the website from time to time. Okay, so let's talk about changing the ownership of a file. Let's look at the file Amazing Love. So you can see that the owner of this file is root, and the group that owns this file is also root. So let's change the owner of the file. To change the owner of a file, you use the command chown. All right. So if I want to change the owner of this file from root to Victor, so I'm just going to use the command chown, then Victor, followed by the name of the file. All right. So let's see the attribute of the file again. So you can see that the owner of the file is now Victor. To change the group ownership of the file, you use the command chgroup, that's chgrp. All right. So if I want to change the group owner of this file from root to, if I want to change it to finance, for example, I'm just going to use the command chgroup, then the name of the new owner of the group, which is finance, then followed by the name of the file, Amazing Love. So if I check the attributes of the file again, so you can see that the group owner of the file has changed to finance. So this is how you change the owner of a file and the group owner of a file in Linux. So thank you for watching. Please subscribe to this channel. And in the next video, we're going to look at special permissions in Linux. Bye for now. Hi everyone, welcome to the sixth section of this video. We're going to look at the special permissions in Linux. In our previous videos, we've looked at file permissions, we've looked at the absolute way of changing permissions in Linux and the symbolic way. All right, so there are other advanced permissions other than the read, write, and execute permissions, and they are the set user ID. We also have the set group ID, which is the SGID, and we also have the sticky bit. So let's start with the set user ID. When you set the permission set user ID on a file, it means that any user can have the execute permission on the file and can run the files as their own. So on the contrary, if you set the set user ID on a directory, it doesn't have any effect on a directory. So for example, let's look at the file Amazing Love. All right. Using the absolute mode, you can use the number 4 to set the set user ID permission. And if you want to use the symbolic mode, you can use the alphabet S to set the SUID permission. All right. So for example, to set the set user ID permission on this file Amazing Love, you use the command chmod. We're using the symbolic mode. All right. So set user ID, which is the SUID, of course, user plus the alphabet S on Amazing Love. All right. So let's look at the attributes of the file. So you can see that the file has turned to red. And when you look at the file also, when you look at the user permission, you can see read, write, and S. So when you see this letter S, it means that this file has been set to the set user ID permission, and any user can run the files as their own. The set user ID permission, which is the SUID, is a very dangerous one in Linux. So you should be very sure you really know what you're doing before using it. Okay, so let's look at the set group ID permission. So when you set the permission set group ID, or in short form SGID, all right. So if you set the permission SGID on a file, it means that every member of the group have execute permission on that file and can run the file as theirs, as their own. All right. So if you use the SGID permission, I mean, if you set the SGID permission on a directory too, so it means that every group member will inherit the ownership to a newly created files in that directory. The set group ID is mostly used in a shared group environment. The SGID permission can be set using the absolute mode with number 2, or you can also set it using the symbolic mode with the letter S as well. So for example, to set the SGID permission on the file Amazing Love, you use the command chmod G, which is this SGID plus S on the file Amazing Love. So let's see the attribute of the file. So when you look at the group part, you can see that the permission here has changed to S. So you've been able to set the permission to SGID. So every member of the group have the execute permission on this file and they can run it as theirs. As I've said, if you set this permission on a directory, it means that every group member will inherit the ownership to a newly created files in that directory. So when you create a file in that directory, every group member will inherit the ownership. All right. So let's look at the third special permission, which is the sticky bit. On a file, the sticky bit permission doesn't have any effect, all right? But on a directory, it means that only the owner of the files in the directory can delete the files or the directory itself. So what it does is to prevent other users in a group from deleting the files they don't own. To use the absolute mode to set the sticky bit permission, use the number 1, and to use the symbolic mode to set the permission, use the alphabet T. So for example, to set the sticky bit permission on the file, all right, it doesn't have any effect on the file. So let me make a directory. For example, let's just say directory technique. All right. So to set the sticky bit permission on the directory technique, you use the command chmod plus the alphabet T. All right. Then technique. Okay, so before I do this, I want you to see the attributes of the file first. Let's do this. All right, so you can see the attribute of the file. So now let's set the permission, and so you can notice the changes. All right, so let's see the attributes again. So you can see here that the letter T has been added. So that is to show you that the sticky bit permission has been set on a directory. The T here at the end of this file, where my mouse is. All right. So every files in this directory can only be deleted by the owners of the files and not by anyone else. Of course, the root is the super user which can do anything. So these are the special permissions in Linux. Quick one, if you're writing the RHCSA or the LFCS or the SUSE Linux exam, just scroll down to the end of this website. I'm going to be dropping the link to the website in the description section below, and come and click on the RHCSA 8 dumps or practice questions. We're going to be updating the website from time to time. You're going to see the SUSE Linux dumps and the LFCX dumps also. All right.
So thank you for watching. And in the next lesson, we're going to look at the ACL in Linux. So please subscribe to this channel and bye for now.
Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course. We're going to look at how to manage ACL in Linux. All right. In our previous lesson, we when we talked about permissions, we noticed that setting permission has focused on giving permissions only to one user, which is the owner of the file, and to one group, which is the group owner of the file. But what if you want to give permissions to more than one user or groups on a file or a directory? Or what if you want to give permission to a user that is not a member of a group? How do you achieve that? So we use ACL to achieve this. ACL is in full terms is access control list, all right? And with ACL, you can give permissions to more than one user or groups that are not owners of the file in Linux. So ACL is just an advanced permission mechanism in Linux. Quick one, if you're writing the RHCSA exam or the LFCX exam or the SUSE Linux examination, you can scroll down to the end of the website and come and click on the practice questions, which is the dumps of the exam you want to write. We're going to be updating the website from time to time, all right? And I'm also going to be dropping the link to the website in the description section below so that you can easily click on the link and follow through.
The Linux kernel must support ACL before ACL can be used, all right? There are some old Linux kernels that doesn't support ACL, but the new Linux kernels, they all support ACL. So to verify if your kernel supports ACL option, you can use the command. So let's do this. I just want to grep for ACL. All right, so you can see ACL to be yes. So you can see ACL equals Y, ACL equals Y. All right, so that means that the ACL support, the kernel supports ACL. If you see N, which is no, then the kernel doesn't support ACL. You should also know that using ACL requires that the file system where permissions will be set is mounted with ACL options. There are some file systems that are mounted with ACL options by default, like the EXT2, EXT3, 4, BRT, FS, and etc. Those file systems are mounted with ACL options. But if your file system is not mounted with ACL options by default, you would need to mount the file system with ACL option before you can use ACL. And to verify if a file system is mounted with ACL option, you use the command. Let's look at the blocks we have. All right, so let's verify if the SDC is mounted with ACL option. So use the command tune to fs on SDC. I'm just going to group for default mount options. All right, so you can see that the device SDC is mounted with ACL option. If the device is not mounted with ACL option, this is how you're going to install the ACL utilities in Linux and mount the file system with ACL options. All right. So since we're using a Red Hat 8 system, and of course most of the file systems is mounted with ACL options by default, we're not going to look at this here. But if you want to know more about this, you can just come to this website to learn about it. I'm going to be dropping the link to the website in the description section below. There are two commands that are used to manage ACL. They are the get FACL command and the set FACL command. The get FACL tool is used to get an overview of an access control list on a file. So, for example, let's get the access control list for the file. Let's do for pictures, for example. So you can see the overview of the access control list on the file pictures. And it is also possible to view the permission of a file using the get FACL command. Just as you use the ls-l command,
All right. The get FACL will display the file permission that is set with ch mode and the file permissions that is set with ACL. While the set FACL command is tool or command is used to set or change the access control list on a file. So in the next video, we're going to look at how to use the ACL options and how to set permissions for users, groups, and others on files and directory using ACL. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, welcome to the second section of this video. We're going to look at how to set permissions for a user on the file and directory using ACL. Alright, so we're going to start with a file first. And quick one, if you're writing the LFCS exam or the RHCSA exam or the SUSE Linux exam, just scroll down to the end of this website and click on the DOMs or the practice questions of the exams you want to write just to practice before writing the exam. I'm going to be dropping the link to the website in the description section below so you can click and follow through. And we're also going to be updating the website from time to time with the practice questions. So let's look at this file. All right, so you can see that the owner of this file is root and the group owner of this file is also root. So if you have a user, another user which is technit, if you want to give that user a read and execute permission on this file, just as we've said in the previous video, you use the set FACL command. All right, so to do that in this case, we use the set FACL command. But then, how do we use this command? If you have been following me through my series, if you're a tech leader, you would know that we always do this to check how to use a particular command. So you can see the flag -m, for example, it says it is used to modify the current ACL of a file. But then, how do we fully use this command? So let's look at the man pages or the man page for the set FACL command. So let's just look at the examples. All right, so you can see how set FACL can be used. This says granting an additional user read access. So this is the command set FACL with the flag -m modify with the U, which means the user, and the user here is Lisa, and they're giving the user read permission on a file. So let's just copy this. Right, so I'm just going to paste this. So I'm just going to do this. So to give the user technit a read and execute permission on the February 6 file, I'm going to use the command. First of all, let us verify the current permission on the file. We can do ls-l February sales. So you can see, you can also use the get FACL command just as we said. So you can see that, of course, the file is February sales, the owner is root, the group owner is root, and these are the permissions. The user permission is the read, write, and dash, so just the read and write permission. For group is just the read permission, and for others is just the read permission. So to give the user technit the read and execute permission on this file, we're going to use the command set FACL. So I'm just following this. All right. Set FACL, modify the user. All right. Then the user is technit, followed by the permission read and execute, then followed by the name of the file, February sales. All right. So let's do get FACL again. So you can see now that we have the user technit with the read and execute permission. If you also do ls-l on this file, you can see the plus sign, which means that you've used the ACL option on this file.
So I'm just going to mention one thing here, especially for those that are writing the examination. If you're going to be using the ACL, it's better you have set all your permissions first before finally setting the ACL permissions. Though you can set ACL permission first before setting your permissions, but then it can cause a disorder of permission settings on the file. So why would you want to waste your precious time and effort if you can avoid it? So I'm going to advise you set your permissions first using the chmod command, and then after you're sure about setting your permission, come and use the ACL options to set the ACL permissions. Okay, so let's see another example. Let's give the group finance read and write permission on the February sales file. So as usual, we check the file, the permission on the file, right? So we want to give the finance group the read and write permission on this file. So we use the command, just as I've told you that you should always check your man pages, right? So this time around for the group, we use the command. Let's just edit the one that we've done before. So this is going to be set FSL modify. Then instead of user is going to be a group, and which group are we giving the permission to? Is going to be finance. All right, and we're giving the read write permission to finance on the February sales file. Let's see again. So you can see that the group finance now has the read write permission on the February sales file. What about others? So to give others a read and write permission on the February sales file, just the way we've been doing it as usual, we're going to use the command set FACL. So this time around, instead of the group, it's going to be others. So we're just going to specify other, and this time around, it's going to be a read write permission on February sales file. So let's do get FACL. So you can see that others have the read write permission on this file. So this is how you're going to set the ACL permissions in Linux. And in the next video, we're going to look at how to completely deny access for a user or a group on a file using the ACL. All right. So thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, welcome to the third section of this video. We're going to look at how to completely deny access for a user or a group on a file using ACL. We're also going to look at how to remove ACL from a specific group or user. All right. We're also going to look at how to remove ACL default entries from a file or a directory. And finally, in this video, we're going to look at how to remove all ACL entries on a file. So we're discussing about file first. So this should be from a file, all right? Okay, so quick one, if you're writing the RHCSA exam or the LFC or the LFCS exam or the SUSE Linux examination, just scroll down to the end of this website and click on the practice questions or the DOMS of the exam that you're going to be writing. We're going to be updating the website from time to time, all right, with the practice questions, and I'm going to be dropping the link to the website in the description section below for easy access. In our previous video, we've looked at the file, February sales file, and we've been able to give the technique user some permissions on the file. So we're going to look at how to remove the read, write, and execute permission on the February sales file for the technique user. All right. So to do that, you're going to use the set FACL command, first modified in the user, just the same way we've been doing it, technique. All right. So this time around, we want to remove both the read write and the execute permission. So we're just going to use the dash. That means we don't want any permission for the technique user on this file. We are denying access for this user. All right. Then followed by the name of the file, February sales. Then we're going to press the enter key. All right, we're having an error here. Oops.
So we need to put the colon here. Another error. Okay, sorry. The column needs to be here, and we don't have to put a space between the column and the dash. Okay, so let's now verify with the get FACL command. So you can see that the user technique does not have any permission. All right. Also, let's see another example. To remove all the ACL entries from a user, for example, to remove all the ACL entries from the user technique, let's use this option and see if you can see the flag here. So we can see the -X flag which says remove entries from the ACLs of files. Let's get to see the manual page as well. And the examples. So you can see here removing a named group entry from a file. All right, this is for a group. So we don't have for user here, so of course we can copy this. All right, we can just paste this here, and we can do this set FACL by removing all ACL entries from a user. All right, so the G will replace it with the U, which is a user, followed by the name of the user, which is technique. All right, followed by the name of the file. So let's use the get FACL command again. So you can see that we don't have the user technique here anymore. So we've been able to remove all the ACL entries from the user technique. We can also do that for the group. In the previous video we did for the group finance. Of course, we still have finance here. So let's remove all the ACL entries for the finance group. So what we're going to do is to replace this with G and then the name of the group. So let's see get FACL. So you can see that we've been able to remove all ACL entries from the finance group. All right. So let's see how to remove the ACL default entries from a file or a directory. Let me just clear my screen. ACL are of two types. We have the access ACL and the default ACL. The default ACL can only be effective on a directory, and the default option on a directory will allow the ACL permissions set to take effect on the new content, files, and directories that will later be created in that directory. So what I'm saying is that the new content that will be created in that directory where the default options is allowed, all right, will inherit the ACL permission. So, for example, to remove all ACL default entries from the statistics directory, we use the command set FACL -K, then the name of the directory, which is statistics, and this will remove the default entries. You can use the set FACL -up option to look to see the flag that is going to remove the default entries. All right, you can see the -K option here that says remove the default ACL entry. Okay, so thank you for watching, and in the next video we're going to look at how to use ACL on directories, how to set permissions for a user on a directory recursively, and we're going to see everything that we can do with ACL on a directory. Okay, thanks again, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the fourth section of this video. We're going to look at how to set permission for a user on a directory recursively using ACL. Using the ACL to set permissions on a directory most times require that you use the recursive and the default option. So the current items, that is the files and directories, will inherit the permission that is set when the recursive option is used, while the new items, that is the file and directories that will later be added in a directory, will inherit the permission that is set when the default option is used. So to give the user technique the read-write permission on the statistics directory recursively, you're going to use the command set. Okay, let's verify the permission. So you can see the permission. You can also use the get FACL command. All right, so to give the user technique read and write permission on the statistics directory recursively, you're going to use the command set FACL -r modify. The R is for recursive, right? Then name of the user, the technique, and the permission, which is read write, and the name of the directory, which is statistics. All right. So let's verify the permission again. You can see the plus sign just as we've said, meaning that ACL option is used on the directory. And if you use the get FACL as well, you can see that the user technique has been given the read write permission. So whatever items I have, the files and directories, they will all inherit the permission that is set for this user. All right. So if I also want the new items that will later be added, that is the new files and directories that will later be added in this directory to inherit the permission, I'm also going to use the default option. So to use the default option, I'm going to use the command set FACL modify. All right. And the default, oops, so this needs to be here, column needs to be here, and user. All right. So I've been able to set the default option. Okay. So let's see another example. To give the finance group the read and write permission on the statistics directory recursively, all right, we're going to, of course, use the command, the set FACL command. So it's going to be this time around the group in finance, followed by the name, followed by the permission, which is read write permission. All right. So let's do get FACL. So you can see that the group here, the finance group, has been given the read and write permission. Okay. So this means that the current items, that is the files and directories, will inherit the permission that is set. All right. So to allow the new items, that is the new files and directories that will later be added in this directory to inherit the permission, we need to use the default option. So basically, you need to always run this command twice, that is the recursive option and the default option when you're working with a directory. So just the same way we did for the first run. So we're going to use the finance group, and the group, this one will be G. All right, for the default option. So let's see the get FACL. So you can see that the default options have been set for the finance group on this directory. In the next video, we're going to look at how to remove all ACL entries on a file or directory, and how to remove all ACL entries on a directory recursively. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the fifth section of this video, which is the last section. We're going to look at how to remove all ACL entries on a file and directory and how to remove all ACL entries recursively on a file and directory. Quick one, if you're going to be writing the RHCSA exam or the LFCS exam or the SUSE Linux exam, just scroll down to the end of this website and click on the DOMs or practice questions of the exams you want to write. We're going to be updating this website from time to time with the practice questions. All right. And I'm going to be dropping the link to the website in the description section below so that you can easily access the website. So let's use the -help command to see the flag to remove all ACL entries from a file. So you can see the -B option which says remove all extended ACL entries. So to remove all ACL entries from the February sales file, use the command set FACL. All right, that should be on the February sales file. So this will remove all ACL entries on the February sales file. So let's use the get FACL command. Okay, so you can see that all ACL entries have been removed. All right, so to also remove all ACL entries from all ACL entries on the directory recursively, all right, you use the command -b and -r. So for example, to remove all ACL entries from the statistics directory recursively, use the command set FACL -b, then -r on the statistics directory. All right. So if you use the ls-l in this directory, okay, it's a directory. So you can see that the plus option is gone. All right. And if you also use the get FACL on this directory, so you can see that all ACL entries have been removed, or and even recursively, all have been removed. All right. So thank you for watching, and I'm going to advise you that you go through the practice questions. There are a lot of questions in there, over 10 questions on, yeah, I think over 10 questions on permissions, users, groups, and permissions. So you can just go through them, practice them, and make sure that you understand. All right. So thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at software installation in Linux part 1. Alright, so installation in Linux is quite different from software installation in Windows. In Windows, most times you will have to download an executable file that is .exe and specify an installation path to install a software. However, software installation in Linux requires using a software repository most of the time and a package manager. Anyway, sometimes you can also download a package, an RPM package, but most of the time it requires using a repository and a package manager. So what is a package manager in Linux? A package manager is a software program. It's an application to itself that is used to manage software in Linux systems. So the package manager can help you to download, it can help you to update, search, and delete packages as it deems necessary on the system. So I'd like to differentiate between the software and the package manager before I continue. All right. So to better explain this, I'll be using the Windows operating system as a comparison. In Windows, if you want to install Office 2016, for example, you'll have to click on the Office 2016 and click on the setup file, which is the executable file, right, to be able to install. So you can see that this is the executable file. So to be able to install a software, all right. So in Linux, this executable file too can be compared to as a package, all right, or the folders that comprises of the executable file. So, like for example, this Office 2016 has some files and directories in it that is also embedded in the software to make the software work. So in Linux also, a package can contain all the necessary binaries, codes, programs, configuration files necessary to install a software. More importantly, a package in Linux contains information about dependencies. So as we go on, we'll look at what dependencies are. In Windows, most times you say things like, can you please install the SQL software? Also, similarly, in Linux, you can say, can you please install the SQL software, which is something like, can you please install the SQL package? All right. So, to a large extent, one can technically say that a package is also a software. And for a package manager, just as we said, and as the name implies, a manager, it is used to manage a package. A package manager can manage a package by using an automation process of automatically downloading dependencies for the software. So as we go on, we'll look at how we can use a package manager to manage a package. All right. So quick one, if you're going to be writing the RHCSA or the LFCS or the SUSE Linux exam, just scroll down to the end of the website and click on the exam DOMS or the exam practice question of the exam you want to write. All right. So we're going to be updating the website from time to time with the exam practice questions. So let's look at what dependencies are. Dependencies are other programs that a software depends on to run on or function. So one thing you must know about Linux is that some dependencies may depend on some other dependencies, and some other dependencies may also depend on some other dependencies, and some other dependencies may also depend on some other dependencies, thereby making installation complex. So before the existence of a package manager, installation in Linux has been a hell and frustrating. As a matter of fact, the complexity of dependencies has discouraged a lot of Linux users in those days from using Linux. So thank God for Package Manager. The advent of Package Manager has solved this complex problem by automating the download of a package where it automatically downloads and updates dependencies for a package to be installed. So every package comes with a metadata which the package manager uses to automate the download and update of the dependencies. So we will look at how this package manager, how it downloads dependencies as we go on in this course. All right. So another concept you need to understand is a repository. So what is a repository in Linux? A repository, or rather, a software repository, is a central server that stores most software or packages, as you might call it. All right. And a repository can be compared to a Google Play Store, for example. When Android users need to install the software, they go to the Play Store to download and install the software, same as Apple Store for Mac users. So, as mentioned before, software installation in Windows is different from software installation in Linux. All right, so in Linux, the package manager most times does installation by getting the packages to be installed from a repository, right? And every Linux distribution have their default official repositories and they are available online, all right? So how would the package manager go into the repository to pull packages alongside its dependencies for installation? All right. So one thing you must know also is that a repository can't be hosted on a Linux system except maybe you configure a local repository, which we're going to also do as we continue. All right. So how is it even possible for a Linux system to host a repository that contains thousands of software? All right. So what drive size on your Linux machine will have to do, will you have to provision to do all of that. So that's why every Linux distribution have a repository configuration file added to the package manager, which is a directive of the official repository online. So for example, for Red Hat Enterprise Linux, the repository configuration file for yum package manager is the etc yum.repos.d. All right, so let's go to that directory. So this is a repository configuration file. This is the one for Red Hat, while this is the one that I locally configured on the system. You should also know that some packages that you may want to install may not be in your Linux distributions repository. In that case, you will need to download the software from another site and install the software on your Linux system, or you add a third-party repository to your package manager. So the repository could be from another distribution or entirely from the community. All right. I mean the community repository. So whichever, be very sure of the third party repository that you want to add to your package manager so you will not be a victim of viruses and malware attacks. In the next lesson, we'll look at the types of package manager we have. Alright, so thank you for watching and please subscribe to this channel. Bye for now. Hi everyone, welcome to the second section of this video. We'll be looking at types of package manager, alright? In the first section, we looked at software installation in Linux. We looked at what a package manager is, right? And what a package is, we're able to differentiate between both. We looked at what the repository and dependencies are, alright? So there are different types of package manager in Linux. And every Linux distribution have their own package managers. So for Red Hat Enterprise Linux and Saint OS, their package manager is the Yum, and we also have the DNF for RHEL 8 now. All right, and for Debian systems and Ubuntu's and their likes, the package manager is APT, and for Arch Linux, the package manager is PAC-Man, right? And for OpenSUSE, the package manager is Zappa or YAST. All right. So let's talk about the DNF package manager. We're talking about the Red Hat Enterprise Linux 8. So the new package manager for Red Hat Enterprise Linux 8 is the DNF package manager. All right. The DNF package manager is known as Yum version 4. It's a newer version of the Yum package manager, which is Yum version 3, right? And installing with Yum on RHEL 8 and CentOS 8 as a way of ensuring that installation is done using the DNF package manager. And DNF has better dependency resolution compared to Yum. And it can also integrate with the Yum package manager as for RHEL 8, all right? So what is RPM? RPM is also a package manager in Linux, right? So before the Yum and the DNF package manager, the RPM package manager was the former package manager that was used, but it doesn't do automation, right? And like in downloading and pulling of dependencies as Yum. So RPM, which also stands for Red Hat Package Manager, will only install softwares with the RPM format. All right. So to learn more about the Debian systems and Ubuntu's and the likes, you can come to this website to learn that. I'm going to be dropping the link to this website in the description section below, right? So we are concerned about Red Hat because this is the RHCSA 8 course, so we're concerned about the RPM package manager, the Yum package manager, and the DNF package manager, most especially the DNF package manager, which is the recent package manager in Red Hat 8 systems. In the next lesson, we'll look at the examples, we'll look at how to use the DNF and the Yum package manager. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our RHCSA 8 course and we're going to look at how to configure Yum local repository on Red Hat 8 system. Alright, in our previous lesson we talked about software installation in Linux part 1 and we looked at what a repository is and what the package manager is. We also looked at what dependencies are, all right? So, and at the end of the class, I said that in the next class, we're going to look at how to use the DNF package manager and the Yum package manager, all right? And this is actually the class I was supposed to go to now, which is software installation in Linux Part 2, where we're going to talk about how to use the Yum Package Manager and DNF Package Manager. So, for example, now to use the DNF Package Manager or the Yum Package Manager to install a software in Linux, you're going to use the command. Let me just pull up the system so I can show it to you. So you're going to use the command, for example, yum install or DNF install, whichever one. Yum install, let's say git package, and you see that the system is going to go to pull up the package, and it's asking if this is okay, yes or no. If I press yes, it goes along to install the package. So, for example, too, I can also use the DNF package manager to install GIT. This is a Red Hat 8 system, all right. DNF install GIT, and it goes along to ask me if I want to. If I say yes, it's going to install the package. You see that it's preparing and it's installing the package, all right. And let's wait for it. So you can see that the package has been installed. But if you've been following my course since from the beginning, your system might not be able to do this actually. So you need to subscribe your system before you can do this, right? So I already have a subscription that I am using, but it's unfortunate I can't share my password and my username. All right, so that's why I said before we talk about how to use the DNF package manager or the Yum package manager, we need to. I've been thinking of how to combine this or how to integrate this topic to this and how to arrange the topics, so you can actually understand. So it's better we talk about how to install, how to configure Yum local repository on Red Hat 8 before we now talk about how to use the Yum or the DNF package manager. All right. So if your system is not subscribed, there's another way around it, which is even what you're going to be doing in the examination. Or you're going to be configuring a Yum local repository. All right. So when we configure the Yum local repository, you can be able to install and download packages. All right. So let's look at how to configure Yum local repository. A local repository can be configured by using the Linux ISO or the DVD, all right? And the default Red Hat repository configuration file is in etc yum the repos.b, all right? If you do ls, you can see the Red Hat repo. So if you're also going to be configuring the yum local repository, you also need to create a configuration file in this directory in the etc yum.repos.d directory. All right. So this is another repository. This is the one I created, but I'll show you how to do that. So before I show you how to configure the yum local repository, let's understand what a repository file should contain. So let's see the one for Red Hat, right? So you can see everything in the file. So let's quickly explain what all these parameters mean. But we're just going to be I'm going to be explaining the important ones you need to configure your Yum local repository with. All right. The first parameter is very important. All right. So let's see what this is. It represents a unique repository ID. All right. So if you're configuring a Yum local repository, you need to give a repository ID, and it is unique. You can give any name you wish, but do not allow it to conflict with any already given repo ID on the system. All right. And when you're giving the name, also there shouldn't be any space. Like for example, this is a repo ID, so this is my repo, and you see that there is no any space at all. So this is how you give a repo ID. There is another important parameter which is name. Let's see where name is. So this is name. The name field is also very important, and that's the name of the repository you're configuring, right? You can also give any name you wish, but it's advisable you give any name you can easily relate with. And another important parameter you need is the base URL. The base URL is the repository's URL, that is where the packages are. All right. The ISO packages or the packages can be located either locally on the system or on an HTTP FTP NFS server or whatsoever any kind of file server. All right. So, but for this topic in configuring the Yum local repository, ours is going to be local. All right, and this is the way you can um, configure or create a base URL value. All right, so you can either point it, if it is HTTP, this is how you're going to do it, and if it's HTTPS, this is how you're going to do it. If it is FTP server, this is how you're going to do it. But in our case, we're going to be using it's going to be local, so it's going to be a file server. This is how we're going to do it. Another important parameter is the enabled parameter, all right? So this value means that you either want to enable or disable the repository. And if the value is 1, it means that the repository will be enabled. But if it is 0, it means that the repository will be disabled. Of course, in this case, we want the repository to be enabled. And another important parameter is the GPG check parameter, and it is used to check the genuinity of the packages in the repository. So by default, GPG check is always 1, but in this case, we are the one configuring this. So of course, we know that the ISO package is genuine. So in this case, we're going to make it equal 0. All right. So just to avoid any complexities in the configuration. I'm going to be dropping the link to this website in the description section below. If you want to know more about the difference between Rail 7 and Rail 8 ISO, and also how you can, I mean, there are a lot of things you can learn here. You can always click and navigate your way through. All right. So now that we understand what a repository file should contain, let's go ahead and create a Yum local repository. The first thing you need to do is to get the ISO to your system. You can use FileZilla or any other FTP utility. So in my case, I'm using FileZilla, all right? So I'm just going to get the ISO into my system. I'm going to put it in /media. You can put it anywhere you have space, all right? So I'm just going to drag it and put it here. I'm going to wait for the upload to complete. The transfer is complete, so I'm going to check my system. Oops. So I don't think it's in media. Let me check the FileZilla and see where the ISO was dropped again. So I think it's in root. Alright, so this is the ISO file. Apparently it was dropped in the root directory, home directory. So the next step to do is to mount the ISO to any mount point. Alright, so I can just mount this to /mnt. The ISO image is mounted. Let's verify this. So we can see that it's mounted, all right, on MNT. The next step is to make a directory so that you can copy the ISO files in that directory. You can copy the ISO files in any path you wish to copy it to, but I'm just going to make a directory called ISO files, right? So I'm going to copy everything in the mount directory. So I'll copy all of this to the ISO files directory. So I'm just going to do -verbose and archive. All right. It's going to take a while because it's about 8.1 gig. The copy is complete, so let's check the ISO files. So you can see the ISO packages here in this file. Okay, so let's create the local repository file. All right. So I can call this ISO files or any name I wish to call it. This is different from the RHCSA. in Rel 8, you need to configure two base URLs, one for the upstream and one for the base OS, unlike the one we did when we configured the local repository for Rel 7. Briefly, this you can use any name here, and this is the base URL, all right, and the base URL is file. We're pointing to the ISO files, and we're pointing to the upstream package file, and this is a GPG check, which is 0, right? And the name, you can give any name in here. So I'm just using Red Hat Ent Linux Upstream, and enable here is 1. So the same thing here as well. You can give any name here. The base URL, it needs to point to the ISO files, because this was the directory we created where our packages are, right? And it also needs to point to the base OS. The GPG check, right, it can be 0. The name too can be any name you wish to give, and enable us to be 1. So I'm just going to save the file. So I'm going to test our configuration. You can use DNF repo list or yum repo list, whichever one works. You can see the repo ID here, and you can see the packages that we have. So the configuration is working. So this is how you configure your yum local repository on Red Hat 8 system. You can install whatever package you want to install. So in this case, we're installing the HTTPD server. All right. So quick one, if you're going to be writing the RHCSA 8 exam or the LFCS exam or the SUSE Linux exam, you can scroll down to the end of this website and click on the exam practice questions. I'm going to be updating this website from time to time, and you can always come here to practice before you write the exam. All right. So thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, my name is Victor, and I'm one of the authors of Technique.com. Today, we're going to continue with our course, and we're going to be looking at software installation in Linux Part 2, where we're going to look at how to use yum and DNF package manager on Red Hat Enterprise Linux 8 system. All right. Quick one, if you're going to be writing the RHCSA 8 or the LFCS or the SUSE Linux exam, just scroll down to the end of this website and click on the exam practice questions that you want to write. So I'm going to be updating this website from time to time with the updated questions and answers, and with the SUSE Linux and the LFCS exam questions. All right. In the previous lesson, we've looked at how to create a yum local repository. All right, so to use the DNF package manager to install the software, you use the command DNF install and the name of the software. So for example, if the software is VSFTPD, you do DNF install VSFTPD, all right, and then you press your enter key. So this software has already been installed, and you see it's saying already installed. So you can also use the command dnf install vsftpd -y, which means don't ask me questions. This means yes, just go ahead and install it. The same way, you can also use the yum install. So both yum package manager and dnf package manager are working on the Red Hat 8 system. So the Red Hat developers, they've been able to integrate them so well that if you use the yum package manager, you can be able to install packages. If you use the DNF package manager, you can be able to install packages. But I know that as time goes on, the yum package manager will be deprecated. The recent package manager, or the latest one for Red Hat, is the DNF package manager. Let me just clear my screen. So to use the yum or the DNF package manager to delete a package or remove a package, use the command yum remove, for example, the VSFTPD package. All right. So you can see this, you press Y, yes, and then it's going to remove the package. To use the yum package manager or the DNF package manager to get an information, you can use the DNF info, then the package name, but I doubt if this would work because this can only work if your system is subscribed, right? So let's say, well, it's working. So you can see that you can use the DNF or the yum info to get the information, the package information. All right. So the name of the package is HTTPD. This is the version of the package, right? This is the size, and this is the URL from which repo from rel 8 upstream. All right. So that was the repo we configured. Okay. So to use the Yum package manager or the DNF package manager to check for an available update, yeah, I doubt. Let's see if this would work. So you use Yum check update to do that, or the DNF check update. Okay, you can see that the system is not registered. All right. So this wouldn't work for a Yum local repository configuration. To use the Yum package manager to update a file, you use Yum update the package, use the Yum update, then the package name. All right, so this works most especially if your system is subscribed. All right, so we're just using the local repository we configured, so it might not work. It won't even work. All right, so to use the Yum package manager to list a software or a package, you do Yum list for all, we do all right. Let's try DNF list all. Oh, sorry, it should be list all. Okay, so you can see all the packages on this system. To clean the Yum cache, you use the command Yum or DNF, whichever one, clean all. All right, so you can see that 28 files are removed. To use the DNF or the Yum to get a package binary, use the command DNF provides then the name of the package. It can be DNF what provides or DNF provides, whichever one it would work. All right, so you can see that this will fetch out the package binaries. DNF what provides to should work. All right, so you can see that it's working. Let me do this for all. This shouldn't be a problem if you've gone through my Red Hat, Linux tutorial for beginners series. Okay. To use the DNF or the Yum package manager to search for package, you use the command Yum search, for example, HTTPD package. To use the DNF or the Yum package manager to list all the packages that are installed on your system, use the command this installed. Alright, so these are the packages that are installed on your system. As I've always told you, always use your dash help or your man page for a particular command, all right? And if you do that, you'll be able to get a grasp of everything that the command can do. All right, so if you want to learn more about the Yum or the DNF package manager, I'm going to be dropping the link to this website in the description section below. You can just come here to learn more about it, but we've covered everything you need to know in the RHCSA 8 course. All right, thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at software installation in Linux part 3. We're going to be looking at RPM in Linux with examples. Alright, and quick one, if you're going to be writing the RHCSA 8 or the LFCS or the SUSE Linux exam, just scroll down to the end of this website and click on the exam practice questions. All right. So we're going to be updating this website from time to time. So you can always come here and check the practice questions and practice with before you write the exam. It's very important. I'm also going to be dropping the link to the website in the description section below. Okay. So having understood the concepts and terminologies around software installation in Linux Part 1 and Part 2, all right. So it's high time we looked at what RPM is. In one of the videos, I mentioned that RPM is a package manager. So you should also know that RPM is a package manager as well as a package file type with the extension .rpm. So there are always softwares or packages in Linux that most especially in Red Hat or Red Hat based Linux distributions that has .rpm as the extensions. So to install such packages, just as the same way you're going to be installing a .exe package in on Windows, right? Just that one single package which has .exe. The same way you also have it here on Red Hat. So you're going to be having the package with just an extension of .rpm, and you need to install it. So to install such kind of package or software, you need to use the rpm command followed by hyphen, which means install, right? Then the name of the package with the .rpm extension. So for example, let me just look for a package which has .rpm extension. I can add verbose and email readable form. All right. So I remember that we configured the yum local repository in ISO files and followed by upstream, right? Followed by these are the packages we have in the ISO. Let's see what we have. The RPM packages. Whoa, about 5,184. Okay, since I don't know anyone right now, so I'm just going to use the Y command. Okay, so let me just pick one. Let's pick ABRT. But you can see the extensions there. They all have .rpm extensions. So to install a .rpm extension file, you need to use the rpm -i to install that, and you can add all other options you wish if you wish. All right, so let me just pick this file, this Java file, and let's install this. So you can see that ABRT is needed by ABRT Java connector. You know, in one of the videos I mentioned dependencies. That's with RPM package manager, you always have dependencies issues, and that's why the Yum package manager was later developed, and also the DNF package manager. So this is one of the dependency issue we mentioned. I said a dependency might depend on another dependency, and that dependency will also depend on another dependency, and that dependency will also depend on that dependency. So I mean, sometimes it's hell. But let's see if this dependency does not depend on another dependency. So let's just pick this. For example, let's see .rpm. It's gonna have .rpm. Oops, sorry, I didn't specify the path. So let's specify the path here. .rpm. All right, so you can see that this is also needed by this dependency again. Anyways, that's why you should always use the Yum package manager. You understand? And sometimes too, you should. There are some cases that you would need to use the RPM package manager, but then it wouldn't depend on a lot of dependencies. Okay. You should also know that RPM is not that bad. With RPM, you can do a lot with packages, even though it's been replaced with Yum and DNF. All right, so RPM package manager can be used to query packages as well. So, for example, to query a file in a package, use the command rpm -q query the file. All right, and the name of the file. So let's use the HTTPD conf, for example. So another thing you can use the RPM to do is to list the configuration files in a package. So to do that, use the RPM QC. Let's see the HTTPD package. All right, so these are the configuration files in this package. You can also use RPM to verify installed package. So you can do RPM, for example, let's do HTTPD is also installed. Okay, and also of course kernel. Kernel is also installed too. Of course, without a kernel, then there is no operating system. Like we've said, to use the RPM to install a package, use the RPM -ivh sorry, and the package name. All right. So to use RPM to update a package, use the command RPM -u means update. All right. Rebels human readable form and the name of the package as well. So to use RPM to delete a package, all right. Of course, RPM package, you use the command RPM which is remove, then the name of the package. All right. To query or list the document file of a package, use the command QD, which is query document file, and the name of the package. So if I use LVM2, so it's going to create the document file of the package. To use RPM to verify on all installed packages, we do RPM-QA. All right, just as when we used yum as well. And you should also know that as an administrator, you wouldn't just want to install any package, especially the ones downloaded from an external repository without verifying it. So it is a good idea to have a look at the package script before you actually install the package. So there's what we have, there's a pre-installation package script and a post-installation script as well. So it's a good idea to always verify a package script before you, if it has actually, before you install the package. All right. You should also verify the post-installation script after the package has been installed if you do not trust where you're downloading the package from. So to use the RPM to check for the installation script of a package that hasn't been installed, use the command RPM-q, then p -script, all right, and the name of the package. So let me try and look for one. So this is RPM. Let's see this. Okay, I have installed this. All right. Okay, so to check for the installation scripts of the package that has already been installed, you use the command. Let's use this command RPM-q and script. Then followed by the package. All right. I think something is wrong. I need to add Q here. Okay, so you can see the installation script of the HTTPD package. Like I have said, you can do a lot with RPM. To know more about a command, always use the command RPM, for example, -up, or you can always use the man page of that command. All right. If you want to know more about RPM, you can come to this website. Basically, we've covered everything we should cover for the RHCSA 8 exam. All right. So I'm going to drop the link to the website in the description section below. Thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I'm one of the authors of technique.com. Today we're going to continue with our course, and we're going to be looking at managing services in Linux. Alright, managing services in Linux is one of the important tasks of an administrator. You need to learn about what services are. You need to learn how to start, how to stop, enable, and disable services in Linux. Alright, so but before we continue, let us look at what systemd and sysvinit are. Alright, so a systemd Linux system is a Linux operating system that runs on systemd. So what does that mean? It means that the Linux operating system uses systemd as its service manager. So the program or application that is responsible for managing services on that particular system is systemd. Okay, so similarly to when you hear sysvinit, that means that the program or application that is responsible for managing services on that kind of system is sysvinit. Alright, so we have a systemd Linux system. We also have a sysvinit Linux system. But the modern Linux systems are all systemd systems, the likes of Red Hat 7, Red Hat 8, CentOS 7, 8, and other distributions. They are all systemd systems. The old Linux systems like RHCSA are sysvinit system. Alright, since we are concerned with Red Hat 8, so we're going to focus all our attention on systemd system. Okay, and when we get to the Linux boot system, I'm going to explain more about systemd. But you should know that systemd, of course, has run target, and run target is the system mode that controls the operations of the system in accordance with the services that are available in the mode. You shouldn't bother yourself much about this. When we get to the Linux boot process, you would understand more about it. What you should be concerned about is that when the system boots, of course, so the system would boot into the default run target, which will be the first process or service that will start. Hence, it will have the process ID 1. Alright, and other services will then depend on it. So what I'm trying to say is that the default run target is the parent process or the parent service to other services on the system. So every services on the system belongs to a particular run target, which basically means that every service is assigned to a target, and the target takes care of starting the services. Alright, so systemd, unlike sysvinit, doesn't take care of starting services. If you want to learn more about sysvinit, you can come to this website to learn more about it. I've written about sysvinit. I'm going to drop in the link to the website in the description section below. Alright, so also if you're going to be writing the RHCSA or the RHCSA exam or the SUSE Linux exam, you can just come to this website and come and click on the exam practice questions. I'm going to be updating the website from time to time, and it's better you practice before you go write the exam. Alright, how does systemd work? Systemd uses unit files for its management, and unit files are configuration files or scripts that define how units function. Alright, and the unit files are the replacement of the old sysvinit script, unlike the sysvinit long bash script where you have a long script and it's always difficult to comprehend. So unit files are short, so it has come to replace the sysvinit script, and that's why systemd is at least more preferable than sysvinit. Okay, and the systemd's unit files can be found in different parts, but majorly in two different parts. The first part is the user, which is user lib, systemd, system. So let's list the content here. So you can see different unit files here. You can see the different unit name. Units are also objects, alright, and they are different types. So for example, we have .service. So this is a type of a unit or object. We have another one, .socket. This is also a type of a unit or object. So these are all the unit files. Okay, and the second location where the unit files can be found is etc systemd system. Alright, so you can see the different unit files here too.
This location is a location where an administrator can modify or write their unit files. So if you want to write your unit files, don't go to the first location. It's better you do that here. All right, and whatever unit files you define here will have a higher priority over the unit files in the first location, which is the user lib system system directory. So anytime you want to define any unit files, you should always define it in this location. All right, a unit file defines how the unit or object functions. Okay, so for example, a mount unit file will define how a mount point function, while a service unit file will define how the services function. Let's take a look at one of the services unit file in the user lib. All right, so we have a lot of them. So let me just look for the one for the services unit file. Okay, so I want to look for the common service that we know. All right, I think I can look for the SSHD service. Okay, service. All right, so you can see a unit file. This file contains everything the SSHD service needs to function with: how it should start, how it should stop, how it should restart. All right, so you can see how or what a unit file looks like. Having understood all of this, what a service is and what a unit file is and what systemd is, all right, so in the next lesson we're going to look at how we can start, stop, enable and disable services in Linux. All right, so thank you for watching and please subscribe to this channel. Bye for now. Hi everyone, welcome to the second section of this video. Today we're going to look at how to start, how to stop, how to enable, how to disable, and how to do some other activities with services in Linux. All right, in the previous video we've looked at what a service is. We've looked at systemd and sysvinit system. We've looked at how systemd works. We've also looked at unit files and what unit files looks like. All right, to start a service on a systemd system, use the command systemctl start, then followed by the name of the service. So for example, if the service is http service, you're going to start the service like this. All right, and if it is a sysvinit system, you use commands like service start httpd, but since we were dealing with systemd system, also every command that we're going to be using here is going to be about systemd. All right, so to stop a service in Linux, all right, use the command systemctl stop followed by the name of the service. All right, and to view the status of a service, use the command systemctl status. All right, status. So you can see the status of a service. So for example, you can see that this service is inactive, which is dead. So this is showing you the status that it is inactive and it is dead. So for example, let me start the service again and let's see the status of the service. So you can see that the service is active and running now. Okay, these are logs, systemd logs concerning the service. All right, so let me just clear the screen. So to restart a service, use the command systemctl restart followed by the name of the service. So this command will restart the service. All right, and to make a service start automatically on a system boot, that is to make the service persistent, use the command systemctl enable service. So if you use this command, that means that this service, when the system boots, this service too would automatically be started. All right, so you can see that it has created a symlink, which is a symbolic link in this target. And to do otherwise, to disable the service, use the command systemctl disable, followed by the name of the service. So you can see that the symlink has been removed. Okay. To list all available systemd units and unit files, you use the command systemctl list followed by the unit, then files. Alright. So this command will list all the available systemd units and unit files. So to list all the available running units and unit files, you use the command systemctl list units. So this command will list all the running units and unit files. Alright. So to list the systemd field unit, you use the command systemctl --field. Alright, so you can see here that 0 loaded units listed, so there are no field units here. Okay, and to list all systemd services, you use the command systemctl list unit files followed by the type, which is service. Alright. Okay, so to list all systemd targets that are currently active, you use the command systemctl list unit, then type here would be target. Alright, this should be unit. Okay, and to kill a service running a systemd system, you use the command systemctl kill followed by the name of the service. So for example, if the service is httpd, alright, so this is how you kill a service in Linux. This is how you kill a service with a service name in Linux. Alright, so I'm just going to do status here. Alright, so you can see that the service is dead. So thank you for watching, and please subscribe to this channel. Bye for now.
Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our RHCSA 8 series, and I'm going to be talking about network management in Linux. I'm going to explain all of this with examples. Alright, so before we read at 7, the only service that is used to manage network in Linux is the network service, which is also called the network script. All right, so when Red Hat 7 was introduced, another service was also introduced with systemd that is used to manage network, called the network manager service. Before the introduction of network manager service, if you want to do some configuration, say for example you want to configure a manual IP address, all right, you would need to go to the NIC configuration file to do some scripting activities. But from Red Hat 7, you do not need to do all of that anymore with Network Manager. So it's been introduced to eradicate the fact that you would need to know how to do all of the scripting things before you can configure your network. All right. So you can either use the network. You can either go to the network configuration file to configure your network, or use Network Manager from Red Hat 7 and above. And the thing is, even in Red Hat 8 now, the network service has totally been deprecated. So we don't have the network service anymore. The only thing we have in Red Hat 8 is the network manager service. So in this course, we're going to be focusing on the network manager service. And for those that like to disable Network Manager, sometimes I do that on site too, especially when I'm configuring KVM virtualization and Network Manager is giving issues, I just disable it. Well, in Red Hat 8, you cannot do that anymore because That is the service that is used to manage network. However, you can still use the network service, which is network script to manage network in Red Hat 8. There's a way you can do it. I'm going to drop the process, the steps of doing that in the description section below. If you still want to use network script to manage network in Red Hat 8, you can do that. But the fact is that it has been deprecated in Red Hat 8. So let's see how we can configure and manage network addresses on network interface card in Linux. So before we look at that, you should know that in Linux, the utilities that are used to manage network are the NMCLI utility, which is used by the network manager. This means network manager command line interface, and the NMTUI utility, which means Network Manager Text Utility Interface. All right. You can also set your network addresses using the GUI environment. All right. And you can also use the IP utility to manage network in Linux. So let's talk about a NIC. I hope you understand what a NIC is. All right. So a NIC actually is a network interface where network functionalities, properties, and addresses such as IPs, DNS, gateway, and all the network properties are configured on. And by default, every NIC has its own properties and other network properties, and connections can be configured on a NIC in Linux operating system. Linux has a way of naming a NIC. In Red Hat Enterprise Linux, a NIC can be named ETH0, ETH1, ETH2, etc. And this type of nicknaming exists in the old versions of Red Hat, and it's called the UDEP naming. All right, and a nick, sorry, can also be named with respect to the card attributes. This type of naming is known as the BIOS naming, for example, the EM1, EM2, EM3, and so on and so forth. We also have the P2, P1, the P3, P2, such type of naming is BIOS naming. And another form of BIOS naming is the physical naming of a NIC. For example, when you have the ENS22, ENS24, and so on and so forth. All right. And to see the network cards available on a Linux system, we're going to use the IP-A command. So let's do that. Using this command will show you the available NICs on the system. Okay, this first one you can see some other interfaces, but what we're concerned about is the NIC. All right, and the NIC here is ENS33. That's the only NIC I have on the server. And the configuration file for this NIC can be seen in etc sysconfig network script directory. All right. So if I do ls, you can see the configuration file for this NIC. Let's see what we have here. All right, you can see the parameters in this file. Let's get to understand the basic parameters. The first one is type equals Ethernet. All right. So this parameter signifies the type of network interface. In our case, the network type is Ethernet. You'll get to know more about the other types in the advanced course of networking in another lesson. All right. So the another important parameter is boot proto. So boot proto has a value to be DHCP. All right, this parameter signifies that the IP should be obtained from the DHCP server. All right, if you want to set, if you want the IP to be obtained manually, or sorry, if you want to set an IP manually, right, you're going to set this to be none, right? This can be none. And also, if you want to use a bootstrap protocol, this can be set to boot TP. Well, you don't need that for the basic RHCSA course. All right, so another important parameter you should know about is the def route parameter, which means that the default route should be yes. This value can be nullified by setting it to be no. All right. So the next important parameter here is let me see. All right, name equals ENS33. So this signifies the connection name. All right, in our case, the connection name is ENS33. Okay, and the connection name is actually different from a device name. You can see a device name to be ENS33 as well. So there are two different things. As we go on, I would differentiate between both so you can understand. All right. However, a connection can have the same name as the device name. It doesn't matter. They can be the same name and they can be a different name. All right. So the other important parameter you should know here is the UUID. All right. This UUID signifies is an identifier. All right, of the network interface, and it's a way of identifying a NIC with an ID, and every UUID is unique to an interface. All right. So the next important parameter, we've talked about the device, which is the hardware itself, which is the NIC. So the next one here is on boot equals yes. So this signifies that the network interface should be active at boot time. All right. So in our case, when the system is booted, the network interface too will come up as the system is coming up. And if you don't want this behavior, you can set the value to be no. And another important parameter is the HWADDR, which is the MAC address. It signifies the MAC address or the hardware address of the network interface card. Okay. This settings is for a DHCP server that if you want to obtain your IP automatically. So what about if you want to manually set your IP? What kind of configuration file would you have? So I'm just going to show you an example of how it's going to be so that I can explain the basic parameters. So let's clear the screen. So for a manual configuration of an IP address, you would see IPADDR, right? Which means this parameter signifies the IP address. This 0 means IP address 0. You can have more than one IP addresses, while this 1 means IP address 1, all right? And this prefix equals 24 means the subnet, right? You can use another parameter instead of this prefix. It's called net mask. Sometimes when you see some configuration files, you see net mask equals 255.255.255.0 for a class C network. All right. So another important parameter is the gateway, where you would have your gateway IP address and the DNS. All right. So we've already explained the others. All right, another important one is the boot proto, which has to be none. In the former one, the boot proto was DHCP. So if you say boot proto should be none, that means you want to manually configure your IP address. So in the next lesson, we will look at how to manually configure IP address in Linux operating system. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our RHCSA 8 series and we're going to continue with network management in Linux explained with examples. In our previous video, we've looked at how network works in Linux. We've looked at what network service, which is the network script, what it is. We've looked at what network manager is. We've been able to compare both services together in our previous video. All right. We've also looked at what a NIC is. We've looked at the NIC configuration file. We've looked at the important parameters in the NIC configuration file. All right. So in today's video, we're going to look at how to set a static IP in Red Hat Enterprise Linux 7 or 8 system. Okay. And setting a static IP in RHEL 8 can be done by the following ways. You can do that by directly editing the network configuration file. You can do that by using the NMCLI utility. You can do that by using the NMTUI utility. And you can also do that by using the GUI utility. So we're going to start with setting a static IP by editing the network configuration, the network interface configuration file. So for example, if I'm to set this IP addresses, all right, if the static IP is supposed to be this IP address, the subnet mask, the gateway, and the DNS, how do we go about it? All right, the first step to take is to edit the network interface configuration file. Let's just open it. All right, so before I edit this, let me just do a backup of this file. Okay, so what I should edit is this boot proto. I need to change this to none. All right, because I want to set it to be a static IP, and I don't want the DHCP server to give me an IP address. All right. So the next thing is to add the IP address. Sorry, I have issues with my dot key. So we're going to add a net mask as the subnet. So the next thing to add is the gateway. Let me just copy this. And the final thing to add is the DNS. Okay, so let's look at other parameters. Def route, yes. All right, this name, yes. Your ID, device, on boot, and the MAC address. So this is fine. Okay, so let's save this file. So the next step to take is to restart network manager service, or you restart the network interface. But what I'm going to do is to restart the network manager. Okay, so let's confirm our settings. You can see the NIC now. You can see the ENS33 NIC. You can see the new IP address that we've set, and you can see the subnet mask. All right, let's see if I can ping Google. Oh, yes. Okay, so you can see that our network settings is working. If you want to restart the network interface and you don't want to restart the network manager, just use this command. Right, so this is going to restart the network interface. I'm not going to do this because I don't want to lose connection to my SSH. It's possible I lose connection and I might not lose connection, but this is how you're going to restart the network interface. All right, so in the next video, we're going to look at how to set a static IP using the NMCLI utility. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to continue with our RHCSA 8 series, and we're going to continue with network management in Linux explained with examples. In our previous videos, we've looked at a lot of things. We've looked at what network manager is, we've looked at what network services is, we've looked at the NIC configuration files and the important parameters there. We've looked at how to set a static IP address by directly editing the configuration, the NIC configuration file. In today's video, we're going to look at how to set a static IP address in Red Hat 8 system by using the NMCLI utility. So for example, if you want to set the static IP address to be 192.168.170.211, if you want to set all these IP addresses, how do you go about it? Okay, the first step to take is to first of all set the IP address, right? So let's do that. NMCLI connection, modify the connection name. All right, I'm supposed to explain the difference between a device and a connection. So a device is the NIC, that is the network interface card, and a connection is the properties you define on a NIC, right? So let's say, for example, you have IP addresses, the gateway, the IP, the DNS, all of these are properties that is always defined on a connection, and a connection is always defined on a NIC. So let me just quickly show you the NIC configuration file. So you can see here, you can see a name, which means the connection name, and you can see a device, which means a connection device. So the reason why you always have connections is because you can have more than one connection on a network device, right? I can decide to create another connection called maybe connection Victor, all right? I can also decide to create another connection called connection Technid, right? All of these connections can be created on one device, and the reason is because if you want more than one IP address on a NIC, right, you can just create a connection. You define that IP address on the connection, and the connection is being attached to a NIC. So whenever we're defining an IP address, we are defining it on the connection, right? And the connection has to be attached to a NIC. And a connection, like in this case, a connection, the name of the connection is the same name as the NIC. As we go on, I'll show you how to create a connection and assign a different IP on a connection, and you will assign that connection on this NIC. Okay, so to create the static IP address, right, using the NMCLI, so you're going to use the command NMCLI connection modify. Oops, sorry about that. Modify ENS directory, which is the connection name, followed by the IP address, IPv4 dot addresses, then followed by the IP, which is 192.168.170.211. I'm going to let me just use 212. I think I might have a 211 connection existing, right? And followed by the prefix, which is the subnet mask. So you can see that I have edited this connection. So the next step to take is to set the gateway. Well, I forgot something. I was supposed to do the backup of this because I might need this later. So let me just quickly take the backup. Okay, so let's set the gateway now. So the IP for the gateway is .0, and we're going to change this to gateway. Oops, the IP for the gateway is actually .10. All right, let's just edit that. So the next step is to set the DNS, and the DNS is .0. So I'm just going to change this to DNS. The next step is to set the boot proto to be manual. All right. So let me just change this to the manual. So this means that I don't want my IP to be gotten from the DHCP server. All right. So the next step is to restart the network manager, or you restart the network interface. So let's check the script again. So you can see that all these IP addresses have been defined on the NIC, right? And the boot proto is set to none. It's not DHCP anymore. Let's check from here. It's not changed here. So let's restart the network interface. Oops. So because I'm logged in via the SSH session, so I've lost connection. All right. So I'm just going to go to my console and then bring up the network, the connection, and I'm going to try and log in again. Now I'm on the console. So let me bring the connection down and bring it up again, because I remember in the first command I made a mistake while I was spelling NMCLI. All right, so let me bring it up again. Okay, so let's check the IP address. So you can see that this has now changed to 192.168.170.212. All right. So you can tell now which is easier, either using NMCLI or directly editing the network configuration file, right? So that's why most administrators don't like the NMCLI command, because they feel it's tedious. So that's why I had to set the IPs one by one. Like I had to set the the IP address followed by the gateway followed by the DNS. I can just write a very long command to set all of them all at once, right? But just to simplify things, I had to do it one by one. I remember I backed up the configuration, the NIC configuration file, right? So before I backed it up, I I had already edited the IP address here, so I'm just going to delete it. Okay. So in case you want to return your backup to DHCP, you can always return it back. All right. So thank you for watching. And in the next lesson, we're going to look at how to set a static IP address using the NMTUI utility. Thank you. All right. So bye for now, and please subscribe to this channel. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our RHCSA 8 series, and we're going to continue with network management in Linux explained with examples. In our previous videos, we've looked at a lot of things. We've looked at network manager, we've looked at what network services, we've looked at network configuration files, we've looked at how to set the IP address by directly editing the network configuration file. We've also looked at how to set an IP address by using the NMCLI utility. So in this video, we're going to look at how to set the IP address in Red Hat 8 using the NMTUI utility. So for example, we're going to set this IP addresses, having the IPv4 address to be this, the subnet mask to be this, gateway, this address, and DNS, this address. So how do we go about it? The first step to take is to initialize the text utility interface by running the nmtui command. All right, and we're going to edit a connection. All right, we want to edit the ENS333 connection, and so what you're going to do is you navigate to the edit. All right, so you're just going to set your, you can set the profile name, which is the connection name here, the device, which is the NIC. All right, so IPv4 configuration, it's already manual. If you want it to be DHCP, you're going to set it to be automatic. So it is manual. We're just going to set this IP to what we want to set it to. All right. So what we're trying to do is to make this 10 dot 10 dot. And I just have a lot of issues with my dot key. Dot 15. All right. So the next step is to set the gateway. 10 dot 10 dot 10 99. All right, so the next step is to set the DNS server, which is 10.0.1.3. Okay, so you can just scroll down. If you have other IP addresses, you can click on hard here. If you have other, you can press or enter on the hard um, tab here, right? If you have other DNS servers, you can do the same thing. Then you can just scroll down and then you click on OK. You're not actually clicking, you're navigating and pressing the enter key. All right, so I'm going to remove this and I'm going to make sure I click OK. I press enter and OK key. All right, and you're going to go back. And here you're going to say OK. So you can restart your network manager service. Restart. Okay, so let's see if it's changed. It has not changed, so we need to restart the network interface. So I guess I've lost connection because I'm logged in via SSH. So I'll just go to the console to, let's see if I can even just restart here. Oh, obviously I cannot restart because the IP has changed. So I'm just going to go to the console and log in via the console. So I've logged in via the console. So let's check the interface again. Okay, so you can see that the IP has changed. Okay, so this is how you're going to set the static IP using the NMTUI utility. All right, so thank you for watching, and please subscribe to this channel. In the next video, we're going to look at how to set the a static IP address using the GUI. All right, thank you, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our lesson, Network Management in Linux explained with examples. In the previous videos we've looked at a lot of stuff. We've looked at Network Manager, the interface configuration files. We've looked at how to set IP address using the NMCLI utility, the NMTUI utility. And we've also looked at how to set the IP address by directly editing the network configuration file. So in today's lesson, we're going to look at how to set the IP address in Red Hat 7 or 8 system using the GUI interface. GUI, graphical user interface. All right, so by the right hand corner of your GUI, click on this button and you click on wired connection. All right, we are doing a wired settings. Okay, so now you go to network here and you see that it's on, right? So you can come to here to this place to click on the settings. All right, so you can see the details here, and for you to set your IP, you come to IPv4 tab. It's already in manual. If you want a DHCP, you put it in automatic, which is DHCP. All right, you can just click here and set your IP address. So I can do 10.10.10.21. All right, your net mask, a class C net mask, and here you can just set your gateway. All right, and your DNS, you can set your DNS here as well. Okay, so what else? You can scroll down to check other settings. So I think that's what we need. All right, so let's just look for where we can say apply. All right, so we just click on this apply here, and then we've already set the IP address. So let's just close this one, and let's try to restart the network manager service, or we just go ahead and restart the interface. All right, I think I have this command here, so let me do this. Okay, so let's check the IP now. So you can see that the IP has changed, and we've been able to set the IP address using the GUI environment. In the next lesson, we're going to look at other important network configuration files in Linux. All right, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor, and I'm one of the authors of Technique.com. Today, we're going to continue with our RHCSA 8 series, and we're going to continue with how to manage network in Linux, explained with examples. In our previous lessons, we've looked at a lot about network configuration, the NIC files, the basic parameters, and how to set static IPs using 4 different methods. All right. So in this video, we're going to look at the other network configuration files in Linux. All right. So I'm just going to start with the etc hostname file. The etc hostname file consists of the hostname. Let's check the file. All right. So you can see the hostname of the system. You can also use the command hostname ctl status to check the host name as well. You can see various information here, the static host name, which is HQDev1. You can see the icon name, which is a computer VM. Actually, I'm running a VM. All right. You can see the machine ID, the boot ID. You can see the virtualization software, which is VMware. You can see the operating system, whether Enterprise Linux 8.1. You can see the CPU OS name. You can see the kernel as well, and you can see the architecture a 64-bit system. All right, so this is the file that shows you the etc host name, is the file that shows you the host name. All right, and you can also do host name ctl status to check the host name of the system. As an administrator, there are some times that you might want to change the host name of a system. All right, so I'm just going to drop a link to this a link to changing the host name of a system in the description section below, so that if you want to know how to change the host name of a system, you can click that link and change the host name of a system. Okay, so the second file that we're going to look at is the etc host file. Let me just cut the file. All right, this file consists of a host name and IP address. Basically, it is used to map a host name to an IP address. All right. So in Linux, a host name is mapped to an IP address by either using this file, which is the etc host file, or by using a DNS server. And for a large network environment, DNS server is suitable for mapping. So you can see different IP addresses. Like for instance, this is an IP address and this is the name of the server. This is another IP address and this is the name of the server. All right. These are names of servers and these are IP addresses, right? So by default, when you open the etc host file, this is what you're going to see here. But if you want to map a host name to an IP address, then you can begin to populate the file by yourself. The third important configuration file is the etcresolve.com file. All right, let's just open the file. This file consists of the name server or a DNS address. All right, and it is automatically generated by network manager. You can see here, generated by network manager. So if you don't really know what you're doing, it's better you don't come here to edit your DNS server. But if you actually know what you're doing, then you can as well also edit your DNS server here, or you just let the network manager automatically generate this file. So when you populate your DNS IP in your network settings, all right, the DNS will automatically be generated here by the network manager. And the name server can be generated, can be populated like this, all right, by yourself, where you would have your name server and the IP address. And it can also be populated like this, where you're going to have the name server, the search, that is, let it search these DNS servers, right? And then you're going to have your name server and the IP address. In the next video, we're going to look at how to add secondary IP address to a NIC, how to permanently and temporarily add a second IP address. All right. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, I'm going to show you how to change a host name in Red Hat Enterprise Linux 7 or 8 system. Alright, so let's verify the present host name. So the present host name is HQDev1. So if I want to change this host name to Technique, for example, so what I need to do is to edit the hostname file. Okay, so I can just change this to Technique. The next step is to restart the system hostname service. All right, so let's verify again. So you can see that the hostname has changed to Technique. You can close this terminal and open another terminal to just see that the hostname has changed. So now you can see that the hostname is Technique. Thank you for watching and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today, I'm going to show you how to add a secondary IP address on a Linux system. Adding a secondary IP to a NIC can be done in many ways, and one of the very old ways of doing this is by creating a virtual NIC, which is a slave NIC from the original NIC, which is the master NIC. However, using this method is becoming obsolete and not recommended anymore, but still works anyways. Hence why in this lesson, I will show you the different methods of adding a secondary IP to a network card, and I'm also going to show you the right methods to use. In addition, you will know the advantages of using some methods over others. Alright, so let's get started with the first method, which is by editing the NIC configuration file. This method of adding a secondary IP to a NIC is a replacement of the old method of creating a slave NIC from the master NIC. So for example, to add a secondary IP address of this, for example, the first step to take is to edit the NIC configuration file. So let's do that. All right, so you can see the first IP address, which is the primary IP address. So we can just add 0 here if you wish. And then you add the secondary IP address. This should be 1. After 0 is 1. And then you add the IP. Followed by the prefix. Alright, so you save the file. The next thing to do is to bring down the NIC or the connection. Alright, so you bring it up again. That's you're just restarting the network configuration file. So let's verify the secondary IP address. Okay, so we don't have it yet. What could be the reason? Let's restart Network Manager. So let's verify again. We don't still have it. Okay, let me do this. Okay, so now we have the secondary IP address. So we have two IP addresses here, which is the primary IP address and the secondary IP address. So let's look at the second method of adding a secondary IP address to a NIC in Linux. The second method is by adding a connection. All right. In one of our previous videos, I said I was going to show you how to add a connection. All right, so we're just going to look at how to do this right now. And this second method of adding a secondary IP to a NIC is also a replacement of the old way of creating a slave NIC from the original NIC. All right, so it involves adding a connection to a NIC, and a connection can be added using the NMCLI or the NMTUI utility. And one advantage of using this method, but we're going to see the advantage after we do the configuration. Okay, and in one of the previous videos too, I explained what a connection is, which is the network properties, right? You have and you define on the NIC. All right, so let's look at the ways we can add a connection. The first step using the NMCLI utility is to run the command. Let me just clear the screen. So if I want the connection name to be Victor, I add Victor. All right, so NMCLI connection, add connection name, Victor. Okay, followed by if name. That's on the device ENS33 rather. Then the type is Ethernet IP4. followed by the IP address. So, oops, what is the error we're having here? Oh, okay, the IP address. All right, so you can see that the connection has been successfully added. So let's verify the connection in the config file. So you can see the connection here. All right. By running the command nmcli connection show, you can also verify a connection. So you can see a connection name. This is active and it is on this ENS33 device. All right. The connection vector is not active. All right. And to make it active, to make the connection vector active, all you need to do is to just do nmcli connection up vector. All right, so if you run this command again, you can see that the connection vector is now active. And when you do IP-A, you see that you have the IP on the connection vector working. So you can see the advantage of using this method because you don't have to necessarily use the two IPs together all at once. Okay, you can always toggle between one IP and the other by just bringing down a connection and bringing up the connection or the connection of the IP you want to use. So if I want to use the the connection ENSS3 back, so all I have to do is to bring it up, right? By using the same command ENS33. Okay, so let's verify the IP. So you can see now that we have the connection vector up and we have the two IP addresses that we've already created when we looked at the first method. All right, so let us look at the third method of doing this. So the third method is by creating a slave nick from a master nick. All right, so like we said that this method is becoming obsolete and it is not recommended anymore. All right, so I'm not going to do a video for this, but if you wish to know how to use this method, you can just come to the website. All right, I have the steps here. I've done it. You just take these following steps to do that. And I'm going to be dropping the link to this website in the description section below. All right, so thank you for watching. And in the next lesson, we're going to look at how to temporarily create a secondary IP on a NIC for test and purposes. All right. So thank you and please subscribe to this channel. Bye for now. Hi everyone. My name is Victor and I am one of the authors of Technique.com. Today I'm going to show you how to temporarily add a secondary IP to a NIC on RHEL 7 and 8 systems. All right. You know, sometimes as an administrator, you may want to add another IP to a network interface. You know, temporarily, probably maybe you're doing some testing, and you don't want the IPs you want to add to be permanent on your system. You can use the IP utility to do that. When you use the IP utility to add another IP address to your NIC, by the time you reboot your system, all the configuration disappears. So let's see how to do that. For example, to add this IP address, all right, to the NIC as a secondary IP temporarily. So what you would need to do is to use the IP command. All right, so let's do that. So that's IP address add dev ENS33, the NIC.
192.168.170.11, then the prefix. All right, so let's confirm now. So you can see that the secondary IP address has been added. Okay, so when you reboot your system, you will not see this IP address anymore. So if you're doing a testing, for example, and you just want to quickly add a secondary IP, you can do it this way. So thank you for watching, and please subscribe to this channel. Bye for now.
Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to look at how to configure and manage Firewall in Linux. Firewall is a security feature that is used to protect the system from a network traffic, right? A system can be protected from incoming traffic by defining or adding rules or set of rules to a firewall. And these rules are called firewall rules. All right. So, for example, if I have a firewall enabled on a system and there is an incoming traffic, right? If this incoming traffic meets the firewall condition, that is the firewall rules on the firewall, right? The incoming traffic passes through and then goes to the system. Okay. And if the incoming traffic does not meet the firewall rule conditions, the incoming traffic bounces back, it's terminated. So how does firewall work in Linux? Okay, the network framework in Linux is net filter, and the net filter is used to address a firewall. Okay, and the net filter can be managed either by a tool called IP tables or firewall D or NF tables. In previous Red Hat versions like RHEL 6 below rather, the IP tables was formerly used, but as RHEL 7 came by, IP tables was not in use anymore. Actually, some people still use IP tables, but Firewall D took over to simplify the complexities of IP tables. And now we have NF tables. As a matter of fact, in RHEL 8, IP tables is totally deprecated. What we have now is Firewall D and NF tables. And the Firewall D is used to configure firewall properties that is not really advanced compared to the NF tables. If you really want to configure an advanced firewall feature on your system, you should consider using the NF tables. Though Firewall D can also do a lot and a lot on the system. So in this lesson, we're going to be looking at how to use the Firewall D tool to configure firewall in Linux. How does Firewall D work? Firewall D works with a zone and service concept. A zone is created and activated, all right? And on this zone is where you would have your firewall rules defined. And firewall rules can include a set of IPs, protocols, ports, NICs, etc. In Linux, the firewall rule can be configured or defined directly on the zone, or it can be configured and defined on a service, and then a service can be attached to a zone. We're going to look at how all of this is being done as we move on in the next class. All right? So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to continue our lesson on configure and manage firewall in Linux. In our previous lesson, we've looked at what firewall is, we've looked at how firewall works in Linux, we've looked at firewall D, we've also looked at how firewall D works in Linux. In today's lesson, we're going to look at firewall D zone and probably firewall D services. As it was mentioned in the previous lesson, that a zone is where you configure all your firewall rules on. The zone concept in firewall has made firewall management easy compared to IP tables. Okay, with zones, a lot of complex firewall rules can be easily configured on the system. A zone can be created by a user or an administrator can use a predefined zones on the system. The predefined zone can be seen by using the command firewall cmd. get zones. Oh, sorry, get zones. So you can see all the zones we have on the system. I'm using a Red Hat 8 system, so I have 10 zones. They are the block zone, DMZ, drop, external, home, internal, library, public, trusted, and work zones. These zones are predefined and they all have their function. For example, the block zone is suitable for incoming connections that is not trusted. This zone will block all incoming traffic with ICMP prohibited message, right? Then the external zone, for example, is suitable for external network and masquerading, right? The home zone is suitable for home network, that is a network within your home environment. Network within this sphere can be trusted, right? So if you know you have a network that you trust, you can use the properties, the firewall properties that are configured on the home zone. So these are all predefined zones, and the default zone on the system is the public zone. Of course, you can change it if you want to. The public zone is where all your firewall configuration will go to, except you specify the zone you want to configure your firewall rules on, right? If you do not specify the zone and you keep configuring, all your configurations are defined on the default zone. And the default zone is always active by default. To get the active zones on the system, use the command firewall cmd get active zones. So you can see the two active zones on the system, the librat, sorry, yeah, librat, and the interface that is using this is virbro, and the public zone, and the interface that is using this is the ENS33. So this is how you can get the active zones on the system. Okay, so to get the public zone and its firewall rules, right? You use the command firewall, sorry, list all. Okay, so you can see the default zone, which is public, right? And it is active. And you can also see the firewall configuration on this zone. For example, you can see the port and the protocols of this zone, right? The port for this zone is 2022. Okay, and then you can see all the information, all the firewall rules that are defined on this zone. Don't forget, I said firewall rules are always defined on the zone, right? To list all the zones available on the system with their rules and configuration, you just use the command list all zones. Okay, so this will show you all the zones and the different configurations or the firewall rules that are defined on the zone, right? So we have the block zone, we have the DMZ zone, we have the drops zone. These are all the zones with their configuration. And to list a specific zone with its rules and configuration, for example, if you want to list the one for the public zone, you can just do firewall, sorry, firewall cmd zone, all right, then public list all. Okay, so this will show you the specific zone and its configurations that are defined on it. Okay, so to change the default zone, for example, say you don't want to use this zone, you want to change the default zone. Okay, you use the command firewall cmd. I think it's set, yeah, default zone. Then I can change it to the zone name I feel I want to change it to. I can use home, for example.
Okay, so you see that we've been able to change this zone, the default zone, to home zone. Depending on how advanced you want to configure your firewall, sometimes you might need to activate 2, 3, 4 zones on your system and define the rules on the zone. So this is a public zone, for example. This rule is saying allow port 2022 on this system with the TCP protocol. All right. And on any other active zone, you can also say allow whatever port or whatever source IP, you understand, or whatever nick. Of course, you're going to define a zone on a nick, right? And then you can have multiple zones as you wish to define your firewall rules. Okay, so if you wish to learn more about all the predefined zones, I have them in this website. So I'm going to be dropping the link to this website in the description section below. You can come and learn about them. All right, so in the next class, we're going to talk about firewall D services, and we're going to look at examples of how we can generally configure firewall on the system. Okay, thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to continue our lectures on configure and manage firewall in Linux. In our previous lessons, we've looked at what firewall is, we've looked at how firewall works in Linux, we've looked at firewall D, we've looked at firewall D zones, we've looked at some basic configurations of firewall D zones. So in today's lesson, we're going to look at firewall D services. Firewall D is a very simple concept. It's just the combination of ports and protocols, and sometimes IPv4 and IPv6 destination entries. Just as we have predefined zones, we also have predefined services. So an administrator can choose to create or use their own services, or either use the predefined ones. To see all the predefined zones on the system, use the command firewall cmd get services. Okay, so this will show you all the services on the system. For example, we have the RH Satellite 6 service, Amanda client, Amanda K5 client. There are lots of them. To see the configuration or information of these services, you need to go to the location of where these services are, which is USR library firewall services. Okay, so you can see all of these services, and they are all in XML file, right? So for example, to look at the samba.xml file, okay, I can just concatenate this file, samba.xml, okay? So you can see all the information of this service. Don't forget, I said it's a combination of ports and protocols. So you can see the port that this service has, and you can also see the protocols. Okay, so you can choose to use a predefined zone, and you can choose to create your own, a predefined service this time around, and you can choose to create your own service. Okay, for example, if you're configuring Red Hat Satellite, you can just you might want to use this Red Hat Satellite service without configuring or creating your own service. It all depends on what you want to do. Okay, so to create a service, a firewall this service, you will need to follow the XML template just as the ones in the predefined template. Okay, and it's best you create your own service in the location etc firewall b. All right, then services. It's best to create your own services here. All right, so for example, if I want to create a service called technid2, all I will just do is to copy one of the templates and use that template to create my service. Okay, let's do that, which is copy. Let me copy from here.
library. Okay, let me copy the samba.xml file. Don't forget I said it's best to do your configuration in this location. Technique, technique 2.xml. All right, make sure it has the extension XML. Now let's edit the file to suit what we want it for. I want to add port 2020 to this file. Okay, so I can just say in the description. All right, I can just write whatever description I want to write here. Oops. Let's put something here. This option is for a technique service based on this tutorial. All right, and I want to add port 2020. Let me just do this. I want to port 2020. Okay, and 2020. Okay, let me use the same port, and I'm just going to do. I'm just going to use the same port, and I'm going to use different protocols. Okay, 2020. Let me use one should be TCP while one can be UDP. Okay, so I think that's all. I need to remove this. I also need to edit this. This is technique. Technique. All right, so I can save the file. Of course, when you create a service, the next thing to do is to attach the service to a zone, just as we've said in the previous class or in one of the previous classes. So in our next class, we'll look at the general basic firewall configuration and how to attach a service to a zone. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to continue our lesson on configure and manage firewall in Linux. In our previous lessons, we've looked at what firewall is, we've looked at how firewall works in Linux, we've looked at firewall D, we've looked at firewall D zones and services. Okay, so in today's lesson, we're going to look at the general configuration of firewall on Linux, and we're also going to look at how to attach a service to a zone. So we're going to start by verifying if firewall D is running or not. And to do that, use the command systemctl. Okay, so we can see that firewall D is active and running. To start firewall D, if it is not running, just change the status to start here, and to stop, change the start to stop. To enable firewall D service, that is to make it persistent, change here to enable, and to disable, that is to make it not persistent, change here to disable. If firewall D is not installed on your computer, just install it by doing your install firewall D. All right. So this is how you can install firewall D service. All right. So now let's add the port to the firewall rule. Okay, so I remember that we changed the default zone to home. So let's change it to public back, and that's because I doubt it if we have a NIC attached to the home zone. All right, I can just check.
Okay, you can see that there is no nick attached to the home zone. I can actually attach a nick, but I'm not going to do that here. Okay, so we're going to change the default zone to public back. Okay, so I'm just going to set the default zone to public. All right, so we've been able to do that. Let me just confirm. Okay, so you can see that my nick was actually attached to the public zone. Okay, so to add a port to the firewall rule, for example, say I want to add port 2015, I'm going to use the command firewall cmd add port port 2015. Okay, TCP protocol. I can use port 2018. I think I've already added 2015. Okay, so let's confirm. All right, you can see the number of ports I have on this firewall, 2018 TCP. And you can see that the firewall rule is defined on the zone, just like we've said, that the way firewall deal works, that it uses a zone concept and a service concept. So you can see the firewall rule, it's been defined on the zone. Okay, to make the changes permanent, you need to add the command permanent here. All right, so that has made the changes permanent, and sometimes you might want to restart or reload the firewall service. All right. Okay, so that has been reloaded. And if you want to specify a specific zone to add a port to, you need to specify the zone here. You can just say zone equals home, example. Oh, sorry, I need to add dash dash. Okay, that's it. To remove a port, you just change the add to remove. Okay. Oops, sorry. So that's how you can remove a port from the firewall rule. Let's do this for the public zone. All right, and I might want to sometimes reload the service. To verify which nick is associated with the zone, you use the command firewall cmd get zone of interface equals ens33. So you can see that this nick is attached to the public zone. To reassign a nick to a different zone, just use the command firewall cmd change. This should be change. Change interface. All right. So this is how you use the command, and you should add permanent to make it permanent. So I want to attach the nick to home. Okay. So to attach a service to a firewall zone, right? So we're going to do use the command firewall cmd add service. Yeah, the service we created was Technique 2 in the previous lesson. So you see that we've been able to attach the service to the zone. To confirm, we can use the command firewall cmd. All right, you can see the services. This is a new service we've just added, Technique 2. All right. I said the service consists of ports and protocols. So instead of you adding the ports and protocols directly, we can attach it to a service, or rather add it to a service and then attach the service to a zone. Okay. There are some class activities on the website. I'm going to be dropping the link to the website in the description section below if you want to partake in those activities. All right. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at managing process in Linux. Alright, everything in Linux runs as a process. When I say everything, I mean everything, including services and a shell command that is running on a terminal. Alright, so as a matter of fact, the open terminal itself is a process. So therefore, a process in Linux is a running program, and the process can either run as a shell or as a job or in the background. Alright, so as we go on in this subject matter, you will understand what the job is, and you would also understand the processes that run in the background. But have it at the back of your mind that a job, as far as it is a running program, is also a process as well. Alright. And as soon as the Linux OS is turned on, background programs and services start to run. These programs can also be called background processes, and they all have a unique process ID. Alright, so managing process in Linux many times requires you manage them via the process IDs, and every processes in Linux have a process ID. Alright. So let's see how we can view or list all processes in Linux. The command used to view all the current processes running on a Linux system is ps command, alright, which means print snapshot. Okay, quick one. If you're going to be writing the RHCSA exam or the SUSE Linux exam or the LFCS exam, alright, just come to this website and you can see my cursor and click on the exam practice questions. Or you scroll down to the end of the lesson and you click on the RHCSA exam practice questions. So at the end of every lesson, we usually have the RHCSA practice questions. I'm going to be updating it from time to time, even with the LFCS and the SUSE Linux exam practice questions. Alright, so to view the processes or the processes running on Linux system, you use the command ps-ef. Alright. So this can be viewed using the standard syntax. If you want to use the BSD syntax, you use the command ps-aux. Alright, so this will show you all the processes that are currently running on the Linux system. To know the number of processes running, the total number of processes running, you can just use this and grep this to, let's just count the number of processes that are running. So currently I have 323 processes running on this set. Alright, so I just want to scroll down to the top so I can explain. You can see all of these parameters. So just as we have humans that got attributes, processes also have attributes as well. And from this display you can see the user. Alright, you can see the PID, you can see the percentage, CPU, the memory size, the VSZ. Alright, so let's start from this parameter. So this field represents the user that is running the process. So for example, this process ID 1, Alright, the user that is actually using this process or running this process is the root user. Alright, while the PID represents the process ID and it is unique. So you can see the process ID 1, the process ID 2 till 20 till you begin to scroll down. You see all the numbers of the processes running and the process IDs. Alright, and the third parameter here is the CPU, percentage CPU, which represents the amount of the CPU the process is using, alright, in percentage. And the next value is the memory, alright, which represents the amount of the memory the process is using, alright, also in percentage. While the VSZ here represents the virtual memory size, and the virtual memory size is the memory size of the process that has been reserved and has access but not currently in use. Alright, and the next value we have here is the RSS field, which means resident memory size. The resident memory size is the memory size that has been allocated to the process in RAM. Alright, and we have the next one, which is TTY. This TTY represents the terminal the process is running on. Alright, so for a process that is running in the background, you will see this question mark. Alright, but for a process that is not running in the background, you will see the terminal the process is running on. So let me just scroll down if we can see one here. So we can see the terminals here the process is running on. Alright, so let me see if I can see another one. Alright, so you can see another one here. Okay, so let's look at the next value here. The next value is the start value, and this represents the current process's state. Alright, the S here means this means that the process is in interruptible sleep state. Alright, so it is waiting for an event to complete. Alright, while R means that it is in a running state, alright, on a run queue, while high means that this is high, looking for just high. Alright, so I means that it is idle. Alright, so it means idle kernel thread. While this lesser than represents high priority, not nice to other users. Okay, so let's look at the next parameter, which is the we're using the BSD. I think I screwed way too up. Alright, so the next parameter is the start parameter, and this field represents the start time of the process, while this time, alright, parameter represents the total number of time the process has been running. Okay, while the command, which is the last parameter, that this field represents the command associated with the process. Alright, so these are the commands associated with the process. So for example, this is kthread. Alright, this is the RCU_GP. I want to look for a common one that we can easily explain with. See if I can see a common one here. Alright, that's not a problem. As we go on in this course, you would understand all of these attributes very well. Okay, so in the next video, I'm going to show you what a parent and a child processes, and we're going to talk about a parent and a child process. Alright, so thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, welcome to the second section of this video. Today we're going to look at what a parent and a child process is in Linux. In our previous video, we've looked at what a process is. We've looked at how to view and list the processes in Linux, the number of processes that are also running on a Linux system. We've also looked at the process attributes. We've looked at the user, the PID, percentage, CPU. Okay, And quick one, if you're going to be writing the RHCSA 8 exam or the LFCS exam or the SUSE Linux exam, just scroll down to the end of this website and click on the exam practice questions. Alright, I'm going to be dropping the link to the website in the description section below, so it's good you practice before you write the exam. And I'm also going to be updating the website from time to time with the exam practice questions, so it's good you subscribe to our news channel, to our YouTube channel, or to our newsletter. Okay, just as we humans give birth, our process also gives birth, but not to a boy or a girl. Alright, a process can run as one process or also spawn or initiate other processes. Alright, so the other spawned processes are equal to the parent process. Alright, and the other spawned processes that are equal to the parent process are child processes. So while the processes that spawns or initiate the other processes are parent processes. So a parent gives birth to a child, alright, and parent processes to usually have a parent process ID, and the parent process, the PPID, which is the parent process ID field, was what we saw when we used the standard, the PS-EF, alright, to check all the running processes on the system. So let's see what a parent and child processes looks like. So if I use the command PSFAX, for example, you can see the tree-like process. Let me just scroll to the top. So for example, you can see this process, okay, and then you can see this ones that branches out. Okay, this is a very good example. You can see this one branching out to all of these. So this process, alright, is going to be a parent process for all of these processes. Alright, so these are child processes, or can I use the word children processes? So this is a child process, alright, to this parent process, while this is a parent process to this child processes. Okay, let me look for this process, for example, this 233. So to get the parent process ID, alright, we can just use the command. Let me just copy this and see how we can get the parent process ID. So we can just use the command PS, alright, -o ID equals to the, oops, I didn't copy that. Okay, let me just pick one here. Let me pick this 3279. So I'm just going to use 3279. So you can see the parent process ID of this process. Alright, so these are the parent process IDs. So if I kill this process, okay, or I kill here or here, then this process will also die. Okay, so if you kill a parent process, the child process will die, and if you kill a child process, the parent process will not die. As we go on, we'll look at how to kill processes in Linux. To view a process tree, you use the command ps_tree. Alright, you'll be able to see the process tree. Okay, so how do you find a specific running process in Linux? Alright, so if you don't want to see all the running processes, you can just view or see a specific running process. And to see a specific running process, you can pipe the command to the grep utility. One thing you must know is that every processes have a process ID, as I've always said. So if a process is running, the process ID is also associated to the process automatically. So for example, to see the process ID of the HTTPD process, use the command ps-ef. Alright, then you grab this to HTTPD. Don't forget, I said this is the standard syntax. You can either use AUX, which is the BSD syntax, whichever one you like and whichever one that is preferable for you, both will work. They're just different syntaxes. So alright, so you can see the process ID of the HTTPD process. To see the process ID of the VSFTPD process, you can just follow the same approach, VSFTPD. Alright, so you can see the process ID of the VSFTPD process, and you can also use the command PID of, for example, PID of VSFTPD. It will show you the process ID of this process or service. Okay. In the next video, we're going to look at how to kill a process in Linux. We're also going to look at how to do with a job in Linux. Alright, so thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course, and we're going to be looking at managing process in Linux part 2. Alright, so in part 1 we've learned what a process is, we've learned what a parent and a child process is too. So having understood part 1, it is high time we learned how to kill a process in Linux. Alright, so we're also going to learn what the job is in this part 2. Okay. Killing a process in Linux has to do with sending signals to the process, and there are some situations where an application will stop responding, and you may have done all the necessary things to stop and start the application, but it never just comes up because the real process is still running and was never stopped in the real sense. The only way to come out of such sometimes is to kill the process. Alright, so when you terminate the process, then the application can be started again afresh. Alright, so there are many types of signals available in Linux that you can send to processes. So let's check the man page of signals to understand what some of these signals are. The man 7 will give us the type of signals we have. So I'm just going to scroll down, and you can see the different signals that we have. Okay, we have the SIG STP, the SIG TIN, the SIG bus, the SIG pole, the SIG trap. Alright, but what I'm actually interested in, or what we are interested in this study, there are two signals that we're interested in, which is the SIG kill and the SIG term. Let me just look for these two signals. Alright, so this is the SIG kill. Alright, so this is kill signal. Alright, and this is the SIG term, and this is termination signal. These are the two signals that we are interested in. Alright, to kill a process in Linux, you will have to send the SIG term or the SIG kill signal to the process. Alright, so the SIG term signal kills a process gracefully, while the SIG kill signal kills the process abruptly. So, like, I mean, when I say gracefully, you know, it takes the due process in killing a process. But when I say abruptly, if the process is just misbehaving, and you can just use the SIG term signal. The SIG kill signal to kill the process abruptly. Alright, so you also need to be careful while using the SIG kill signal, because some processes may be doing the critical job at the time you use the SIG kill signal, which may corrupt the job. Alright, so the SIG kill signal should not be used at all times to kill a process, and should be avoided if it can be avoided, especially on critical processes. Okay, so the idea is you first use the SIG term signal, and if the SIG term signal doesn't work, if it doesn't kill the process, then you can use the SIG kill signal. Alright, so to kill a process with the SIG term signal, you just use the command kill and followed by the name of the process. So for example, let's get the process ID of the vsftpd. So that's 4426. Okay, don't forget you can also use this command like we've discussed in our previous video. You can use ps-ef, then you can grep this to vsftpd. Alright, so you can see the process, which is 4426. Okay, so to kill this process, you use the command kill followed by the process ID, which is 4426, and this process should be killed. So if I view this process, the status of this process, you can see that the process is dead. Okay, and if I do PID of vsftpd, the process isn't running any longer. Alright, so the process is dead. Let me just start the process again. Alright, and if I do status, the process is running again. So if I want to kill the process abruptly, that is, if I want to send the sig kill signal, alright, so what we did first was to send the sigtem signal. Alright, so now if I want to kill the process using the sig kill signal, I'm just going to use the command kill. Let's get the PID again. So the PID has changed. Okay, so to kill this process, I'm just going to use the command kill followed by -9, just like I showed to you when we looked at the man page of the sigtem and the sig of the signal, the man page of the signal command. Alright, we saw that the sig kill has the -9 option. Let me show you again. This is man 7 signal. So you can see the sig kill having the value of 9 and the sigtem having the value of 15. Alright, so if I want to use the sig kill signal this time around, I'm just going to use the kill -9 followed by 5172. Okay, so this will kill the process abruptly. And if I do the status, so you can see that the process is dead, and this time around it's even saying failed. Okay, so like I said, always use the sigtem signal by killing the process this way. Understand? And if this doesn't work, then you can always use the sigtem signal to kill the process. Okay, you can also kill a process with the process name. So for example, if I want to kill this vsftpd process with the process name, I'm just going to use the command pkill followed by vsftpd, and this will kill a process using the process name. Alright, so in the next video, I'm going to show you what a job is and how to use a job in Linux. We're also going to look at the process priority and niceness. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this video. In the previous video, we've looked at how to kill a process in Linux, and in today's video, we're going to look at what a job is in Linux. So a job in Linux is a program that is not running as a daemon, so it doesn't run as a background process. Alright, so a job is started interactively on the shell. For example, the command ls, mv, cp, etc. are all jobs. They do not run in the background as a process, though they are processes logically, because everything that runs on the system runs as a process. A job cannot be made persistent after a reboot, so it just runs on the Linux shell. And there are some jobs that keeps the shell busy for a while, thereby making the admin redundant until the job gets completed. Although if a job is keeping an admin for a while, you can easily just right click and then get a new session. Alright, and you can log in to continue whatever thing you want to do. But if you don't want to do that, there are ways. There are ways you can actually put a job in the background, and then you can continue to do what you want to do. All right. One of the jobs that take a long time is when you're using the DD utility to make a flash bootable. I remember that takes time a lot. And another one is if you're trying to copy a large file, that takes time too. So for you to clearly understand what I'm trying to say here, let's make a dummy command using the DD utility. So for example, if I use the command DD if, let's just make a dummy of this. This should be off. Alright, so you can see that the command keeps the shell busy and would not release the cursor. Alright, and as a user you can make this kind of job run in the background so that you can continue to do other things you want to do. Alright, so to make a job run in the background, it can be done two ways. You can either do that immediately when you're running the command, or you can do that after you've run the command. So in this case, I'm just going to press the Ctrl+Z command, and I'm going to use the command bg, meaning that put this in the background, and you can see that the job is running in the background. Alright, another thing I can do is to, if I know that I want to run this job in the background, or if I know that this job is going to take a while, I can just run the job, and at the end of the job I can put the ampersand sign, and that means that this job should run in the background. And to verify the jobs that are running in the background, you can just use the command jobs. Alright, so you can see that we have two jobs running in the background, the first one and the second one. One thing you must know is that when you put a job in the background, alright, it keeps queuing until the jobs are done. So if I have another job, it's going to queue, alright, and when the jobs are done, it's not going to be here when you run the command job again. So to bring the jobs back to the foreground from the background, you use the command fg. So depending on the job you want to bring back to the foreground, so I have job 1, I have job 2, so I can just use the command fg1. That means I want to bring the first job back to the foreground, and you can see that my shell is busy again and the job is already in the foreground. Alright, to terminate a job, just use the command Ctrl+C, and you can see that the job is terminated. Okay, so in the next video I'm going to show you, we're going to talk about niceness and priority, process niceness and priority in Linux. Alright, so thank you for watching, and please subscribe to this channel. And if you're going to be writing the RHCSA 8 exam or the LFCS exam or the SUSE Linux exam, just scroll down. I'm going to be dropping the link to this website in the description section below. Right, just scroll down to the end of the tutorial, click on the exam practice questions so that you can practice it with. And we have a lot of practice questions, and we're going to be updating the site from time to time. And it's better you subscribe so that you can always get the latest updates. Thank you once again. Bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course, and we're going to be looking at managing process in Linux part 3. In part 1 and part 2 we've talked about what a process is. We've looked at how to kill a process. We've done a lot of things when we looked at what a process is. Alright, and in this video I'm going to show you how to nice and renice a process. Okay, quick one: if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LFCS exam, just scroll down to the end of the website and click on the exam practice questions. Alright, so I'm going to be updating this website from time to time with the latest practice questions, so you can practice before you write the exam. Okay, so what is Linux process priority and niceness? Every process in Linux has a process ID as well as a process priority. Alright, we established that in the previous video. Okay, and when I say every process in Linux has a process priority, that is the amount of system resources allocated to a process. Okay, so every process, when they are started, are assigned the same process priority. What I mean is that they run with almost the same amount of system resources, except in a few cases. And however, the priority of a process can be changed. Alright, so for example, if a process is such that it will take time to complete, you can nice such process, that is, give it a higher priority than other processes by assigning a higher amount of system resources to that process. Okay, and also, if a process is slow or taking time to complete, it could be a job as well as it could be a job, alright, and it could also be a background process. Alright, you can renice that process and assign a higher amount of system resources to that process. So in essence, nicing and renicing a process, in other words, is setting and resetting or changing the priority of a process. Okay, so it's just simply giving more CPU time to a process than the other, and it can either be a positive or negative. So as we go on in this configuration, you would understand more of this. And you should also know that one can change the priority of a process by assigning a higher amount of system resources or processing power to the process, or reducing the amount of system resources from the process. So this will depend on the nice or the renice value that will be used to change the process priority. Okay, so let me just quickly explain how to nice and renice a process before we also look at the configuration. There are 140 priorities, but I won't delve into that for now, not to go out of the scope. But changing the priority of a process depends on the nice value you give to that process. A nice value can range from -20, which is the highest priority, to +19, which is the lowest priority. And if you have a negative nice value, more processing power will be assigned to that process. On the contrary, if you have a positive nice value, processing power will be reduced from that process. So furthermore, to nice a process, the best practice is not to do it aggressively. Okay, so for example, if you want to change the process priority from 20 to 9, it is best to change the nice value bit by bit and not do it all at once, except if the difference in the number is not wide. Having understood this concept, alright, I'm just going to show you how to nice and renice a process, and that's what we're going to do in the next video. Alright, so thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, welcome to the next section of this lesson. Today we're going to look at how to change the priority of a process, that is, how to renice a Linux process with examples. And quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LFCS exam, just scroll down to the end of the website and click on the exam practice questions. Alright, so we're going to be updating the website from time to time, and we're also going to be updating with the recent questions as well. So it's better you practice before you write the exam, and I'm going to be dropping the link to the website in the description section below. You can also come to the website and click on the RHCSA 8 exam practice questions here too. Alright, changing the priority of a process or the niceness of a process can be done by using the top command, and you can also use the CLI command. So to renice a process, that is to change the nice value of a process that is already running, you can use the command top. Alright, so this will show the processes that are consuming higher resources, that is the top processes that are consuming the higher resources on the system. So for example, you can see PID, which is the process IDs. You can see the user, which
are the users that are using this process. All right, so you can see the PR, which is also the priority of the process. So the priority here is 20, the priority here is 0. You can see the nice value, which is 0. You can see minus 20. All right, so to renice a process using the CLI, we're going to use the top command first before we use the CLI. All right, but before we do that, let's just quickly see how to check the priority and nice value of a Linux process using the PS command. So for example, if my system is hanging. Okay, so for example, if I can do PS, right? I think EO, the process ID, which is PID, followed by parent process ID, followed by priority, followed by the nice, then followed by the command. So you can see that I can get all these values from here. And so to check the priority and the nice value of a process ID that is running, you can also use that command and grep it to that process ID. So for example, let me run the dd dummy command just to create a process that we can use as an example. So I can do this dev 0 of dev null. All right, let me just run this job in the background. Okay, so this, I have talked about how to do this in the previous video. You can see that it is a job that is running in the background, and for me to see this process, if I do top, you can see the dd command. All right, and you can see the process ID, which is 7874. all right, 7874. So if I just do this and grep this to 7874, you will be able to see the process ID, which is this, and the parent process ID, the priority, and the nice value, followed by the command. So to renice the value of this process and change the priority, all right, you can use the top command, and you need to enter the key R, which means renice. By the time I enter the key R, you see that this tab was given to me, which has this process ID. Okay, if the process ID is not the value you have here, you just need to enter the value. So I can just say 7874, though that's the value, but I'm just doing that so if you want to renice the another process, all right, so press the enter key. You can now renice PID to, you can enter any nice value. All right, so I want this to be minus 7. Okay, and I'm just going to tap the enter key as well. Okay, so you can see here that the CPU time has increased to 99.7. all right, so I've been able to add more resources to this process, and the priority value, of course, has changed to 13. all right, so there's more CPU power. Don't forget when we mentioned that the priority or the nice value, of a process can range from -20 to +19, and -20 we have the highest priority, so the negative ones we have the highest priority. all right, so if I do -7 or -1, you know that I'm going to really have a high priority. Okay, like we said, the priority of a process can also be changed using the command line. all right, so to change the priority of a process, let's run this process again. This is process 7970. all right, so to renice
this process using the CLI command. Let's verify with this command, which is 7970. Alright, so you can see the nice value and the priority. Let's verify the current CPU utilization. So I'm just going to do this 7970, okay, -O percentage CPU and percentage memory. O, not 0, my bad. Okay, so you can see the CPU percentage and the memory percentage. Okay, so to change the priority and to give the process a nice value of -7, I'll just use the command renice the nice value, that's -n, followed by -7, and the process ID, which is 7970. Okay, so you can see here that the old priority was 0 and the new priority is -7. So let's verify again. Alright, so you can see the new one to be -7. Alright, and the priority has increased to 26. So you shouldn't get confused. There's a little not really discrepancies, but there is a way the value is being displayed when you use the command line, and there's a way it's being displayed when you use the top command. Alright, so if you check the percentage, you can see that it has actually increased. Alright, so what you need to be very sure of is when you understand the priority values, for which is from -20, okay, and the negative ones will have the higher priority. Alright, if I use the top command on this process, you can see that it is the same. Okay, so you don't have to get confused. Alright, so when you use the command line, the priority would increase instead of decreasing when you use as against when you use the top. You see, let's just do this again so you see what I'm trying to explain. So you can see the priority, so it's just adding it to the former priority, whereas when you use the top command, it's going to be decreased. But the main thing is you should just understand how priority works, okay, and we've been able to achieve our aim. So now that we know how to renice a process, so let's see how we can nice a Linux process. Okay, so this is how to set the priority of a process when the process has not started running. Alright, so say for example you want to start running a process and you just want to set the nice value of that process before you start running the process. So for example, if I want to run the same DD process, alright, I can just say, okay, I want the nice value of this process to be 11, okay, and I'm going to, this is going to be off. I'm going to run the command. Okay, so this is a command that, I mean, you're going to be having it lingering on your system. So let's just run this again so we can be very sure. Alright, so you can see that this is done, and this is the job we have. That's job 4, the job ID. Let's just run the top command. Alright, so this is how you can nice a process in Linux. Okay, so thank you for watching. Now you know how to renice and nice a process in Linux. Now you know how to change the priority of a process in Linux. Alright, so please subscribe to this channel, and bye for now.
Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at the Linux boot process, part 1. Every operating system have a process of booting, but before I talk about the boot process of the Linux operating system, I'll first talk about the basic boot process of the most operating systems. So what happens when you power on the system, which is the first thing you need to do actually. So you power on your system and after that the CPU starts, okay, and passes the next process to BIOS. Then BIOS is loaded, okay. Then BIOS will start the post, which is the power on self test, and post will scan, and if the test is passed, the next process is passed to the boot sector, okay, and the boot sector launches the bootloader, and the bootloader is executed depending on the operating system's bootloader, and then the bootloader will load the operating system. So that's just the basic boot process of operating systems. All right, so if you want to know more about what BIOS is, post is, and bootloader and all of these concepts, it's a basic computer concept that you should know about. But if you don't know about it, I'll be dropping the link to this website in the description section below, so you can just come and read about it here. Alright, so the focus of this video is to look at the Linux boot process. Alright, so let's look at the Linux boot process. So when the system is powered on, which is the first thing, the CPU starts, alright, and it passes the next process to BIOS, just as we've said. Then the BIOS is loaded, alright, and the BIOS will start the post, and if the test is passed, the next process is passed onto the boot sector. Alright, the boot sector launches the bootloader, alright, just like what we've said here in the basic boot process. And this step 6 is that the bootloader is executed depending on the operating system's bootloader. Alright, so in step 6, of course, the bootloader is executed. But in Linux, we have in the old Linux systems, the bootloaders we have the Lilo bootloader. So we have the grub, followed by the grub, and followed by grub 2. So we are dealing with Red Hat 8 here. So we're not using this bootloaders anymore in Red Hat 8. So the bootloader that is going to be executed is the grub 2. Alright, and after this step, the Linux kernel is then executed. Alright, then devices initialized, the modules and init RAM disk are loaded, and followed by the bootloader. The bootloader then loads the operating system, okay, after which the root file system will mount, okay. And for a modern Linux system running system D, as we go on in this course, you will get to understand what system D is and what sysvinit is. Alright, so modern Linux systems like Red Hat 7 and above, they run on system D. So for the ones that are running on system D, the next process is that the system D will run along with its dependencies, and it becomes the first process, the first PID, that's process ID, alright, and then followed by the default run target. Then the default run target will start along with its dependencies, after which the root file system is checked. Then the remaining local file systems are mounted, okay, and then the network devices will start, followed by the root file systems starts, and they will start if it is configured, of course, and then the login prompt displays where you see the login prompt that asks you to put in your username and your password. Alright, so that is pretty much it, the Linux boot process. Alright, and for systems that are running sysvinit, we're not actually dealing with sysvinit, but this is what happens actually. The init programs will load, the etc init tab is read, and run level scripts run, the default run level starts, and that's the process of the sysvinit. But we're not dealing with sysvinit, we're actually dealing with system D systems. Alright, and so in the next video I'm going to show you what this is, what sysvinit, system D, the run target, so you fully grasp the Linux boot process. Alright, so thank you for watching. And quick one, if you're going to be writing the LFCS exam or the RHCSA exam or the SUSE Linux exam, just come to this website, alright,
and click on the RHCSA exam practice questions so you can practice before you write the exam. We're going to be updating the website from time to time, and we have over 100 questions that we still need to solve. Alright, so thank you once again, and bye for now. Hi everyone, my name is Victor, and welcome to the next section of this video. In the previous video, we looked at the Linux boot process. We looked at the step-by-step process of how the Linux operating system boots. And in step 11, we mentioned system D. We said system D would run along with its dependencies. We also mentioned default run target 2, which will run along with its dependencies. All right. So what is this system D, and what is this run target, and what is sysv init? All right. And what are these dependencies? This is what we're going to look at in this video. All right. So what is system D? System D is the program that is responsible for managing processes in the system D Linux operating system. All right. So a system D is a daemon or a process manager that starts as soon as the system is powered on, and it is the very first process that is started by the kernel. As such, it is the parent process of other running processes on the system, and it has a process ID of 1. All right. If system D has issues starting, no other processes will be started. As I said, it is the parent process of other processes, so other processes depend on it. So what is sysv init? All right. So before system D, the process manager was sysv init. As tech evolves, sysv init shortcomings became obvious, and as such was replaced with other system management daemons, such as we have upstart, we have epoch, we have model, and we have system D. All right. And system D is our focus in this subject matter because system D is currently the default initialization and service management process of almost all modern Linux operating systems, especially on Red Hat 8 that we are looking at in this course. All right. However, some developers don't see the need to replace sysv init, hence why it has become a controversial discussion, which I won't discuss in this video. All right. So not to go out of the scope of study. An advantage of the system D over the sysv init system is that it prioritizes services and reduces startup time compared to sysv init. All right. So now, now that we know what system D is and sysv init, of course, let's understand what run level and run target are. As I mentioned in the boot process step 12, that the default run target will start after system D has been initiated. So what is this run target? Run target is the system mode that controls the operations of the system in accordance with the services that are available by the mode. Anyways, don't stress yourself too much. You will understand better as we go on. And the system can run in different modes or different run targets depending on the preset mode. And the mode that the system is set as default is what the system will boot with and becomes the system state. So it is safe to simply say that run targets are the modes the system runs in. All right. So I think the next question would be, what are these system modes? What are these system run targets? All right. So, but before then, let's talk about run level. All right. Run targets is also run level. All right. So the sysv init system uses run level, while the system D system uses run targets. It's funny, right? Anyways, that's the way it is. Okay. And of course, the difference is that the sysv init system will have different run levels from the system D's run targets because they are different programs altogether. But when you're using run levels, mostly it comes with sysv init, and run targets mostly comes with the system D system. All right. So let's look at the sysv init run levels. Okay. So the sysv init run levels are, we have the 0, which is alt, which means shuts down. All right. And we have the 1, which is the single user mode. which is the rescue mode, alright. And we have the 2, which is the multi-user mode. We have the 3, which is the full multi-user mode. We have the 4, which is the unused. We have the X11, which is the 5th mode, and we have the 6th mode, which is the reboot mode, alright. And if the system's default run level is set to 0, which is the shutdown mode, it means that as soon as the system boot process gets to the system, to the sysv init stage, the system halts and it shuts down, alright. Anyways, we are looking at Red Hat 8, so we're concerned with the systemd run target, alright. So the systemd run targets are, we have the mode 0, which is the power off the target. We have mode 1, which is the rescue.target. We have the multi-user.target mode, which is the non-graphical full network and the multi-user interface, alright. We have the multi-user target, which is non-graphical, of course, full network and multi-user. We have the multi-user.target, which is non-graphical, full network and multi-user, and we have the graphical target, which has the graphical desktop and multi-user, and we also have the reboot target, alright. And you can see that the run target 2, 3, and 4 have the same functions, unlike sysv init that is different, alright. You can see this, the mode 2, 3, and 4, which is different from the systemd run target. So if the default run target is set to 5, alright, it means that the system will boot into a multi-user mode, okay, and it will also have the full graphical desktop mode, alright. And if the default run target is set to 6, you will just see that your system begins to reboot as it is trying to come up, alright. So these run targets are very important, and the default run target that your system should be set to, alright, most times, especially when you are in an enterprise environment, is always the 5th mode, alright. It actually depends on the environment you're working on, and sometimes when you want to do some troubleshooting, you can change the mode from the 5th mode to either the 1st mode, which is the rescue mode, or the 2nd mode, depending on what you want to do, alright. In the next video, we'll look at how systemd works and how we can also change to different modes, alright. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the 3rd section of this video. In the previous sections, we've looked at the Linux boot process. We've looked at what systemd is, and we've also looked at what sysv init is. We've looked at their run levels and run target, alright. So in this video, we're going to look at how systemd works, okay. So systemd uses what is called unit files for its management, and these unit files can be found in 2 directories, alright. One which is the user lib systemd system directory, alright. This directory contains the systemd's default unit files, alright, and the second directory is the etc, alright. The etc systemd system directory, and this directory is the directory the administrators can define their unit files. We've talked about this I think in the previous chapter when we looked at managing processes in Linux, alright. And to verify the run levels for systemd system, you use the command ls-al, alright. So we're talking about run target for systemd, just as we said. I can just do this. Sorry, there should be system here. Okay. So you can see here the main 6 run targets that we have. You can set the power of the target, the rescue.target, the multi-user.target, just as we've mentioned, alright. You can also see targets like the sleep.target. You can also see the slices.target. So does this mean that a systemd system can be running on more than one target? The answer is a big yes. But other targets are dependencies of the main target. Alright. In the Linux boot process step 12 in the previous videos, the default run target, just as we said that the default run target starts along with its dependencies, which of course may include other targets as its dependencies. All right, so let's look at the default target this system is running on. Okay, we'll also look at the dependencies as well. So to get the default run target, use the command systemctl. That's the utility we're going to be using, and we use systemctl get default. Alright, so this will show you the default run target that your system is running on. Alright, and you can see that this system is running on the graphical.target. And to look at the dependencies, that is other targets that is associated with this target, use the command cat user lib systemd system, then graphical.target. Okay, so you can see that the graphical.target requires the multi-user.target. Okay, it also wants the you can see other dependencies as the display manager.service and the rescue, the conflict equals rescue.service, which is also rescue.target. Okay, if you look at this rescue.target, alright, you see that there are other targets which are dependencies that is also associated with this target. Alright, so you can see that the graphical.target requires multi-user.target as well as its conflict with rescue.target. Okay, so let me just quickly show you for multi-user.target. So you can see other dependencies that are associated with that too as well. Alright, so you can see that the multi-user.target would require the rescue.target as well, and would also require we have the basic.target. Okay, so this tells you that systemd runs on a major target, alright, and other targets that are dependencies of the major target. To view the current run level or run target of a Linux system, you use the command run level. Alright, so you can see that this is running on run level 5 or run target 5, and this n means the previous run level before this. Okay, so that means you're running on the graphical.target, which is number 5. Okay, and also to change the run level of a Linux system, you can use the command. For example, if I want to change this run level to run level 3, I can use the command init3. Okay, so you give it some time, so you let it change. It's going to take a while, alright, and then you can also use the command run level to see the current run level or run target as the case may be. So you can see now that you're currently running on run target 3. Like I said, this is always the previous run target, while this is the new run target. Alright, and you should also know that this settings is not persistent, so it's not going to work across reboot. To make this settings persistent, you need to use the command systemctl set default. Alright, then the run target or the run level. So for example, I want to go back to the graphical.target, so I can use the command graphical.target. Okay, so this will make the settings persistent. So let me just go back to the run level 5, which I was running before. And let me confirm this. oops, this should be run level. Okay, so you can see now that I'm back to run level 5. So in the next video, we're going to look at the bootloader and continue with the Linux boot process. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at the Linux boot process part 2. We're going to be looking at the Linux bootloader. In part 1 we looked at the step-by-step boot process of the Linux operating system. We looked at what sysvinit, what systemd is. Also we looked at the run target of systemd, and we looked at a lot of things in part 1. And quick one, if you're going to be writing the RHCSA 8 or the SUSE Linux exam or the LFCS exam, you can scroll down to this end of the lesson. So at the end of every lesson, there is always a practice question, alright, that you can practice with, or you rather come here and click on the exam practice question. It's very good you practice before you write the exam. And we're going to be updating this website from time to time with practice questions, so it's better for you to subscribe to the YouTube channel or to our newsletter. Alright, so let's talk about the Linux bootloader. As the name implies, a bootloader is a program that starts up or loads the operating system. Okay, so in the time past, the Linux operating system's bootloader was Lilo, which is Linux loader. Alright, Lilo means Linux loader. But as tech evolved, Lilo was replaced with Grub, and the likes of Red Hat 6 used Grub. And as tech evolves again, the Grub was also replaced with Grub 2. Grub 2, which means Grand Unified Bootloader 2, which the likes of Red Hat 7, Red Hat 8 is now using. Alright. And Grub 2 is a powerful bootloader, and it has a boot menu where user can choose which kernel to boot from. I mean to boot with. Alright? And if a user does not choose any one, the bootloader after some time or after some seconds, depending on what you've set, continues to boot to the default operating system. Alright? So when the boot process is going on, at the point where you get to choose the kernel to boot with, this is what you're going to see, just like this that you can see on my screen where my mouse is hovering. Alright, so if you do not choose in the boot menu, if you do not choose the kernel to boot with in the boot menu, it's gonna boot with the default kernel. I remember that sometimes I may have to boot, I will need to boot with the Linux kernel that is different from the default as a result of the fact that an application after a kernel update refuses to function properly, or the operating system itself begins to misbehave. So as a result, you may boot the system with the old kernel, and the only program that allows you to do this is the bootloader, which can be done from the boot menu. Alright, so let's look at the Grub 2 configuration file. Don't forget that the bootloader we're dealing with here is Grub 2. So let's see the Grub 2 configuration files. Because to make changes to the boot menu or Grub 2, you will have to edit the Grub 2 configuration files, right? And the Grub 2 configuration files is in the part etc. Let me just put hash here. Okay, so it is in the path etc default grub, okay, and also in the path etc grub.d. Alright, so let's look at the etc grub.d path. So I'm just going to cd here. Okay, I'm going to do ls. So you can see the grub2 configuration files in this path. If you're not a grub expert, or if you don't know what you're doing, Do not tamper with the configuration files in this directory. The scripts in this path are very sensitive and I advise you not to touch them. If a user needs to make changes to grub2, it is advisable the changes are made in the etc default grub file, which is the first one I showed to you. Alright, so let's look at this etc default grub file. Let me just copy and paste here. This is going to be /etc. Okay, so you can see the parameters in this file. The first line, which is the grub timeout equals 5, indicates that the grub2 timeout in the boot menu would be 5 seconds. Alright, so if a user refuses to select a particular kernel or the operating system to boot with, after 5 seconds, grub2 will start with the default kernel. And if you think that 5 seconds is too short and you need to make changes, just edit the line by changing 5 to your desired time. And another important line in the configuration file is this grub cmd linux line. Alright, this line here. And this parameter is what the kernel uses to boot. So the parameters in here will be passed to the kernel at boot time, and it can also be edited depending on what you want. So for example, if you need to disable the sysdate of the system, if you need to add the sysdate parameter in that line, alright, if you also want to remove the Red Hat graphical boot, if you want it to be quiet, you can also do that on this line. Alright, so this is mostly done when it comes to the RHGB quiet line. This is mostly done when you're configuring kdump, but you don't need to know that in this course. Alright, one very important thing you should know is that making changes to these configuration files will not suffice. You would need to rebuild one very important grub2 configuration file after you must have made changes to these configuration files here. Alright, and that file is the grub.cfg. The grub.cfg. Alright, this file, it's a very important file that you need to rebuild once you make changes to the grub2 configuration files here. Alright, when we get to the managing Linux kernel chapter, we're going to update a Linux kernel, and you're going to see how we're going to rebuild this configuration file. But one thing I want you to know is that you should always back up the configuration file before rebuilding it. Alright, it is very important so that if anything goes wrong, you can always revert back to the configuration file. And this configuration file here, the full part is etc grub.cfg. Alright, let me just cut this file so you can see here. Sorry, grub2, not grub. Oh, my bad. So grub2.cfg. Okay, so this file is a symlink to boot. Is a symlink. We've talked about symbolic link in one of the videos, so I shouldn't be discussing that here. Alright, so it's a symlink to this file, grub.cfg. Let's just cut this file so I can be sure of the file. Alright, so you can see that they are the same thing. Alright, so it's a symlink to this file. Okay, and this file knows how to auto generate itself. Alright, especially when a new kernel is installed or upgraded. Sorry. Okay, so to rebuild the grub configuration file, you use this command to rebuild, or you use this command. Okay, or you use this command. Alright, so this is going to make more sense in the managing the Linux kernel chapter. Okay, so what I'm going to do in that chapter is that I'm going to upgrade a Linux kernel, and I'm also going to, after upgrading the Linux kernel, then I'm also going to rebuild the configuration, the grub2 configuration file. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this lesson. In this lesson, we're going to look at how to switch between targets using the bootloader menu. In one of the previous videos, we looked at how to switch between targets in an operational environment, where we used the init command to switch from one target to the other. Alright, so you should know that the switching of targets can be done in two ways. One is to do that from the operational mode, which we have done before, just like I've said, and the other one is to do that from the boot menu. Alright, so let's see how to do this from the boot menu. When the system is powered on, alright, and when the bootloader is initiated, on the kernel line you want to boot with, you press the E key. So for example, if you have many kernels, you can just scroll to the kernel line you want to boot with, and you press the E key, which means edit. Alright, and then you scroll down to the line Linux here, and at the end of the line you add the parameters. We had the systemd parameter, so here we write systemd.unit, okay, equals to, so if you want to change to the rescue.target, you put the rescue.target. If you want to change to the emergency mode, you put the emergency.target. And if you want to change to the multi-user mode, for example, you put multi-user.target. So in this case, I want to change to the rescue mode, alright, or the rescue target. So I'm just going to add the value rescue.target. So when you're done, you can press Ctrl X to boot the system into the set mode. Alright, so I'm just going to press Ctrl X, and then the system will boot into the mode we've set it to. So let's wait while the system boots. So now we can give the root password. So you can see that here it's saying we are in rescue mode. Okay, if you look at my cursor, my cursor is not really functioning on this console, alright. But you can see that you're in rescue mode. Then after logging in, type blah 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 and all of that. So let's give the root password. Okay. You see now that I'm in, and so anything that I want to do, I can begin to do it in this mode. Alright, and to exit from this mode, I'm just going to, that is to leave this mode and go back to the normal mode, I'm just going to type the command exit, and you can see that it's going to start with the default target. Alright, so the system is booting now to start with the default target, with the default run target. Alright, so this is how you can change the run target of a Linux system using the Linux the bootloader menu. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor, and I'm one of the authors of Technique.com. Today we're going to continue with our course. We're going to be looking at storage management in Linux, explained with examples. In Linux, there are basically two methods a disk or a drive can be partitioned. One way is by using the standard partitioning method, and the other way is by using the LVM partitioning method. So let's start with the standard partitioning method in Linux. Disk topology in Linux is always in the form of SDA. Then you see other disks to be SDB, SDC, just like that. If it is a virtual environment, you see it as VDA, VDB. So you can see this disk now. On the system, we have just one disk, all right, one hard drive, and you can see the hard drive to be partitioned into SDA1 and SDA2, all right. So that is the way the disk topology in Linux is. So it's possible I attach another disk. When I attach another disk into this system, you will see it as SDB somewhere around here. And I can partition that disk to be SDB1, SDB2, SDB3, SDB4, and so on and so forth. All right. So we're talking about the standard partition first before we talk about the LVM partitioning method in Linux. So to list all the disks and their partitions in Linux, you use the command lsblk, and that is what I've just done now. If I use lsblk, I'm going to be able to see all the disks with their partitions in Linux. So lsblk means list block. You will get to understand this SDA2 that is further partitioned into root and rel swap. When we get to the LVM partitioning method, you can see the type to be LVM. So just forget about this for now. We're talking about the standard partitioning method, all right? So in the standard partitioning method, when you see type here, you see it as parts, which is standard partition. So if it is a disk, you see it as a disk, and if that disk is partitioned, you see it as part, just as we've seen it here. All right. So there are some concepts and some terminologies you should know around storage in Linux. All right. So let's talk about the fdisk utility. So this utility is used to create a standard partition in Linux. All right. So if I have a disk SDA or SDB or SDC, and I want to create a partition on that disk, I'm going to use the fdisk utility to create a partition on that disk. And I can also use the utility, the gdisk utility too, to create a partition on that disk. All right. So let's talk about file systems in Linux. Just as we have different types of file systems in Windows, we also have different types of file systems in Linux, right? So file system is just a way, or rather a system of arranging files on the drive. So let's do this. Let's take this scenario. So for example, if you have a shelf and you've decided that you want to arrange your books into the shelf, so you can either choose a system of arranging the books into the shelf. You can either arrange the books horizontally or you arrange the books vertically. So that's a system you've chosen to arrange the books. So the same thing is also applicable in computer. So a file system is just a system of arranging files on the drive, and there are different. There are lots of file systems. So just as you have the horizontal, vertical, perpendicular way of arranging your books in the shelf, so there are also systems, different kinds of file systems in OS, in computer. So for Linux, for example, we have the XFS file system. So you can decide to arrange your files in the drive in an XFS way. We also have the ext4 file system, all right? We have the ext3, we have the ext2, we have the GFS2, we have so many types of file systems, all right? In Red Hat 7, Red Hat 8, all right, the XFS file system is the default file system, and it is a very good file system for basic storage. It's considered to be flexible and has good tuning options. So we also have the ext234 file systems. They were the default file systems in RHEL 6 systems and below. All right, so these file systems, they use a flat index file, and they're not very scalable as compared to the XFS file system. All right, so we also have the GFS2 file system. The GFS2 file system is basically used for clustering environment, active-active. I remember I've done quite a lot of active-active clustering with pacemaker, and I've used the GFS2 file system. So that's what you use for that bit. All right. So let's talk about knowing the type of file system for a particular partition. Everything that I've said here, we're going to do all of this with examples. So
I just want you to understand first before we start doing our configurations with examples. That reminds me, if you're going to be writing the RHCSA 8 examination, or you're going to be writing the LFCS exam or the SUSE Linux exam, just scroll down to the end of this website, all right, and come and click the DOMS or the exam practice questions of the examination you want to write. We're going to be updating this with the LFCS exam practice questions and the SUSE Linux practice questions soon. All right. And I'm also going to be dropping the link to the website in the description section below so that you can easily click on the link. So to know the file system of a particular partition, just use the command. You can use the command fsck-n, then the partition, which is dev, which means device. You need to always put the /dev, which is the device. I've talked about this in file system hierarchy and structure in the Learn Linux from Scratch series. All right. So you need to put dev, then SDA1 example. So you can see that this is an XFS type of file system. All right. So the next concept we should know about storage is the mount point. All right. So a mount point is a special directory or a path where drives or partitions are mounted on. So if I have a partition or a drive, for example, the SDA1, the mount point for SDA1 is /boot. So the /boot is a special directory that is always mounted on this drive. So without a mount point, you cannot use a drive. To get devices that are mounted on the system, you use the command df-h. You understand? So you can always see the current devices that are mounted on the system. So for example, you can see this mounted on. So this is a mount point /boot is currently mounted on the SDA1. Y slash this mount point slash is also currently mounted on this device dev mapper root. Okay, so as we move on, we'll look at how to create mount point in Linux. All right. So for this section of the video, I'm going to be stopping. I'm going to be ending this here. So thank you for watching. And in the next video, we're going to look at the fstab file. It is something that we also need to really understand before we go to configuring storage in Linux. So thank you once again for watching. Please subscribe to this channel and bye for now. Hi everyone, welcome to the second section of this video. We're going to be understanding the etc fstab file. All right, if you're going to be writing the RHCSA examination, just scroll down to the end of this website, all right, and come and click on the practice questions. For the people that's going to be writing the LFCS and the SUSE Linux exam, we're going to be updating the website soon, and I'm also going to be dropping the link to the website in the description section below. All right. The etc fstab file is one of the most important files in Linux. All right. And this file is used to automatically mount file systems or devices in Linux. And you can either populate this file by yourself or it can be self-populated during system installation. So let's see this file. In the process of the system booting, these files are read, all right, and the option specified in this file is used to mount the devices or the file systems. So look at the options specified here. Let's get to know what these options means. Okay, so let's see the first column here. This is the first column, and the first column is used to specify the device name. All right. So the device name can also be specified as either dev SDB1, and there are various ways of specifying the device name. You can specify the device name by using the UUID, which is the unique identifier, and you can also specify the device name by using a label. If you come if you want to specify the device name by using a label, if you come to the website, which I'll be dropping the link in the description section below, you will see the different ways of how you can specify the device name. I'm also going to do that when we start doing our configuration. Okay, so the second column to this is the second column. This is used to specify the drive or partition's mount point. Okay, so if you look at the second column here, this is the mount point for this device. So you would always use the second column to specify the mount point for a device, and the third column is used to specify the device or the partition file system type, which we've talked about. So this device was actually partitioned with the XFS file system. So anytime you're populating the FS file, you should know that the third column is used to specify the partitions or the device file system type. All right. So the fourth column is used to specify the device or partitions mount options. So this is the fourth column, all right? And there are various mount options. We have the auto and no auto options. The auto option implies that the drive or file system will be mounted automatically at boot time. And if you set it to no auto option, it signifies otherwise. Okay, so we also have the user and no user option. The user option implies that users on the system will be able to mount the file system. Okay, so while the no user option signifies that the users on the system will not be able to mount the file system or the drive. Okay, so we also have the exec and no exec option. The exec option implies that the files or binaries that resides on the drive should be executable, while the no exec option signifies otherwise. All right, and that's for security purposes anyway. So if you use the no exec option, then that means the binaries will not be executable. Okay, we also have the sync and the async option. The sync option implies that the IO, which is the input and output, or changes on the file system can be done synchronously, which is sync. That means it should be done instantly. And if it is async, which is asynchronously, it means that the changes in the file system should not be done immediately. It can be done when there are not a lot of activities done on the system. So we also have the arrow and the RW option, which means arrow is read only and RW is read write. Okay, so if you specify the arrow option, the drive will be a read only drive, and if you specify the RW option, it will be a read write drive. You'll be able to read and write on the drive. So we also have the SUID and the no SUID option, which implies that the file system or the drive should support the SUID and the SGID bit. And if you use the no SUID, it signifies otherwise. So this is where I'm coming to, because this is what you've been seeing, what you've seen in the etc fstab file when we check the file. So this is the default options, and this option rather default option, and it implies that the file system should use the default mount options, and the default mount options includes the auto, it includes the exec, it includes the RW, the SUID, the async, the device, and the no user. So all these options that we've mentioned here, if you use the default options, it takes all of this. Okay. The fifth column is used to specify the device dump option. So if the value is set to be 0, it means that the file system cannot be dumped or backed up with the dump utility. But if it is set to 1 and above, it means that the file system can be dumped or backed up with the dump utility. While the sixth column is used to specify if the device file system be checked for errors at boot time or not. All right. So if the value is set to be 0, it means that the file system should not be checked. but the value is set to be 1 and above, it means that the file system should be checked. And the value should take an order starting with the root file system with the highest priority of the value 1. Okay, which means that the root file system be checked first, while other file systems can be set to 2, which means that they can be checked afterwards. Okay, all right. So the best practice why populating the FS tab is to use the UUIDs to specify the devices. All right, as this is done, this is UUID. The UUID is used here to specify a device. So it is a best practice to always use the UUID because um, sometimes when you reboot a system, dev SDB1 or dev SDB might actually turn to be dev SDD or dev SDE. It can change, and that too could affect the FS tab file when booting. So it is always advisable, and the best practice is to always populate the FS tab with the UUID, or you use the label to populate the FS tab. Unless in some rare cases that I've seen, when you're using a multipath tool that like EMC, PowerPath, and the rest, that you know that when you reboot the system, it doesn't change, then you can specify this first column with the device name. All right. So now that we've understood this concept, let's start creating partitions with the fdisk utility in Linux. Okay, so thank you for watching, and in the next video, we're going to create partitions with the fdisk utility. All right, and bye for now. Please don't forget to subscribe to this channel. Hi everyone, welcome to the third section of this video, and we're going to be looking at how to create partition with fdisk utility using standard partitioning method in Linux. Alright, if you're going to be writing the RHCSA 8 examination, just scroll down to the end of the website and come and click the RHCSA 8 exam practice questions. All right. If you're also writing the LFCS and the SUSE Linux examination, you can also scroll down to come and click it here. We're going to be updating that as soon as possible. Okay. On my system, I'm going to create a partition with fdisk. So the first thing to do is to list the devices I have on my system. Okay, so you can see that I have the SDA, it's been partitioned already. So the device I want to partition is the SDP. All right, and look at the size here. It has the size of 5 gig, and it is a disk, just as we've explained. So I'm using a VMware virtualization software. So what I did was to just add another disk to this system, which is 5 gig. If you don't know how to go about this, you can just drop your question in the comment section. I mean, so I'm going to help you to do that. Now that I've verified my disk, so I'm going to use the fdisk utility to partition the STB device. All right. So you can see here that I can use the M command for help. If I need help, I'll just do M. All right. And if I scroll up, you can see different flags. I have the P, which means print the partition table. I have the D option, which means delete a partition table. And I have the N option, which means add a partition table. So what we want to do is to add a partition table. All right, so I'm just going to use the N option. Okay, so I have the option of adding the primary or the extended partition type. So, but we're going to be using the primary type. Okay, so you can see the next value here, which says partition number 1 to 4. So if, of course, this is the first partition that we're creating on the system, and so that's why the default is 1. All right, so I can either press enter key, or I will just use number 1. So let me just use 1. Okay. So the first sector is 2048, and that's the default also. So I can press the enter key. All right. And the last sector is the size I'm going to specify, this the partition size I want. So the disk is 5 gig, and I can add plus, I can just partition this to 2 gig, right? So that's 2G. Look at the options there. This is plus, and for a gig that's G, for megabytes that's M, for terabytes that's T, for petabyte that's P. All right. So we're doing for gigabytes. So I'm just going to use plus 2G. All right, and I'm going to press my enter key. So it's saying I should press M for help too, like we've done before. If you do P, it means that you should print the partition table. So that means that by the time you write to this configuration, this is what you're going to be having. You're going to be having dev SDB1. So you've been able to partition SDB to SDB1 with this sector size 2 gig, all right, with this ID, and the type is Linux. So for me to save and write this file, if you use your hem option, you see the option W. W means, let's look for that here. All right. Okay, so you can see W, which it means that write table to disk and exit. So we're just going to use the W option. Then we've been able to create the partition. So if I use the lsblk command again, you can see that the STB disk, right, as in partitioned. I said it before when we were explaining storage that if you do a standard partition, you see it to be parts just this way, and it's been partitioned to STB1, and the size we have is 2 gig. All right. So you should know that by default, a drive is partitioned to Linux file system type. So if you want to change the type of partition, you would use the T option. All right. So that if you don't want to use the Linux type, all right. So this is where you're going to specify the T option to change the partition type. So usually after creating a partition on a device, the next step is to format the partition with a file system type. So you should know that a partition type is different from a file system type. All right, and we've talked about 5 file system types. We talked about the XFS ext4. All right, so to format this device with, for example, with the ext4 file system type, we're going to use the command mkfs, that's make file system dot ext4, all right, on the device which is dev sdb1. Okay, so we've been able to format this partition to ext4. All right, so sometimes you might want to format the device with a label. All right, so to format a device with a label, you're going to use this command. All right, then you're going to use the -l option, and the label name, you can call it whatever name you want to call this. All right, and then you'll be able to format the device with the label name. All right, so when you format a device with a file system type, the next step you would do is to create a mount point. So that's not just the end of everything. You need to create a mount point to be able to use the device. So mount point is making a directory. All right. I can make a directory technique. So I want my mount point to be technique. All right. And after creating the mount point, the next thing we will do is to map the device to the mount point. So use the command mount. All right. The name of the device is SDB1. So the mount point, which is technique. All right, so we've been able to map the device to the mount point now. So if you do lsblk, for example, you're going to see that the SDB1 is now mounted on /technique. And if you also want to see the current file systems are mounted, when you do df-h, you can see that the technid, the mount point technid is mounted on the device SDB1. So from here you can begin to, you know, create your files or do anything you want to do with the device. All right, I can just do touch test one example. So I have my device ready. So whatever thing that I'm going to be, whatever information going to the device would always go through the mount point, which is technid. But you know what? If you shut down the system and you bring the system up again, you will not see this mount point anymore. And that is why you would need to always populate the fstab file, just as we've said, that it is responsible for mounting your devices automatically. So for this device to be mounted automatically when the system is restarted, we need to populate the fstab file. So to do that, we need to do first of all, let us get the block ID for the device SDB1. Oops, let's just do this. Um, all right, so this is the UUID. So we need to get the UUID for this device because that's what I want to use in the fstab file. So sorry, I meant UUID, not the block ID. So we need to get, for you to be able to get the UUID, you need to use that command that I've just run. So then let's open the fstab file. All right, so the device here, I'm going to use the UUID. Okay, just going to do this, followed by the mount point, which is technique, then followed by the file system type, ext4. I'm going to use default, right? So I'm going to use 1, I'm going to use 2. I can decide to use 0, 1, depending on how you want, depending on your mount options, the mount options you want to use. But this is fine, and I'm going to save the file. All right, so for me to be able to show that my fstab was well populated, I can do mount -a. All right, so if I don't get any error, so that means it is well populated. So when my system reboots, the device or the file system would automatically be mounted as well. You can also use the gdisk utility to partition a drive, but we don't need that. As far as we can use the fdisk, I can just do the video, but you don't need it in this course. All right. So in the next video, we're going to look at how to delete a partition. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the fourth section of this video. We're going to be looking at how to delete a standard partition in Linux using the fdisk utility. Alright, so if you're writing the RHCSA 8 exam or the SUSE Linux or the LFCS examination, just scroll down to the end of this website and click on the practice questions. Alright, so we're going to be updating it as often as possible, and also I'm going to be dropping the link to the website in the description section below. So to delete a partition, we're going to delete the SDB1 partition. All right. So first of all, let us unmount the. Okay. So to unmount a device or a partition, you can use the mount point, or you can just do umount/dev SDB1. Anyone would work. All right. So to delete the partition, let's use the fdisk utility as well. Fdisk on the device SDB. Okay. as usual, M for help, all right, and D, the flag D means delete a partition. We've looked at that in our previous video. All right, so let's delete a partition. So we've been able to delete the partition one. We only have one partition on STB, and we can use the P option to print, and we can see that we don't have any partition anymore. So let's write and save. Let's write and quit. So we've been able to save this. If you now do your LSBLK again, you'll see that you won't find any partition on this disk anymore. So this is how you can delete a partition on a drive. Okay, so we've come to the end of the standard partitioning in Linux. So in our next video, we're going to look at the LVM partitioning. There are some other things you might want to do, but this is not in the course, it's not in the curriculum of the course. So if you want to, for example, if you want to encrypt a file system in Linux, you can just come to the website and click on it, and you can see how that is being done. If you also want to create a partition with gdisk utility, you can also come and do that here. All right, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course, and we're going to be looking at LVM in Linux. All right, so LVM, which means Logical Volume Manager. Okay, so it is a management technology for storage. And before LVM technology, storage management has not been really easy, especially in the area of partition resizing. But now that LVM is around, storage deployment and management has become very flexible and easier to manage, more especially in the area of volume management compared with the traditional way of standard or partition or manual partitioning. All right, so this concept has actually changed the storage world positively. Okay, and using LVM comes with great and easy to do configuration. But before we start before we start all of this configuration, it's better to understand the concept and terminologies around the LVM. All right, so LVM, okay, you can see this chart, and you can see that in this chart I have PV, which means physical volume, all right, and I have VG, which means volume group, and I have LV, which means logical volume. All right, so these are all these concepts is what makes LVM. All right, and you can see that before you if you're using LVM, the end result of LVM is actually creating a logical volume, which is the partition, all right, which is the LVM partitioning, just like when we have the standard partitioning. But before you create the logical volume, which is the LV, all right, you would need to have a physical volume first. Okay, so a physical volume must be created, all right, then followed by the volume group, all right. You can have more than one physical volumes. You can have two, three, four, five physical volumes, and from that physical volume, you're going to create a volume group from that physical volume, all right. So if you, for example, if you have like 5 gig of this physical volume, another 5 gig of this physical volume, and another 5 gig of this physical volume, you can create a volume group of 15 gig. You can also choose to create a volume group of 12 gig, depending on what you want to create. All right, and now, so from the volume group, you can now create the logical volume. So say for example you have a volume group of 15 gig, so you can create a logical volume, which is the partition, which is the LVM partition. So you can say, for example, you create a logical volume of 2 gig. All right, you can create another partition, which is the logical volume of 1 gig. You can create another partition, which is the logical volume of 3 gig, depending on what you want to create. So the end result of LVM basically is creating the logical volume. All right, and before you create the logical volume, don't forget you need to have your PV, which is your physical volume, and from your PV you're going to create your volume group, and then from the volume group you can create your logical volume, which is the partition we're talking about. There are a lot of advantages that comes with using LVM, all right, and one of the advantages is easy volume resize option, all right. So if you're using LVM, okay, volumes can be reduced or extended easily. Another advantage is the easy storage management, all right. So if there is a need to create a partition from a particular disk with no free space, with LVM, physical volumes can easily be added to your volume group with no free space, all right? And from there, more logical volumes can be created. So LVM allows easy storage management compared to the manual or standard way of storage partitioning, all right? And also with LVMs, you can have the LVM snapshots, which means you can have your partitioning, your partition being snapshot, all right? You can have your volume or partition as the case may be being mirrored, all right? So LVM supports mirroring, it supports even with LVM you can export your volume group, you can import your volume group, and there are a lot of advantages using LVM. And when it comes to the disadvantages of using LVM, there's no actually a major drawback, all right? LVM is just way too, the advantages, it's just too big and outweighs the disadvantages. So the only thing is probably if you have all your LVs on one disk without the partition, and if something goes wrong with that hard disk, you practically lose all of your data. Okay, and you don't even need to have your LVs on just one disk. All right. So having note that when we begin to create the LVs, which is when we begin to use LVM, you will understand the difference between the LVM and the standard partitioning that we did in the previous chapter. All right. So if you want to learn more about this, I'm going to be dropping the link to this website in the description section below. All right. And also, if you're going to be writing the RHCSA 8 exam or the LFCS exam or the SUSE Linux exam, you can just scroll to the end of this website and click on the exam practice questions. So at the end of every chapter, we always have exam practice questions, and it's very, very good. You practice before you go and write the exam. We always update these practice questions from time to time. With we have over 100 questions that we are even yet to solve, and I can guarantee you that practicing that questions before you write the exam, you will be able to pass your exams. Okay, in the next video, we're going to look at what a physical volume is in Linux and how to create one. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this video. In this lesson, we're going to look at how to create physical volumes and how to create the volume groups. We're also going to look at how to create physical extent and what physical extent is, and we're going to look at how to create a logical volume. In the previous video, we looked at what LVM is, we looked at the advantages of using LVM. We also looked at the terminologies and the concepts around LVM, like the volume group, like the physical volume, and like the logical volume. All right, so now let's get started on how to create all of these. Physical volumes are created from block devices, and a block device could be LUNs created from the storage array, the physical hard drive, or even a partition on a disk. So one can technically say that the physical volume is a block device. Alright, so LVM uses the physical volume as part of its management technique, and reason why if a PV is created, a certain LVM information like the LVM header will be created on the PV as an identifier, confirming that such block device or devices belongs and will be managed by LVM. Alright, and the utility that is used to create PV is PV create. Now, so let's create a PV. And to create a PV, let's see what we have, the block devices that we have on the system. All right, so you can see that I have free SDB and SDC. All right, so I'm just going to create a PV on SDB. Okay, so to create the PV, use the command PV create. All right, on the device you want to create on. So we want to create it on the device SDC. Okay. And then you can see that, all right, warning ext4. Okay, I
an ext4 that is detected on this disk. It's asking me if I want to wipe it. Yes, of course I want to do that. So you can see now that the physical volume has been created successfully. Okay, to verify that the PV has been created, you can use the command pvs. All right, it will show you the PVs that you have on the system. So you can see the new PV that we just created, saying that this PV is, the size is 3 gig. All right, and if you want to get the full information of the PV that we've created, you can just use the command pv display. All right, you can, when you use pv display, it's going to display every PVs that we have here. You can see the new ones that we just created. You can see the PV name, you can see the PV size, you can see the allocatable, the PE size, and every information you want to know about that, you can get it here. All right, and if you want to grep it to whatever particular particular device, you can also use the grep command. All right, so having known how to create the physical volume, now let's see how we can create the volume group. All right, don't forget that that the PV has to be initialized for use by the LVM before volume group can be created. All right, so the whole essence is that if there is no physical volume, there is no volume group. All right, so now let's create a volume group. And you know that like I've said, that a volume group is also a management technique used by LVM. All right, so the idea is that a volume group must be created on a physical volume. Don't forget that you can also have more than one physical volumes. All right, so if you want to create more than one physical volumes, you can do this on the devices you want to create it on, say SDC or SDD. All right, and you can have more than, you can create more than one physical volumes. All right, so now to create the volume group, you use the command vg-create. Okay, and the vg-create will be, it will be followed by the name of the volume group you want to create. All right, so to create the volume group, for example, technique volume group. All right, so this is the name of the volume group. Let me put this as -vg. Okay, and followed by the PV. All right, which is the physical volume you want to create this volume group on. And so we want to create this volume group on the physical volume dev SDC. All right, this is the physical volume we want to create the volume group on, and then we press the enter key, and you can see that the volume group has successfully been created. To get the information, you can use the command vgs. All right, it will show you the volume groups you have on the system. So you can see that the volume group that we just created, which is technique volume group. And you can also use the command vg display. All right, vg display. This will display the volume groups you have on the system with the full information of the volume group. So you can see this volume group name, which is technique volume group. I can see the full information of the volume group. You can also see the volume group UUID. Okay, so there's one thing you should also know about, which is physical extent. Physical extent is a block size, that is how the physical volume is divided into chunks or blocks of data. Okay, so LVM manages extent in such a way that the physical extent would have the same size as the logical extent for the volume group. All right, so when ALV is created, the logical volume gets its extent from the volume group. All right, and the default physical extent size is 4 MB. All right, which will even work for most applications. When we created this volume group, we didn't specify this volume group. You can see this volume group we created here. We didn't specify the physical extent size. All right, so meaning that we're going to use the default size, which is 4 MB. All right, so if you want to change the physical extent size, then you would need to specify the extent size. All right, and to specify the extent size, so for example, if you want the extent size to be 16 MB, you can just use the command -s. All right, followed by 16 M. All right, so this will specify the extent size, the physical extent size. Okay, so there are a lot of things too you can a lot of options you can use while creating volume group. don't forget that I always tell you that you can use vg --help, or you can check the man page of the VG to see a lot of things you can do or how you can create your volume groups. In the exam practice questions that we have a lot of questions pertaining to storage management, and when you check those out, you see the way we were able to create the physical extent alongside with the volume groups. All right. So the next thing we need to create after creating the volume group is the logical volume. And as I have explained, that LV is the main reason why we have the physical volume and the volume group in place. All right. So the idea is to make storage management easier and flexible, as I've mentioned. All right. And logical volumes with various sizes can be created on the volume group. It can be compared to as creating a partition on the hard drive. All right. So to create the logical volume, we use the command lv create. Okay, so lv create followed by the logical volume size. Don't forget that when we created the volume group here, the volume group size that we have is 3 gig. All right, so for example, if I want to create the logical volume size of 2 gig, I'm going to use the command lv create followed by the option -l. All right, and I'm going to put the size of the logical volume I want to create, which is 2 gig, followed by the name of the volume of the logical volume. I can call this TechNeed logical volume. Okay, and then I want to create this on the TechNeed volume group, so followed by the name of the volume group, which is TechNeed volume group. All right, let me make this lowercase. Okay, so you can now see that the logical volume has been created. So this is the partition. We have the LVM partition now, which is 2 gig. If you use the command lvs, it will show you that we now have a logical volume created, which is TechNeed logical volume, created on where? On the volume group TechNeed volume group. Okay, and the size is 2 gig. If you use the command vgs, you will now see that the free size we have on this volume group is now 1020 MB, right? So meaning that we have about 1 gig remaining because we've already created a 2 gig logical volume from this volume group. All right. In the next video, we're going to, since we now understand how to create all of this, we're going to properly create a logical volume partition, and we're also going to add the parameters in the fs tab file. All right. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this lesson. In the previous video, we've looked at how we can create a physical volume, a volume group, and a logical volume. So in this lesson, we're going to see the step-by-step process of how to create a partition or a volume using LVM. All right. So let's verify the block devices that we have on the system. So I'm going to do lsplk to do that. All right. So what I want to do is to create a logical volume of 3 gigabytes. All right. So I'm going to use this disk, STB disk. All right. So this is STB, which has 5 gig. All right. So the first thing I need to do is to, of course, create a physical volume on this STB disk. All right. So I'm going to use the command pvcreate /dev/STB. All right. So I can also decide to partition STB into STB1, say 4 gig, and then create the physical volume on STB1 depending on what I want to do. All right. So but now I just want to create the physical volume straight away on STB1 without partitioning STB1. Okay. So now the physical volume has been created. The next step is to create the volume group. All right. So to create the volume group, I'm going to use the command vgcreate followed by the name of the volume group. I can say TechNeed. I know we already have a TechNeed volume group on the system, so I can just say TechNeed 2 volume group. All right. And I want to create this volume group on the device STB. All right. So you can see that the volume group has been
created as well. I can verify by doing my PVS and VGS, of course. So you can see the volume group technique 2 being created, technique volume group, technique 2 volume group, and the PV that we created. You can see that it's also been created here, which is dev SDB. Okay, so after that, the next step is to create the logical volume. Okay, and to create the logical volume, I'm going to use the command lvcreate, okay, followed by the size of the logical volume, which is, let's say I wanted to create 3 gig or 4 gig. Okay, let's create the logical volume of 4 gigabytes. Alright, so followed by the name of the logical volume. I can call this technique 2LV, okay, then followed by the name of the volume group that I want to create the logical volume on, which is technique 2 volume group. Okay, so you can see that the logical volume has been created. So if I do LVS, you would see that the logical volume is been created, which is 4 gig. Alright, so now we need to format the logical volume with any type of file system we want to format it with, just as what we did when we looked at the standard partitioning, which was the previous chapter. Alright, so you need to format the logical volume, which is the partition or the volume, as the case may be, to a file system type so that you can be able to use the volume. Alright, so I'm going to format this to ext4. Okay, right, so followed by the device, which is the volume group. So the path, the way you write this is going to be the volume group first. Alright, then followed by the name of the logical volume. Okay, so you can use this type of device mapper, alright, depending on how you want to specify the makefs.ext4. So you can now see that this has been done, alright, and the file system has been created on this device. Okay, so the next step is to, of course, create a mount point, okay, so that we can map the logical volume to the mount point. And to create the mount point, you use the command mkdir. So for example, if I want to create the mount point, let's say tech need. I don't want to use technique, so it won't be confusing. So I'm just going to create the mount point Victor, for example. Alright, and I'm going to map the logical volume to the mount point by using the command mount dev technique volume group. Alright, technique 2 volume group, then technique 2 logical volume. Alright, we're going to mount this to the mount point, which is /Victor. So you can see that this has been mounted, and to verify we can use the command df-h. You can see that this mount point is being mounted to this device. Alright, so whatever thing you want to do, you can begin to do it. Anything you do on this mount point is going to begin to write on this device. Okay, so I can just set it to Victor, and then I can begin to do whatever thing I want to do here. Alright, but you also know that if this system should go off, this mount point will be gone. Alright, it's not going to be persistent across reboot, and to make that happen, we need to put this in the fstab file. We need to populate that fstab file. So we need the UUID, the logical volume UUID, and to get that, I'm going to use the command block ID. I can just grep this to technique. Alright, technique 2 logical volume. Technic 2 logical volume. This should be Technic 2. Yes. Okay, sorry, there is no dash there. So you can see the UUID. So we did something like this too when we're creating the standard partition, so this shouldn't be a problem. All right, and now we can put this in the fstab file. Okay, so let's open the fstab file. Just going to put this here at the end of this file. Oops, I need to recopy this. Okay. Then I need to, don't forget that you need to remove this double comma. All right, and then you need to put this mount point here, which is Victor, and you need to put the file system type, which is ext4 default. I can use 1, 2. Okay, and everything seems to be fine, so let me save the file. You can do mount -e to be sure that everything is fine. So you can see that I don't have any error associated with what we've just done. This is just talking about NFS, alright? So everything is fine. Okay, so in the next video we're going to look at how to extend or reduce the volume group, the logical volume I mean, alright? So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this lesson. In this video we're going to look at how to extend and reduce LVM partition in Linux. Alright, quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LXS exam, you can just scroll down here. I'm going to be dropping the link to this website in the description section below. Alright, so just click on the exam practice questions, and we're going to be updating the website from time to time with questions. Alright, and it's best you subscribe to the YouTube channel or to our newsletter on this website so that you can always get updated. You can also click on the RHCSA 8 exam practice questions at the top of the website here. Alright, in our previous lessons we created logical volume. Alright, so let's look at the logical volumes that we created. Okay, so you can see the Technic logical volume and the Technic 2 logical volume. Alright, so for example, you can see the logical volume of the Technic 2 to be 4 gig. So if we are to extend or increase this logical volume to 7 gig, for example, how do we go about it? So the first thing you need to do is to verify the volume group to see if there is still available space left. Alright, don't forget that the logical volume would get sizes or volumes from the volume group. Alright, so let's verify the volume group, and you can see that the volume group is Technic 2 volume group, alright, which is here. We have just 1 gig, just about 1 gig remaining. Alright, and we need to extend this 4 gig to 7 gig. So that means we need about 2 gig here on this volume group so that we can take all the sizes of this volume group and we can use it to extend the logical volume. Alright, so since we don't have enough space on the volume group, we need to get a partition or a LON or a volume from anywhere where we can create our physical volume from. Alright, so if you do lsblk, for example, let me just clear my screen. Alright, you can see the devices I have here. Okay, I think I still have a free volume which is SDE, and it's 6 gig. Alright, so I can decide to partition this SDE and give it the size of 2 gig, and I can also decide to use the whole
volume, okay, and create my physical volume on the old volume depending on how I want it. So it depends on what you want to do. But in this case, what I'm going to do is to use the old SDE, all right? And if you're in a production environment, sometimes you might need to assign a LUN to your server. So now from this SDE, I'm going to create a physical volume, okay? So I'm going to use the command pv create on device SDE, okay? So the physical volume has been created. I can now extend my volume group, all right, since I have physical volume created on SDE. So to extend the volume group, I can do vg extend followed by the name of the volume group, which is technid 2 volume group, all right, on dev SDE. So you can now see that the volume group has been extended. So if you do VGS again, let's see, you can see that the volume group now has, the free size now has been increased to 6.9 gigabytes. So that's approximately 7 gigabytes, all right? So now that we have our volume group extended, we can now extend the logical volume, all right? And to extend or increase the logical volume size, we will use the command lv extend followed by the size, which is the lv size. Let's look at it again. The lv size is 4 gig. We want to make it 7 gig, all right? So we need about 3 gig to add to the 4 gig. So we're going to do lv extend, all right, followed by the size, which is plus 3 gig, followed by the logical volume, all right, then followed by the device where we created the where we extended the volume group from, which is SDE, all right? So there are different ways you can write this command. To know more about it, you can always do lv extend -- help, or you look at the man page of lv extend to see the different ways you can go about this. So you can now see that the logical volume has been increased from 4 gig to 7 gig, all right, and we have 1792 extent, and it's successfully resized. So let's do LVS again. You can now see that the logical volume has been increased to 7 gig, all right? Now that it's been increased to 7 gig, let's verify the file system. You can see that on the file system we still have about 3.9 gig. So what you need to do is to resize the file system, all right? So if your file system is ext4, ext3, or ext2, you use the command resize to fs, all right, followed by the device, that is the logical volume, all right, and this is going to resize the file system. If your file system is xfs, you use the xfs_grow fs command. So I have that on this website, so I'm going to be dropping the link to the website in the description section below so that you can look at how it's being done, all right, if you're using the xfs file system. And there are a lot of things you can also learn on the website as well. Okay, so you can now see that the file system is now 1835008 blocks long, all right? So if you do df-h again, let me just clear the screen. All right, so you can see that the file system has been increased to 6.9 gig, all right? So it's taking 1 gig out of 0.1 out of it, all right? So you can see that the file system has been increased. So this is how you increase or extend the logical volume on a Linux system. Thank you for watching, and in the next video we're going to look at how to reduce or shrink a logical volume. So thank you for watching once again. Bye for now. I didn't mention that you should please subscribe to this channel. Please do subscribe to this channel. Bye bye. Hi everyone, Welcome to the next section of this lesson. In this video, we're going to look at how to reduce or shrink a logical volume partition. Alright, so let's look at the logical volumes that we have here. Alright, so we have 7 gig logical volume for the Technic 2 logical volume. Alright, so we're going to reduce this to 2 gig. Alright, and you should also know that before you reduce the logical volume, you should always ensure that the size of the data on that logical volume is not up to the size that you want to remove from the logical volume. Alright, so this is what I mean. For example, if I do my df-h, alright, and if my used size is, for example, 2 gig, and I want to reduce this logical volume, alright, to 1 gig, I'm of course going to lose data, so that is not advisable. Alright, so and most times it is not even advisable to always reduce the logical volume, but in the advent that you don't have any other choice than to do that, make sure that you check the used size before you reduce the logical volume. Alright, so then we're going to reduce this logical volume to 2 gig. And to do that, well, we need to first of all unmount the LV partition of our system. Okay, so we're going to unmount /Victor, which is also attached to this logical volume. Okay, so to do that, we're going to do umount /Victor. Umount. Alright, so that is done. Let's verify. So that's it's not mounted anymore. So the next thing we need to do is to do a file system check using the FSCK to be sure the drive is healthy and will survive a shrink. And to do that, we use the command e2fsck, alright, followed by the device, which is the logical volume. Alright, so we can see that it is clean. Okay, let's use the -F option, the first option as well. Alright, so pass 1, pass 2, pass 3, pass 4, pass 5. Alright, this is fine. Alright, so it is not a best practice to continue with the file system reduction if 1 out of the 5 file system checks fails. Alright, so but this is okay. Now we can reduce the size. Okay, so to reduce the size, I'm going to use the command resize. We need to reduce the file system first. Alright, we need to reduce the file system to the desired size we want to reduce the logical volume to. Okay, so I'm going to use this command to reduce the file system. Alright, so I'm going to reduce it to 2 gig. Okay, so now that I've done that, I'm now going to reduce the logical volume size to the desired size I want to reduce it to, which is, I'm going to use the lv reduce command to do that. I want to reduce this to 2 gig, followed by the device. Okay. Yes. Alright, so you can now see that the logical volume has been resized. I can verify. Alright, by doing, of course, if I do LVS, you can see that it is now 2 gig. And if I do, of course, LSBLK, where is the second one? Alright, so you can see that it is now 2 gig. Alright, so if I do df-h as well too, oh, it's now we are mounted this, so we need to mount it back. Alright, so to mount it back, we use the command, of course, mount /dev technic 2, alright, on /Victor. Alright, so if I do df-h, now you can see that it is now 2 gig. Okay, so this is how you're going to reduce or shrink a logical volume in Linux. And quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LF6 exam, you can come to this website and scroll down to the end of the chapter. At the end of every chapter, there's always an exam practice question, all right? Or you go to the top of the website and you click on the exam practice questions of the exam that you want to write. We always update this website from time to time with updated questions, so it is better you subscribe to the YouTube channel or you subscribe to our newsletter on the website so that you can always get updated. All right, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this lesson. In this video, we're going to look at how to create swap partition on Linux. All right, so if the RAM on the system is overused or exhausted, the system or other application switches to the swap partition, all right, and the swap partition then acts as the RAM. So if your memory is full, right, what happens is that other applications will switch to the swap partition and use it as the memory. And to see the swap size on your system, you can use the command lsblk to do that. So you can see that the swap size on this system is 1.5 gig. So I did automatic installation on this system, so I wasn't the one that gave the system swap partition of 1.5 gig. But if you need to increase the swap size, you need to use a LUN or a volume to do that, or you rather create a new swap partition on the system so that you will have enough swap partition on the system. I remember that one time like that, when I was working on the project, it was supposed to be Oracle that's going to be installed on the system. So I remember that the specification then for Oracle was 16 gigabyte swap file, all right. But I mean, if you have a swap file or a swap partition of 4 gig, I think that should be enough, except for some specific applications like Oracle that require a lot of swap space or swap file. All right, so let's create a swap partition on this system. So the first thing you need to do, of course, is to I did mention that you can also use the command -h to look at the swap size on your system. All right, so to create a swap partition, we're going to create it from this SDB device. All right, so the SDB device is 3 gig, so we're going to create a swap partition of let's say 2 gig. All right, 2 gig is okay just for this purpose. So what I'm going to do first is I'm going to create a volume group and create a logical volume. So it's going to be LVM swap. So I'm just going to create a volume group on this. I'm going to call this VG swap. All right, on dev SDB. So the volume group has been created, and I'm going to create a logical volume. All right, so I can just say LV create. I'm going to call the logical volume size, let's create 2 gig, right? And the name of the logical volume, I can say LV swap, all right? Then followed by the volume group name, all right? So volume group name is VG swap, okay? So the logical volume LV swap is created. You will notice that I didn't create PV when I was creating the volume group, alright? And in other videos, I've always created PV. Well, if you create a VG, alright, PV, you can see that PV2 would be automatically created. You know, this is Red Hat 8, so even in Red Hat 7, the system just knows how to create PV if you're going to be creating a VG straight away. All right, so now that we have the LV swap logical volume created, let's format the LV as swap. So we're going to use the make swap command to do that, followed by the name of the LV. All right, so the LV is going to be the volume group VG swap, then LV swap. Alright, so this is done. So let's create a mount point. I need to copy this UUID, alright, because I'm going to put this in the FS tab file. I want to clear the screen right now. So I can just create a mount point for swap. I can just say I can say swap or whatever name I wish to call this. Okay. Now I can edit the FS tab file. So I can use the UUID to do this. Alright. I can, this is on swap. Alright. So this is also going to be swap. This is going to be default. I can use 00. Okay. Just going to save this file. So the next thing to do is to activate swap, alright, on the logical volume, which I'm going to use the command swap on, followed by, I can use the -v option, alright. Swap, let's use dev swap. Okay, I think I for okay, LVG swap, alright. Swap on. BG swap, then on LV swap. Okay. Alright, so let's do a mount -a first, and let's run the command. Oops. Okay, this is LV swap. Okay, alright. So we can also verify if the swap volume was successfully created and activated. Alright, we can also do cat proc swaps. Right, so you can see the new swap that we've just created, and if you also do free -h, you would have seen that the swap file or the memory has been increased. Alright, so thank you for watching. Please subscribe to this channel, and bye for now.
Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today I'll talk about SA Linux and how to configure, how to manage and troubleshoot SA Linux with examples. Alright, so SA Linux means Security Enhanced Linux. It is an advanced security feature or utility in Linux. When you talk about SA Linux, you cannot actually replace SA Linux with antivirus or firewall or permissions or ACLs on Linux. As the name implies, it is a security enhanced feature and not a replacement of other security features on Linux. I have done some projects and I have seen in some environments that SA Linux is being disabled because of all the troubles of it. Well, I'll tell you that it's very essential to always enable SA Linux, especially if your system is going to be internet facing. If your system is not going to be internet facing, then you go away with SA Linux. But if people from the outside are going to be connecting to your system, you should enable SA Linux. For example, if you have a web server, Apache or Nginx or other web servers running on your system, of course, the web services would use a port, and people from outside would always connect to the services on your web server. And if a hacker is able, by any means, hack into the system via the open port, what SA Linux would do is to block all the malicious activities of the hacker, because SA Linux labels every file systems on the system. And if the file system of another directory or location, if the labeling is different from the labeling of the services in which the hacker came in with, then the hacker would be restricted and wouldn't be able to perform his or spread his malicious activities on the system. And that's why it's very important to enable SLinux. Okay, so how does SLinux work? When a syscall is initiated, so a syscall is a system call, so it could mean that a service is trying to perform some particular activities on the system, right? So when a syscall is initiated, depending on the mode of SLinux at that time, so SLinux can either be in enforcing or permissive mode. But in this situation, we're looking at the enforcing mode. So if the SLinux is in enforcing mode, SLinux verifies its policy associated with the syscall. If the syscall meets the SLinux policy, what happens? The syscall passes through, right? So syscall is allowed because it has met the SLinux policy. The source will check the target, right? So if the syscall doesn't meet the policy, the syscall bounces back and it's terminated. All right. SLinux, when enabled, logs its event via audit.d in the location vatlog audit.log. Okay, so on the other hand, if SLinux is set to be in permissive mode, and if a syscall is initiated, syscall is allowed. In permissive mode, whether syscall meets the SLinux policy or it doesn't meet the SLinux policy associated with it, all syscalls are allowed in this mode. And if SLinux is disabled, then the feature is disabled. Nothing happens. In the next lesson, we're going to look at the SLinux modes and SLinux examples. We're going to look at how to enable and disable SLinux. Thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of technique.com. Today we're going to continue with our studies with SLinux. In our previous class, we've looked at what SLinux is, we've looked at the reason why we need to enable SLinux. We've also looked at how SLinux works. In today's lesson, we're going to look at the SLinux modes and status and how to know if it's enabled or not. All right. There are three modes of SLinux. They are the permissive mode, the enforcing mode, and the disabled mode. So SLinux can be enabled or disabled. And if SLinux is enabled, it can either be in permissive mode or enforcing mode. If SLinux is disabled, then it's disabled. So how do you know if SLinux is enabled or not? So one of the ways to know that is to check the SLinux configuration file, which is etc sysconfig SLinux. So to do that, we can use the cat command. All right. So in this file, you check this line. We can see that SLinux is in enforcing mode, right? And you can also see the three modes of SLinux. Another way to verify SLinux status is by using the command sc-status, right? So if you use this command, you can check SLinux information here. You can see that, SLinux is enabled here. And you can also see that this is the current mode of SLinux, and you can see that it is in enforcing mode. Well, there's another command you can use. You can use the get enforce command, right? You can see that SLinux is in enforcing mode. So let's talk about SLinux disabled mode. If SLinux is in disabled mode, it means that all the syscalls will be allowed when initiated because the feature is disabled. We talked about that in our previous lesson. The SLinux binaries and policies are disabled, so nothing filters the system calls. And if SLinux is configured to be disabled from an enabled mode, the system must be restarted so that all SLinux libraries that usually loads with the kernel when it is booted up won't load. Also, if SLinux is configured to be enabled from a disabled mode, the system must be restarted so that the kernel
can load all the SE Linux libraries from boot. To disable SE Linux, just go into the configuration file, right? And then you check you change this enforcing to disabled, right? Then you save and you make sure that you restart your system. I'm not going to restart my own system, but if you want the changes to take effect, as we just said, you would need to restart your system. All right, so let's talk about the SE Linux permissive mode. If SE Linux is set to permissive mode, whether the syscall meets or doesn't meet the SE Linux policy, the syscalls will be allowed to pass through when it is initiated. More so, SE Linux, when enabled, permissive or enforcing, logs its events in this directory, which is var log audit and audit audit.log, right? So this is where SE Linux logs its events. We will understand how to check this log, this log file as we go on and as we do some examples. Now let's talk about the SE Linux enforcing mode. If SE Linux is in enforcing mode, it means only the system calls that meet the SE Linux policy will be allowed. The syscall that doesn't meet the policies will be denied. SE Linux can be switched from enforcing to permissive mode and vice versa without the need to restart your system, right? So if I want to switch, I can use the command set enforce, for example, permissive, permissive, right? So I've been able to switch from enforcing mode to permissive mode without the need to restart the system. For me to verify, I can just use the command get enforce, right? You can see that SE Linux is in permissive mode. If I want to switch back to the enforcing mode, I will just do set enforce enforcing, right? And then I can do get enforce. You can see that I'm back to the enforcing mode. Don't forget, I can also use the command sc status to check for the status of SE Linux. You can also set SE Linux to permissive or enforcing mode from the configuration file as well, right? SE Linux. So from the configuration file, you can change this to either permissive or enforcing, right? So this is another way you can change the SE Linux status. All right. So in the next lesson, we're going to look at SE Linux policy. We'll be talking about SE Linux policy, and we're going to know what this policy is actually. And hopefully, we should get our hands dirty. We should start doing the examples in the next lesson. All right. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we'll continue our studies with SE Linux. In our previous lessons, we've looked at what SE Linux is and and why you should enable SE Linux. We've also looked at the modes of SE Linux and how to switch to either permissive mode, enforcing mode, or totally disable SE Linux. So in today's lesson, we're going to look at SE Linux policy. So when we talk about SE Linux policy, it is a set of rules that defines what kind of services or programs can access what kind of objects. And when I say objects, I mean files, directories, services, or ports.
These rules are written by the application or program developer, and the developer will specify these rules in his program code. So you should not worry yourself about these policies. The only time you should worry yourself about it is if you want to change the policy. The developer already knows the objects, file directories his applications will access to function properly. And if you don't want that, probably you want to change the configuration, then that's when you should begin to worry yourself about the policies and say, okay, um, I want to change this configuration. And changing the configuration or policies requires understanding what SE-Linux context and booleans are. So let's start with SE-Linux context. SE-Linux context is simply labels that are associated with objects, that is, labels that are associated with files, directories, ports, processes, etc. Now, everything on Linux has context. And to see the context of an object, be it file, directory, port, you use the option Z with their simple listing command. So for example, to look at the context of the files here, in this directory, we use ls-option Z, right? Okay, let me make a long listing, right? So this are the context of the files in this directory. So you can see this line. These are the context. And context is divided into four parts. We have the user part, which ends with underscore u. We have the role part, which ends with underscore r. We have the type part, which ends with underscore t, and we have the sensitivity part. To see the context of the /tmp directory, right? You use the same command on tmp. So on /tmp, we can see the context of this directory. Let me make my screen bigger. Okay, so we can see the context of this directory. Okay, so we can see the user part, we can see the role part, this is the type part, and this is the sensitivity part. These contexts are used to make access control decisions. So to look at the context of processes, use the command psaux with the Z option, and then you can see the context of all processes. If you want to um, look for a particular process, for example, all right, say you want to look for the Apache process, right? You can use the grep command for that. And you can see the context associated with Apache. You can see the user context, the user part here. You can see the role part, and this is the type part, and this is the sensitivity part. So this is how you see the context associated with a process. If you want to see the context associated with the port, use the normal listing command for port. Then the Z option. Then you can use this to open, and it lists all the context associated with port. Right? So you can see the context, you can see the user part, the role part, the type part, and the sensitivity part. So this is the security context that is associated with this port. Now, what's the name of the port? 111. Okay, so that's how you see the context associated with objects. So in this tutorial, we're going to be looking at, we're going to start from the type context.
the type context that is the context that is mostly modified when it comes to SE Linux troubleshooting. So let's understand the type context with some examples. But before we do that, let's take this keynote. It's essential we take this keynote. And number one is there is an SE Linux security context and attributes for every location or path on the system. We've already established that here when we run the command this as against tmp to look for the context of the directory. Then we can do this, right? And then we can set the context of the tmp directory, and the type context is tmp underscore t. The second keynote you should know is when you create a file or directory, the appropriate SE Linux security context and attributes for the location the file or directory was created will be associated with it. So, for example, if I go to /tmp, right, and when I list the context, sorry, in this location, right, you can see the context, the user tmp t user tmp t and all of that. So if I decide to create a file in this location, for example, or a directory, let me just create an empty file and I say touch technique 5, right? And I decide to list the context again. You can see that technique 5 has taken the context, has automatically taken the context in this location. The top keynote is that SE Linux just knows how to label the files or directories, so you do not have to bother yourself about it, except in the advent where you need to do some special configuration like troubleshoot SE Linux or change labels or context. The fourth keynote is when you copy a file or a directory to a location, the file automatically inherits the SE Linux security context and attributes of the location it was copied to. So you can see the context, the type context of Technet 5 to be user underscore tmp underscore t. So if I copy Technet 5, for example, to /boot, right? Oh, sorry, Technet 5, right, to /boot, and I go to /boot, and I list the content here, /boot. So you can see that Technet 5 has automatically taken the context in this location. The fifth keynote is when you move a file or a directory to a location, the file or directory does not inherit the SE Linux security context and attributes of the new location. Instead, it moves with its old location's context. Now, this is Technet 5, right? If I decide to move Technet 5 to /tmp, okay, so let me move Technet 5 to /tmp. Yeah, okay. Oh, okay, so you can see that when I moved the file, the Technet 5 file also came with the context of the location it was coming from. So it would not inherit the context of the location where it's been moved to, right? So this is a very important keynote you should take note of. And the sixth keynote is that any unconfined context is not limited by SE Linux. All right, so in the next lesson, we'll look at understanding SE Linux type context with examples. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com.
Today, we'll continue with our studies on SE Linux. In our previous lessons, we've looked at a lot about SE Linux. We've looked at what SE Linux is. We've looked at how it works. We've looked at how to switch from SE Linux modes. We've looked at SE Linux policies and context. So in today's lesson, we're going to understand SE Linux type context with examples. In this example, I'm going to assume that you already know about Apache Web Server and its very simple and basic configuration. So I'm going to be dropping the link to how to configure Apache Web Server in the description section below. I'm also going to drop the link to this website in the description section below. So let's create a very simple test website, right? So I'm going to do that in the document root for Apache. So let me create a file called web test or web1.html. Okay, so web1. All right. Okay, so I can open this website. I can either use the Firefox web browser or any web browser, or I can use elinks. So if you don't have elinks, you can install elinks by doing yum install elinks. I'm using a Red Hat distribution. You can use your own package manager distribution to install elinks. So I'm going to be testing this website with elinks. All right, so you can see that I can access the website, and this is the content to the website, web1 test file for SE Linux. Okay, so now let's create another file, another website file in my root directory. Okay, so let me call this website one. And let me just say it's just a test file for SE Linux, right? Okay, so now I have to move this file to the Apache's document root. So let me move it. Right. So let me test my website with elinks. Oops. So you can see permission denied. Forbidden. You do not have permission to access website one. So what is the issue? We can access. We have to. Sorry. Let me just go to this location. All right. So we have web1.html and website one, and we can access website web1.html, right? Yeah, we can access this, but we cannot access the website one. Okay. So how do we troubleshoot this? So this is going to lead us to the next section of this module. We're going to look at how to troubleshoot SE Linux, and we're going to look at the tools we can use in troubleshooting SE Linux. All right. So thank you for watching. please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of technique.com. Today, we're going to continue with our lectures on SE Linux. In our previous lessons, we've talked about what SE Linux is. We've looked at why you should enable SE Linux. We've looked at how it works. We've looked at how you can enable and disable SE Linux, both in permissive and enforcing mode. We've looked at what SE Linux policy is and what SE Linux context is, even with examples. Yeah, in today's lesson, we're going to look at how we can troubleshoot SE Linux problems with examples. Okay, so we're going to troubleshoot the problem we had in the previous lesson. And the first step in troubleshooting SE Linux problem is to be sure that it's actually an SE Linux issue. So to be sure about that, you need to set the SE Linux to be in permissive mode. I already talked about that in previous lesson. So let's do that with the command set enforce permissive. Okay, so let's do get enforce and be sure that it's already in permissive mode. Okay, we can see that SE Linux is already in permissive mode. So let's run the command again and see if you can access website 1. All right, so we can access website 1. So this means that we're actually having an SE Linux problem. So let's take SE Linux back to the enforcing mode. Enforcing. All right, let's do get enforce. So we're already back in enforcing mode. Most times, problems with SE Linux is as a result of file systems being mislabeled with the wrong context, and also booleans. If booleans are not enabled, then you're going to have issues with SE Linux. We're going to look at what booleans are in the next class. So now let's check the context in this directory. Let's even see if the context is correct. All right, we can see that we can access the web1.html, and the type context of this file is sys underscore content underscore t. Even there's another website file that has the same context as this, but for website 1, we have a different context. And naturally, if you put on your troubleshooting thoughts, you would know that this file was actually moved from the home directory with the labeling. It's obvious. Just like every program developers, Apache developers have specifics and directives in the Apache SE Linux policy. So if a type context of an object is different from the policy, syscall will be terminated, and that's why the syscall has been terminated. So if a hacker breaks in via the Apache service, you can see that the context of every directories are different. Say he breaks in via the Apache service, he won't be able to do anything in other directories, because if you go to other directories, most of the context they are actually different. You understand? So for example, if I go to TMP directory and I do ls-lz, you can see that we have so many different contexts different from the sys content T. So the hacker wouldn't be able to spread his malicious activities around the system, because every sys call will always get terminated. All right. So to solve this problem, there are different tools that can be used to solve these problems. We have the restocon tool, we have the semanage tool, we have the chcon tools, and the rest. Okay, and the problem is just that we need to make sure that this let me show you HTML. All right. Okay, so the solution is that we just need to make sure that the website 1 file has the same context as this same type context as httpd underscore sys underscore content underscore t, and that's the solution. So how can we solve that? Well, let's first of all start with the restocon utility, and then we'll look at how we can use other utilities to solve the problem. So to solve this issue, I'm going to use restocon, right? Restocon -r,
-v, right? That's verbose. Then I can do /var. So that means it's going to relabel all the file context in /var directory recursively. So I can specify /var if I wanted to relabel the context in that directory, or I can just specify the document root by saying www, then html, right? And I press my enter key. Oops. Oh, sorry about that. It's var html /var. That's the path html. Okay, so you can see the message here relabeled this from this to this. So let's confirm again. So we can see that the file has been relabeled to the right context. And let's see if you can access the website now. All right. Okay, so you see that we can access the website one file. So this is one of the ways you can troubleshoot SC Linux. All right. The restore con utility checks the file systems to see if the context in their location are appropriate as described in the SC Linux policy. If not, it will do the correction by overwriting the appropriate context in the file system. And that is what has been done. All right. So in the next class, we're going to look at how to use other utilities to solve SC Linux problem. All right. So thank you for watching. Please subscribe to this channel. Bye for now. Hi everyone. My name is Victor, and I am one of the authors of Technique.com. Today, we're going to continue our lectures on SC Linux. In our previous lessons, we've looked at what SC Linux is and why you should enable SC Linux. We've looked at a lot of things about SC Linux, the enforcing mode, the disabled mode, how you can troubleshoot SC Linux policy and context. We've done quite a lot of activities. But into this lesson, we're going to look at how to use the SC Linux SC manage utility to troubleshoot SC Linux. Okay, so in this example, we're still going to use Apache server. All right, so I'm going to be dropping the link to how you can configure Apache, and it's simple, basic configuration. I'm going to drop the link in the description section below, as well as the link to this website. So if you don't know how to configure Apache, you can just go through it. All right, so one of the ways to add in Apache server is to change the document root. So for example, let's change the document root for Apache. So let's make a directory for that document root. New document root. All right. So let's create a website file in the new document root. And call this website 2. Yeah, I think the first one we did was website 1. Okay. So I can just put in anything I want to put in here. I can say this is test website for the new document root. Okay. I'm going to save and quit. I'm going to edit the Apache configuration file now. To do that, it's best you back it up first. Okay, so let's back it up. Let me just copy this. Okay, I can make this original. Okay, so let's now edit the Apache configuration file. All right, no, this is what I want to do. Okay, so I'm going to look for the line document root. Let me just search by doing this document root.
Okay, so I'm going to change this to the new document root. Right? And I'm also going to look for the line. Which other line? Okay, this directory line. We need to change this as well. Okay. I think that's all. No, okay, there's still one more line that we need to change, which is this. Yeah, I got you. This one. Web server / new document root. All right, I'm going to save the file. So we need to restart Apache now. All right, so let's check the status of the server. Okay, so it's running. Let's try and access the website. Okay, you can see that you don't have permission to access website 2. Again, let's put on our troubleshooting thoughts, just as we did in the previous lesson. I said anytime you want to troubleshoot SE Linux, you should always look at the type context first, followed by the Boolean, right? To save time for this problem, we already know that it's not a Boolean issue. We already know that it's the Apache's default document root that we changed, all right? And I talked about where SE Linux usually logs its file, and I mentioned the directory. So let's check that directory. The location is var log audit.log. And I'm going to grep for AVC. I said that it logs its termination calls as AVC deniers. I already mentioned that in the previous lesson. Okay, so let me just broaden my screen so we can see this very well. Let me run the command again. All right, if you look at the last line of this file, you can see AVC denied get attribute for process ID. This is the command, the Apache process, right? Trying to for website 2, the source context is for the type is HTTP D underscore T, and the target context is default underscore T. So this is the path. Let's see how we can use the sc manage utility. So let me do sc manage -help. You can see a lot of sc manage argument here. You can see the positional argument. If you look at this f context, it says manage file context mapping definitions. So how can I use this command? Let me do sc manage and see. Let me just broaden my screen again. Okay, we're looking for f context. This is f context, and this is its description. If you check this line, you can see sc manage f context. So let's look for this man file as well. Man sc manage f context. All right. So what does this command do? let's scroll down and see where we can see examples. All right, we can see this example. Remember to run restore con after you set the file context. Okay, add file context for everything under web. So I can just copy and paste the command here. Okay, but I'll need to change some stuff. For example, this /web should be my new document root. When you read the manual page, you should change this to your new document root. So this is web server, the new document root that we created. All right, so let's run this command. And in that manual page, the manual page says we shouldn't forget to run the restore con utility as well, right? That's what the manual page says. So let's run the restore con utility. I'm sorry, -r -v /web server, the new document root. Okay. So you can see that it's been relabeled. All right. So let's try and access the web server now. Let's see if you can do that. Okay. So we can access the website now. You should note that the SC manage fcontext utility writes to the policy and not directly to the file system. So when we use that command, we wrote to the policy. The reason why we used the restore con command, which is the second command, was to write from the policy to the file system. You know, I've once said that the restore command, I think that was the previous lesson, that what it does is to make sure that all the labelings are correct. It checks the policy and it makes sure that all the labelings are correct. So let's do a cleanup of our environment. I'm just going to store my backup and just do this conf original. Oops. httpd conf, sorry. Then httpd.conf. Yes. So let me restart the Apache server. All right, so let's check if it's running. So this is how you can use the SC manage utility to troubleshoot SC Linux. In the next class, we're going to look at how to use the SC alert to troubleshoot SC Linux. All right, so thank you for watching and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, we're going to continue the lesson on SE Linux. In our previous lessons, we've looked at a lot about SE Linux. We've looked at what SE Linux is, how to troubleshoot SE Linux, how we can enable and disable SE Linux. We've looked at what SE Linux policy and what SE Linux context are. We've looked at how to use the restore con utility to troubleshoot SE Linux. We've also looked at how to use the SE manage utility to troubleshoot SE Linux. So in today's lesson, we're going to look at how to use the SE troubleshoot server to troubleshoot SE Linux. No doubt that troubleshooting SE Linux sometimes can be very tasking, but if you know the right tools to use, at least it makes the stress reduced a little bit. The SC troubleshoot server by default is always installed in the RHEL 7.8, CentOS 7.8, and some other Linux distributions by default. To see the version of the SC troubleshoot server that you're running, you can just do rpm-q SC troubleshoot. server. Okay. If SE Linux troubleshoot server is not installed in your distribution, just install it. All right, in our home directory, let's create another website file. Let's call this website file website 3 this time around. All right, and let me put something here. Let me just say SE alert test website. Okay, let me move this file to the Apache document root, right? Okay, so I can access this website with the e-links tool. You can also use Firefox or any other browser in your environment. I just want to use e-links. So you can see that I don't have permission to access website 3. Of course, from our previous lessons, you already know that it's because of the context. I moved to the file and then the context has changed. The SE troubleshoot logs SE Linux issues in the var log messages, right? So we can check that there. So let me do cat var log messages. Okay, I need to look for SE alert messages. That's what SE troubleshoot logs SE Linux issues with, right? So I can just do less and I can look for SE alert. All right. What date? Let me just broaden my screen so we can see what we're looking for. All right. So if you look at this SE alert message, today is 30th of May. All right. So you can see here says that SE Linux is preventing user USR has been this one from getting attribute access to this file website 3. Okay, so that's the error, and it's saying that if you want to fix the label, can you see this? Default label should be httpd syscontent underscore t. All right, which is true. You can also see the confidence score 99.5 suggests. So that means it's actually the system, the SE troubleshoot server actually it's actually confident because of the score. Sometimes you might see a lower confidence score rather. All right, so we already have the solution here, and SE alert is also saying something here. Can you see? It says run. You see, for complete SE Linux message here, it's saying run SE alert -l with this ID number. So if you run that command, you can also get a lot of information about the SE Linux issue. Okay, you can even see what it's saying here. Failed to retrieve RPM info for this. So we just have our solution. The SC troubleshoot server is giving us what the solution is, but nevertheless, let's just still run this command. All right. And what I love about SC alert is it also gives you a confidence score, you know, and it's saying that after running that command here, I love this part. Then you can run restore con. We were able to do that in the previous lesson. Okay. All right, let me just clear my screen and shrink my screen as well and run the SC alert command. Oops, this is not what I'm looking for. This is what I'm looking for. This is what I am looking for. This is what I want to copy. Okay.
So you can see the information with this command. We have a lot of information. All right. So you see, SE Linux is preventing this blah 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 blah. Website 3. Look at the confidence score. Then look at you're saying if you want to fix this label var www blah 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 should be httpd sys content -t. So we have everything we should use to solve this problem here. And it's saying then you can run the restore con command, right? These are additional information if you want to check. Okay, so let's since we already have the solution to the problem, we can just run the restore con command to fix this problem. Okay. All right, so it's been relabeled. We can try to check the website again. So you can see that we can access the website. So this is how you can use the SC troubleshoot server with SC Alert to troubleshoot SC Linux issues. All right. So in the next lesson, we're going to look at what Boolean is and how we can work on Boolean. All right. So thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of technique.com. Today, we're going to continue our lesson on SE Linux. In the previous lessons, we've learned a lot about SE Linux. We've learned on why we should enable SE Linux and how it works. We've learned about the enabled and disabled mode of SE Linux, permissive and enforcing mode, which is the enabled mode. We've learned about SE Linux policy and SE Linux context. We've learned about how to troubleshoot SE Linux with the RHCSA utility and the SE manage utility. All right. So in today's lesson, we're going to learn about SE Linux Boolean. Booleans are SE Linux functionalities of a policy that can be turned on or turned off. If the boolean for a particular syscall function is disabled or turned off, then the syscall will be terminated. To get the booleans on a Linux system, use the command get -a. This shows all the booleans on a Linux system. You can see that there are lots of them. So to get the boolean of a particular service, for example, the Apache service, you can use the grep command to do that. So we can grep for httpd, right? So you can see all the booleans that are associated with httpd. Look at the last line here, the httpd underscore verify underscore DNS off. So it means that this boolean is off. That simply means that HTTPD would not be able to verify DNS. If you want Apache to be able to verify DNS, you need to turn on this boolean. So don't forget, I said boolean. If the boolean of a particular syscall function is disabled, then the syscall will be terminated. If you want a syscall, for example, if you want HTTPD to be able to use NFS, you need to turn on the boolean. Otherwise, that function will not work. That is why it is very important to always check booleans when troubleshooting SE Linux. Like I said, check the context, check the booleans, right? And if a boolean for a particular function is turned off, you need to turn it on. To turn on the boolean on a Linux system, you use the command set sbool, right? Followed by the boolean you want to turn on, for example, verify DNS, right? Then I'm going to do on, right? So I've been able to turn on this boolean. To verify, you can use the get sbool command, right? With the boolean name, so you can grep for the particular boolean, which is this, right? So you can see that the boolean is turned on. You should note that turning on a boolean with this option will not make your changes persistent. To make the changes persistent, you need to use the -p capital P command, right? Set sbool Then here you put dash p in uppercase, then you do on. You see that it's taking time this time around. Unlike the first one that we did, it was just fast. So you can see that the changes has been made persistent. Okay, to turn off a boolean as well, you need to use the same option here and do off. Okay, so you see that it's taking time also. Okay, we're still waiting for it. Right, so the boolean has been turned off. Okay, and to verify, you can use the same command to verify. You can see that the boolean is turned off. Another important thing you should know is the audit D service. Yes, so this is the what SE Linux uses to log its event, right? So this service needs to be running audit D before SE Linux can log its event to the location var log audit.log. Audit.log. If this service is not running, then Linux will not be able to log its event to that location. We've talked about this in one of the previous lessons. Okay, so this is how you can enable and or disable Boolean in Linux. Thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today, I'll be talking about log management in the Linux operating system. So, logs are very important and it's what the administrator or user would always check from time to time to be able to troubleshoot the problems on the system. And also to be able to track down events on the system, you would need to always view the logs on the system as well. So management of logs should be a very important thing, and it should be done intelligently as an administrator. So how does logging work in the Linux operating system? So there are two services that handles logging on the Linux operating system. Uh, Prior to this time, for the classic systems, it was RHCSA that was handling the logging activities on a Linux system. But for modern Linux systems, the likes of Red Hat 7, Red Hat 8, Saint OS 7 and 8, the introduction of Journal D service is also around to manage logs on the system. So there are two services that manages logs on the system. One is the Journal D service, and the other, which is this, is the RSys log service. So let's look at how Journal D service, how it works on the Linux operating system. So when the system is powered on, the first service that comes up is the systemd service, which becomes the process ID 1. So the systemd service is responsible for starting every other services on the system. So other services becomes the children services to systemd, while systemd becomes the parent service to other services. And systemd with the systemctl tool can be used to restart a service even after a service has been started. It can be used to stop a service. This tool can be used to do some perform some activities on services on the system. While all this is going on, while D is doing all of this, systemd is keeping tracks of all these events, and then it's making sure that everything is being launched to journal D as a binary file. So whatever activity that is happening on system D, it logs all these activities to journal D as a binary file. So if you want to check the logs, the journal D binary file, if you want to check the logs, you can use the journal CTL tool to check the logs on journal D. And you can also use the system CTL tool to check the logs on journal D. So both tools can be used to check the logs on journal D. As a user, if I need to check the logs on journal D, I can either use the journal CTL tool or the system CTL tool. You would notice that when you use the system CTL tool on services, for example, to check the status of a service, you'll get to see some logs underneath. Yeah, let's check. Let's do that. So I'm going to check the status of the SSHD. Let's do that. So you can see the logs underneath here. So you see that the logs are gotten from these logs are gotten from journal D's binary file. This logs right here. So we can also, let me quickly do something to, let me show you something. Okay, let me do this so I can get an error. Okay. Let me restart the service. All right. So you can see that I have error. So which means I need to check my logs. And the system is telling me that I should see system CTL status sshd.service to check my logs and journal CTL-XE. So like I said, we can use the journal CTL tool or the system CTL tool to check the logs in journal D. So if I do the system CTL status, so these logs here are gotten from journal D. If I also use the journal CTL, these logs are also gotten from journal D. In the next class, in the next video, I'm going to show you the different ways you can use journal D to get logs on the system. So now that we understand how journal D works, let's look at how RSys log service operates as well. So just as the journal D service operates, the RSys log utility also gather log files from different services, sorts them, and put them in different paths under the /var/log directory. If you notice on rel 7 and 8, the system D handles the startup logs from the boot process and then it forwards the logs to RSyslog for further processing. And then RSyslog then sorts the logs out into different directories under var/log. under slash var slash log, I mean. So that's why you can see when you look at the slash var slash log directory, you see a lot of files on under that directory as well. You sort them out according to their types. You see the var log messages file. You see the var log secure file. You see the var log mail log file. You see the var log boot.log, and different files under this directory. So let's look at the directory as well and see what we have underneath. So I'm just going to clear my screen and then check the varlog directory. So you can see the different log files here. You can see the boot.log, you can see the messages. Yeah, this extension you see here is as a result of log rotate configuration file settings. I'll also talk about log rotation in another video, but not to go out of scope here. So let's continue with what we have under this directory. So the messages log, this file contains all syslog messages. That is all logs that are related to the entire system. So this file will capture all the system activities. I mean this one, messages file. It capture all the system activities. And then in some distributions like Debian, you see them instead of var log messages, you see them in var log syslog. And we also have the secure file. The secure file is also an important log file. So this file contains all logs that are related to security and authentication, both the successful ones and the unsuccessful logins. In distributions like Debian as well, you see them as vatlog auth.log. And we also have the mail log file. The mail log file contains everything that is related to mail logs and everything that's related to mail, sorry, and everything that is related to mail services too. And another important file we have here is the boot.log. The boot.log contains files, logs that are related to booting the system. We also have the cron file. The cron file contains all logs related to cron jobs as well, inclusive of errors or failed cron jobs. And we have the WTMP file. So this file contains all related login and logout logs. So this are the important files under backlog. So the RCS log service will just sort out these files according to their types. For example, if I look at the messages file, you can see a lot of logs. Today is 12th of April. So these are the logs that are related to the system on 12th of April. I can use the grep file to sort out the time and the date of the logs that I'm looking for or I want to see. So now that you understand how the journal D and the RSys log works, so what happens to a user? This is a user. So what happens to a user if you need to get logs from the system? Because services can either log their event or their logs in journal D or in RSS log. So depending on the service, depending on the application or the developer,
The service might either choose to log their logs via Journal D or via RSS log. There are some services, there are some applications that would even, log their events in a different location entirely. So, which means as an administrator or a user, you can, if you need to get logs, you would either check the Journal D binary file or you check the RSS log, which is the /var/log, or you even check the different location where the application is logging its event to. And this can be tiring as an administrator, especially when you have a very complex and large environment that you're managing. I mean, checking all these locations to get your logs, it can be overwhelming sometimes. But the good thing is, um, you as a user or an administrator, you can configure all your logs to be logged via Journal D. So whatever logs that a service or an application is going to log, all of them would go to Journal D binary file. They can be logged via Journal D. And if you don't want, maybe you don't like Journal D, you can also decide that all your logs it should be they should all be configured via the RSS log service. So you can choose either of the two. If RSS log is your friend, maybe General D is your enemy. So you just make sure that all your services are logging via the RSS log service. So another thing you should know, I mean, is that you can also have a central log server. You can configure your log files to a central log server for easier management. Yeah, so all your logs would come into a log server, especially when you have a lot of systems. I mean, in the environment, you can have a log server, and for easier log management, there are other tools as well that can manage your logs for you. Or I know of the ELK stack. Yeah, in one of the videos too, I'm going to show you how to configure the ELK stack. The E is for the Elasticsearch, L is for Logstash, and K is for Kibana. So I'll show you how to use this tool to manage logs in the system. We also have utilities like the log check utility for easier management of logs. We also have the log watch, and then we also have the SolarWinds log and event manager. So this is how you can intelligently, you know how to or envisage how to manage your logs on the system. So thank you for watching, and bye for now. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today I'll be talking about how you can view your logs with the journal.ctl utility. In the previous video, I talked about log management in Linux operating system, and we looked at how the journal.d service works and how the RSS log service to operate. And I said I was going to talk about the usage of the Journal City utility in many ways. All right, so this is my system. So I'm going to use Journal CTL command. This Journal CTL command will display all the logs um, in Journal D. So let me broaden my screen so you can see the logs, or the logs we have. But then sometimes you might need to filter your logs to actually get the specific error you're looking for. So there are a lot of ways, there are a lot of flags you can use with general CTL. For example, if you want to check the real-time logs with general CTL, you can just use the command as against -f. So let's do that. Use -f. I see the real-time log. You can see this one failed to start open SSH server daemon. So whatever thing that is happening on the system, you keep seeing it as it is happening in real time. And if you remember that in our previous video, we had this error where I wanted to restart my OpenSSH, but I couldn't because of a configuration file I moved away intentionally. So another way you can filter your logs with general CTL is the R command. When you use it with the -r, I mean when you use it with the -r, yeah. So you're saying that the logs should be displayed from the newest to the oldest. Normally, if you just use the general CTL command, it displays the logs from the oldest to the newest. You'll have to scroll down to get the newest logs. But if you don't want it that way, if you want to display from the newest to the oldest, you just use the general CTL with the -r command. This displays from the newest to the oldest. So another thing you can do with the general CTL command is when you use it with the -b flag, which means that it should show you the last boot of the system. So if I use general CTL-b, it's going to show me the last boot of my system. And use the you can also use it within a time range. Yeah, you can do something like this. Journal CTL since am I correct? Yeah, correct with the command since yesterday. Okay, so you can also see the logs that's taking place since yesterday. So you can also use the flag since today. You can make this since today as well. You can see the logs that has been generated today. Of course, we know of this OpenSSH server daemon. If you watched my previous video, you would remember. And you can also use flags like since 1 hour ago. I can do this since 1 hour ago. Okay, so you can see the logs that's been generated on your system since 1 hour ago. No, you can also, if you want to view the kernel messages, you can use general CTL with the -k. This shows you the kernel messages. And to view a specific logs for a specific service, you can use the flag -u and you put the service name. In this case, let's use SSHD service, and you can see the logs that are generated as against the service. And if you can use general CTL with a lot of flags. If you want to know more about general CTL, just go to the man page of general CTL, and then you can know more about general CTL, how you can use general CTL and the things you can use it for. It's a very powerful tool, and you know, you can use it to get a whole lot of logs from your system. So thank you for watching, and please subscribe to this channel. Hi everyone, my name is Victor, and I am one of the authors of techneed.com. Today I'll be talking about how to set up log rotation using log rotate in Linux operating system. Have you ever wondered why the /var/log file system never get to fill up when you're running a moderate application on your Linux system? This can only happen by a mechanism called log rotation with the use of log rotate tool. Log rotation is a process whereby logs are rotated away from the system automatically and systematically, and the systematic rotation of logs depends on the argument that is defined in the log rotate configuration file. With the log rotate configuration file, log rotation can be configured in many ways, and we have two log rotation configuration files. We have the one in /etc/log rotate.conf, and this one contains the generic information for log rotation. Let's have a look at the file, and so we see what we have here. So you can see that this file is self-explanatory, and this is the default for a Red Hat 8.1 system. When you look at the first field, which says rotate log files weekly. So this field weekly means that the log files should be rotated weekly. I can put monthly depending on how I wish to configure my log rotate. The second field, which means that 4 weeks worth of backlogs should be kept. So after the fourth week, the fourth log file will be deleted automatically and a new log file will be created. So I can change this value to 2 to 3 weeks to whatever I want. You should know how you want to configure your environment. And the third field, which says create new empty log files after rotating old ones. So it means that new empty log files should be created after rotating the old ones. And the fourth one, which is use date as a suffix of the rotated file. That means at the end of the file, of the log file, you should use the date as an extension. If you watch my previous video, I said I was going to explain this in log rotate. When you check the var log, one of the files in var log, we saw that the end of the file was carrying a date extension. So it's just a way to quickly remember when the log was generated because it's going to show the date. And we're going to see that as well in this video. And this other field means that you should compress your logs. Yeah, if your application generates a lot of logs, you might want to compress it. And before you can view the logs, of course, you would need to unzip. So if you uncomment this, that means you want to compress your logs. And this other field, RPM packages drop log rotation information into this directory. So it means that you should allow other services, RPM packages, to be able to define their log rotation settings in /etc/log rotate directory, which is this directory, and include configuration from /etc/log rotate.d, which is the second configuration file for log rotate. So this, like I said, this is generic. So if you want to configure a log rotate for your system or for an application,
you would need to define it. You can define it here as well. Yes. Look at this last field. System specific logs may also be configured here. But for a standard, it's best you define it in this directory, etc slash log rotate.d directory. So this is a directory where users can define their log rotate script for a particular service. If you look at the content in here, you see other scripts, other log rotate configuration file. So for example, when you look at the librat.d, the librat.d is for KVM virtualization. If I open this, you can see the fields I have here, just as I've explained earlier. Weekly, it means the logs should be rotated weekly. Missing okay, I would explain some of these things too. I explained compress, it means that the logs should be zipped, you know. So these are the things you see in a log rotate script. And as a user, you might also want to define your own script for a particular service, and it is best you do it in this location. If you have a log rotate script for a particular service here in this directory, and you also have it in log rotate.conf directory, the definitions here in this directory, the definitions here would override the ones here, because the definitions here takes up higher preference over the ones here. So it's going to override whatsoever configuration you have here. Let me repeat myself again. The definitions, the script you have in logrotate.d directory will take higher preference over the ones you have in logrotate.conf file. So if you have a script defined for two services in both location, the one in logrotate.d would override the one in logrotate.conf file. So for this argument missing okay, it means that it is okay for the log files to be missing, and if it is missing, don't give an error, just go onto the next file. It is also possible to set the value to non-missing okay. And for the delay compress, it means that the compression of the previous log file should be delayed until the next rotation. Hence, without the compress value being defined in the script, this value is not useful. For the copy truncate argument, it means that the original log file will be truncated to 0 after a copy has been created. And for the min size value, it means that the log files should be rotated until they grow bigger than the size byte. However, if a time is specified, it won't be rotated before the time. So for some Linux distribution, log rotate is not installed by default, but I note that for modern distributions, log rotate is installed by default. So to confirm if log rotate is installed in your system, you can just use the command rpm-qa to query log rotate. All right, so you can see the log rotate package being installed on my system. So in the next video, I will show you how to configure log rotate for services. Thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone. So in my previous video, we already looked at how log rotate works. So in this video, we're going to be looking at how to set up log rotation for a service in Linux. Okay, so let's say I have a service, an application called TechNeed, and the application is configured to log its event in var/log. So how do I configure
log rotation for this application. So we're going to go through the step-by-step process of doing that. So let me check /log directory. So you can see the logs we have here. So for the purpose of this video, I'm just going to create a log file for TechNeed. So I can put my first, oh, okay, my first log file. All right. So just for the purpose of this class, so you can see technique.log as so I'm just saying that okay technique.log is a log file in this directory. So now that I have the log file, I'm going to configure log rotation. So like I told you, you should define it in the log rotate.d directory. So technique, I'm just going to um, define my script here, how I want log rotation to be configured. So I'm going to copy and paste from the site because I already have some scripts that I defined on the site. I'm going to be dropping the site link in the description section or in the comment section, so you can just check and copy and paste as well. So this is my script. I've already explained all these fields in the previous class. So I'm going to say yes. For the purpose of this video, I'm just going to do a force log rotation. Rotate. All right, now that I've done that, let me check my log rotate, my var log directory, I mean. All right, so you can see the log here, and then you will remember that in my configuration file, okay, yeah, I know I didn't define that the extension should end with the date, but in the generic configuration file, which is this one, log rotate.conf. Yeah, so I said by default this happens by default, so it's defined that the log rotate the log file should end with a date extension. So it's carrying this default definition. So this is how you configure a log rotation for a service. Thank you for watching this video, and please subscribe to this channel. Hi everyone, my name is Victor and I'm one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at scheduling tasks in Linux. Alright, so just as there is the task scheduler on Windows operating system, there's also the cron and the ATD daemon in Linux that runs scheduled tasks in the background. Alright, so scheduling tasks is very important for system users, more importantly for system administrators, especially to be able to automatically perform some repeated and regular activities such as backups, maintenance and so on and so forth. So in Linux, the two basic services that are responsible for scheduling tasks are the cron and the ATD service, right? So as we go on, we'll look at what cron is and we'll also look at what AT is. But before that, quick one, if you're going to be writing the RHCSA 8 exam or the Student Linux exam or the LFCX exam, you can just come to this website. I'm going to be dropping the link to this website in the description section below, alright? And at the end of every lesson, we have the RHCSA 8 exam practice questions. So just scroll down and you click
on the exam practice questions. Alright, it's important you practice before you write the exam, and we have over 100 questions that we're going to be solving, and we're going to be updating the website from time to time. So it's better you subscribe to the YouTube channel or you subscribe to our newsletter so you can be updated. Alright, so we're looking at cron, right? So a cron is the job, or is a program rather, that is used to schedule a job in Linux, right? So if you have a job or a task that you want to schedule, say at a particular time or period, alright, you can use the cron program to do that. Okay, and just as I've said that the service responsible for that is the cron service, and for an administrator or a user to be able to configure and run a scheduled task, the cron daemon must be running. So to verify this cron service, you use the command systemctl status cron. Alright, so you can see that the service is active and running. This service must be active and running before you can schedule a task using cron. Alright, cron is very flexible and best for tasks that needs to be done repeatedly or on a regular basis. So the cron configuration file can be found in many paths, one of which is the etc cron tab. Alright, so let's cut this file so we can see what we have here. Okay, so this file is always automatically modified by system or packages, so it is not recommended a user or an administrator modify this file to schedule a task. Alright, and we also have other cron configuration files, like let's check the etc directory, and then let's list the other cron configuration files we have. Okay, so you can see that we have others like the cron.d, we have the cron.daily, the cron.deny, the cron.hourly. Alright, and as the names of these directories imply, they execute shell scripts or job daily, like for the cron.daily. Alright, and for the cron.hourly, this executes script hourly. Alright, and for the cron.monthly, this executes script monthly. Okay, and they are used by RPM packages, and these packages just know how to use these files to execute their jobs. So for a user or an administrator to schedule a task, alright, it is recommended you define your cron tab files or scripts in the cron.d directory. Alright, so it's recommended you do this, define it here, or you use the cron tab e command to launch the cron tab editor. Alright, and the cron tab is an acronym for cron table. Alright, so it's the scripts or files that will run the cron job with the use of the cron daemon. Alright, and the cron tab command with the -e option will always launch the cron tab editor, where you can always define your script for a cron job. So for example, if I press enter, you can see that the editor is being launched, and here I can always define my script for the cron, for the cron job. Alright, so as we go on, you would understand how we can always define our script to schedule tasks in Linux. And another thing you should know is that it is always advisable that you switch user, alright, to the user that wants to run the job, or you log in as the user to give room for the right permission. So what I mean is, for example, if I want to run the cron job as a user Victor, I'm going to make sure that I switch my user to user Victor. Alright, and when I'm logged in or I'm in the system as user Victor, I can then run the cron tab -e command to launch the cron tab editor, so that I can edit my script for task. Alright, and if you also want to run the task as a root user, alright, if you're not logged in as a root, it's always advisable you log in as the root or you switch user to the root so that you can easily have the right permissions given. Okay, in next video we're going to look at the step-by-step process of how to schedule a task in Linux using cron. Alright, so thank you for watching. Please subscribe to this channel and bye for now. Hi everyone, welcome to the next section of this video. In this video we're going to look at the step-by-step process of how to schedule a task in Linux using cron. In the previous video we've looked at what cron is. We've also looked at the cron daemon. Alright, and quick one, if you're going to be writing the RHCSA 8 exam or the LFCX exam or the SUSE Linux exam, you can scroll down to the end of this website and click on the exam practice questions. It's important to practice before you write the exam, so I'm going to be dropping the link to this website in the description section below. Alright, and we also have over 100 questions that we're yet to solve, and we're going to be updating the website from time to time. So it's better you subscribe to the newsletter or you subscribe to the YouTube channel so that you can always get the latest updates. In the previous video I mentioned that to schedule a task in Linux you can either use the cron tab -e command to launch the cron tab editor, or you define your jobs in the cron.d directory, which is the /etc/cron.d directory. Alright, but before we look at how to do all of these, let's see examples of a cron job definition, and that can be seen in etc cron tab file. Alright, so when you look at this file you can see this is example of job definition, and you can see this first line. Okay, and the first line represents minutes, which is from 0 to 59 minutes. Okay, and the second also represents hour, which is from 0 to 23 hours. The third line represents the days of the month, which is from 1 to 31 days. Alright, and the fourth line represents months, which is from 1 to 12 months, and it can also be written, you can also define it as January, February, that is the first 3 letters of the month. Alright, while the fifth line represents the days of the week, which is from 0 to 6 days. Alright, and it can also be defined as Sunday, Monday, which is the first 3 letters of the week. Alright, so this you can also see star here. Alright, so these examples of job definition can also be compared to as this line. Alright, just like I show you that when you see star here followed by the username and command to be executed, so just like when you have the star 5 stars 1 2 3 4 5 followed by the commands that's supposed to be executed. Alright, just as I've explained that the first star of course will represent from 0 to 59 minutes, the second star will represent from 0 to 23 hours. Alright, so this is what all of this means. Okay, so the star, the wildcard star means every. When you see star it means every. Of course we've discussed this while we're talking about wildcards. Alright, so this script simply means that execute every minute. Alright, execute every hour, execute every day of the month, execute every month, execute every day of the week. Alright, followed by the command or by the script. Hope you catch that. So let's do this with examples so that we can fully understand. So we're going to be logging some information in the system log. Alright, we're going to be creating a cron job. So if you want to read more, I'm going to be dropping the link to this website in the description section below. Alright, so if you want to read more about it, you can just come to this website. So the first thing we need to do is to launch the cron tab editor. So that's the method we're going to be using here, which I'm going to run the command cron tab, alright, -e. Then I'm going to execute for every insert. Alright, so I'm going to execute for every here. You can see my screen. Okay, so it means execute every minute, okay? Then execute every hour, okay? Execute every days of the month, execute every month, all right? Then execute every days of the week, all right? Which means, so this script simply means execute every minute. That's what it simply means. Let's use this command logger. I'm just going to say test, okay? I'm going to save this file. I'm trying to expand my screen so that you can see. Okay, then I'm going to press the enter key so you can see that this job has been created. You can see here that installing new cron tab job. All right, so let's check the time. It's 04:00, that's 12:04 00:04. All right, so this should execute every minute. And to test what we have done, let's see the system log file, which is the val log messages. Okay, so you can see that it has started running. The job has started running. You can see here 00:05 now. All right, started session 42 for user root, and it has logged it. You can see the test command here. All right, so if I also do val log messages again, it should log another one. Okay, it is still 00:05. all right, by 00:06 it should log another one, because the script or the task simply means that always run this every minute. So let's confirm another one. So you can see that another one has been run here. You can see that this is working. So this is another example. If you are to schedule a job to execute every Thursday by 2 a.m., the script will be written as 0, which means do not execute every minute. Then every Thursday, which is 2 a.m. all right, this is hours of every Thursday, which is for 4. all right, okay. So you can see other examples here. This is if you were to schedule a job to execute from Monday to Friday at every 3 a.m. So for intervals, Monday to Friday, it can be 1 to 5. all right, we've explained this here. This is 0 to 6. okay, so this shouldn't be a problem. Using cron is very flexible, all right, and it can also be used by some certain words such as at daily, at weekly, at monthly, and at yearly. So for example, if you want to run some scripts daily, you can just use at daily followed by the job or by the script. all right, and you can also redirect the output of a cron job to a file, and this can be run just as this. all right, so in the next before that, to remove a cron job or the cron jobs for the user, you use this command, which is cron tab -r. So for example, to remove all the cron jobs that I have on the system, use the command cron tab -r. This will remove all the cron jobs. all right, and for me to confirm that I don't have any other cron job, I use the command cron tab -l. all right, so you can see that there is no cron tab for root. okay, so in the next video I will show you how to use the AT utility to schedule tasks in Linux. all right, so thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, welcome to the third section of this video. In this video, we're going to look at how to use AT to schedule a task in Linux. In the previous video, we've looked at how to use cron to schedule a task in Linux. And quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LF6 exam, just scroll down to the end of this website and click on the exam practice questions. all right, we have over 100 questions that we're going to be updating this website with from time to time. It's better you practice before you
write the exam. All right, so I'm going to be dropping the link to this website in the description section below. Okay, so AT, just as cron job, is a program that is used to schedule a task in Linux. All right, and AT is excellent for tasks that needs to be done just once and not repeatedly. Unlike for cron, it is best and excellent for jobs that needs to be done regularly or repeatedly. So if you just want to execute a job just once, all right, it's best to use the AT utility. But if you want to execute a job repeatedly and regularly, it's best to use cron. Okay, for a user or administrator to be able to run or schedule tasks with AT, the ATD service must be active and running, and to verify that the ATD service is up and running, you use the command systemctl status ATD. Alright, so you can see that the services or the daemon is up and running. Alright, if you don't have the AT package, you can just do your install AT to install the AT package. Alright, so now let's see the step-by-step process using examples of how to schedule a task using AT. So let's do dates, and you can see that the time right now is 00:35, which is 12:35. Alright, so for example, to schedule a one-time task to run at let's say 00:38, okay, we need to use the AT utility followed by an argument. Okay, so for example, now I'm going to use the AT, which means at. All right, at 00, let's say 38. All right, then I'm going to press the enter key, which would launch the AT shell. All right, you can see the AT shell being launched. Hope you can see my screen here. So what we need to do now is to begin to enter the script or the command that we want AT to run. All right, so just as we did in the previous video, let's do logger. Let's log to the system log file. So let's do logger test2 here. Okay, and we'll press the enter key. So when we are done, we press the Ctrl D to terminate the shell. So you can see that job 3 at Thursday, September 00:38. So let's see the time now. This is 00:37. So by 00:38, the job should be logged to var log messages file, which we're going to confirm now when it's 00:38. So we have some seconds to go. So let's check the time again. So it's now 00:38. Okay, so let's verify. Let's do this. var log messages. Alright, so you can now see that at 00:38, alright, a new session 51 for the user root was created, and you can now see that the job was executed. Okay, to verify the number of jobs that are to run using AT, use the command ATQ to do that, and to remove an AT job also, use the command ATRM, which is AT remove followed by the job numbers. Alright, so the other special argument that can be used with AT are the AT now plus 3 minutes. So when you use AT now plus 3 minutes, that means it's going to calculate the time, the present time, and add it with 3 minutes to execute the job. Alright, you can also use AT 8 a.m. tomorrow. Okay, so that means by 8 a.m. tomorrow, AT will execute a job. Alright, you can also use the AT 1 p.m. plus 9 days, which means it's going to calculate 1 p.m. plus 9 days to execute the job. And you can also use this 4 a.m. March 20. Alright, so to see how AT2 is somewhat flexible, and to know more about AT, you can just check the man page. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor, and I'm one of the authors of technique.com. Today, I'll be talking about how to synchronize or configure time in Linux. The correctness of time in an operating system is very important, especially if it is a log system or server that has to do with tracking of various logs and activities at a particular time. Correct timing is essential in this case. If you're also in a virtualization environment where you have to do with a lot of clustering, you would know that correct timing and time synchronization is very important. I cannot even overemphasize how timing is very important in financial sector or government sector. So correct timing can be done with the use of NTP, which means Network Transfer Protocol. NTP is a protocol that is used to automatically synchronize time over a network, and NTP is server and client based, whereby you have NTP servers sitting somewhere as a pool of servers in different zones and regions. And for you to have your time to be synchronized with NTP servers, you need to configure NTP client on your Linux system. So we're going to look at the step-by-step process of how we're going to configure NTP client. We're going to be using Crony in this tutorial. Prior to this time, other distributions and even Red Hat usually use the NTPD service for the NTP client, but that has been deprecated. Now Crony is used. So we'll look at how to configure and synchronize time with Crony on a Red Hat 7 and 8 system. In some Linux distributions, Crony is not installed by default, but in Red Hat 7 and 8 system, Crony is installed by default. So I'm using a Red Hat 8 system. So in your case, if Crony is not installed, you will just have to install Crony. If Crony has been installed, the next step is to verify the status of Crony. So you can see that Crony is running. If Crony is not running after installation, all you need to do is to make sure that you start the service, and if you want to enable the service, you can do that as well. The next step is to verify the current time and the NTP status by using this command. So I can see my current time in UTC, and I can also see the time zone, America, and I can see that the NTP service is active. In the advent where the NTP service is not active, you need to make sure that it is active, and to do that, you need to use the command. You need to use this command and set NTP to be active. So with this command, if NTP is not active, NTP becomes active. And the next step is to verify if NTP has started by also checking the Cronid service again. You can also do this again. You would see that NTP has started. So this is another way to check if NTP is actually working or not. So to get the current time zone, use the command time dctl. So this will give you the time zones that we have. My time is currently set to my time zone is currently set to America, and presently I'm in Nigeria, Lagos to be precise, and I'm going to look for Africa, Lagos. All right, so this is Africa, Lagos. So I can set my time zone to be Africa, Lagos. To do that, I'm going to use the command should do that. So now I'm going to verify again. So you can see that my time zone is Africa, Lagos, and you can see that I already have the correct time. Presently, it is 21:58 UTC here, and now my NTP is also active as well. So which means that my NTP, my coding service can of course or will of course synchronize from the NTP server. So this is how you both synchronize and configure time with coding in Linux in a Red Hat Enterprise Linux system. So thank you for watching. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course. We're going to be looking at troubleshooting steps and how to boot to the single user mode. Alright, quick one, if you're going to be writing the RHCSA 8 exam or the LSCX exam or the CZ Linux exam, just come to this website and click on the exam practice questions, or you scroll down to the end of the chapter. At the end of every chapter there's always exam practice questions pertaining to that chapter. Alright, so I'll be dropping the link to this website in the description section below so that you can easily navigate. Alright, so what is single user mode in Linux? From the word single, the single user mode is the mode in a Linux system where only one user, single user, right, the root is allowed to perform system tasks. Alright, so single user mode is also referred to as run level or run target 1 and can be called emergency or maintenance mode. Alright, and booting in this mode can be done in many ways. In one of the videos I discussed how a system run level or run target can be changed from an operational mode, that is from the command mode, and we did that, and how it can also be changed from the boot menu. Alright, but both methods will still require the input of the root password. Alright, but in this video we'll look at how to boot into the single user mode without inputting the root password. Alright, so in single user mode the system is booted to a minimal environment with the file systems, that is the local file systems, be mounted. Alright, but without network services, so the full operating system is not functional in this mode, and most services will be manually mounted. Okay, so you know this mode is just basically used for maintenance, like I've said, and troubleshooting such as resetting a lost root password, which we're going to also look at in the next video. Alright, so we can also, in this mode, we can also repair bad file systems, such as executing the fsck command. Alright, and also editing the fstab file to make the system boot properly in the event where the system has stopped booting because of a file system. Alright, and we can also stop services disrupting the system from booting in this mode. So this mode is most especially used for troubleshooting and maintenance purposes. Alright, so in the next video I'm going to show you the step-by-step process of how to boot into the single user mode. Thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the second section of this video. We're going to look at the step-by-step process of how to boot your Linux system into the single user mode. Alright, in the previous video we looked at why boot into the single user mode and the things you can do in the single user mode. Alright, so I have a lot of methods on how to do that here. Okay, well, I'm just going to be using the first method. I have about 4 methods here. I'm going to drop the link to the website in the description section below so that you can also check out other methods if you want to. I'm just going to show you the first method of how to do that. Alright, so when the system is being powered on, alright, so let's power on the system, and as soon as the boot process gets to the drop menu, you need to interrupt the drop menu by pressing the E key, which means edit, on the kernel that you're using. Alright, so this is the kernel that I'm using, so I'm just going to press the letter E on my keyboard
to edit the kernel, and I'm going to go to the line Linux. Sometimes you might see it as Linux 16 on some operating system. I'm going to look for the parameter RO. Okay, I'm going to change this RO means read only. I'm going to change this to read write. Okay, root file system permission needs to be changed to read write for root to be able to make changes. All right, so I'm going to do read write init. Okay, so let me expand this screen, this console, so that you can see what I'm doing pretty well. Okay, so I'm going to do this read write equals init. Okay, followed by, all right, so there's going to be a space between the read write and init. Let me do this again so you get what I'm trying to do, because I just expanded the screen. So this is going to be read write init, okay, equals /sysroot /bin/bash. all right, so when you're done with this, you need to press the Ctrl X key to put the system into the single user mode. All right, so I'm just going to do Ctrl X, and then the system would go into the emergency or the single user mode. All right, so let's wait for the system to boot into that mode. So you can see that we are in the emergency mode or the single user mode. All right, and to mount the real root partition, all right, we need to use the command chroot /sysroot. okay, and you can see now that the real root partition has been mounted. At this point, the system is minimally available, and it is also restricted to some commands actually, so you can begin to perform your activities here. All right, you can begin to perform your maintenance here, just like you're already logged into a fully functional system. So you can also, for example, say if you want to edit the fstab file, you can do cat etc fstab file, and if you need to edit anything, you use the vi text editor, and you edit the file system or the storage or whatsoever thing that is causing your system not to boot. All right, and if you also want to do your file system checks here, you can also do it here. If you also want to reset your root password, all right, you can do it here. All right, so this is how you this is one of the methods to boot a Linux system. This is Red Hat 8. all right, so to boot a Linux system into a single user mode. All right, so thank you for watching, and please subscribe to this channel, and bye for now. Oh, I didn't mention that if you want to exit, all right, so if you want to exit, just use the exit command, and if you want to exit the single user mode, all right, you can use the exit command again. So that means you're logged out, and then you can reboot your system by using the command reboot. Let me look for this recorder and make sure that I get the right screen to capture. 1 minute please. Okay, so you can see the prompt here. So now I can reboot the system by using the command reboot, and then my system would be rebooted. Okay, so you can see the system being rebooted. So this would boot the system into the default mode. All right, so thank you once again, and please subscribe to this channel. Bye for now.
Hi everyone, my name is Victor, and I'm one of the authors of Technique.com. Today we're going to continue with our course, and we're going to be looking at how to reset root password on Red Hat 8 system. All right, and quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LFCS exam, you can just come to the website and click on the exam practice questions. You can see here where my mouse is, or you scroll down to the end of the topic and click on the exam practice question. So at the end of every chapter, there is always an exam practice question for this course. All right, we have over 100 questions that we're going to be updating the website with from time to time. So I'm going to be dropping the link to this website in the description section below, and it's also better you subscribe so that you will always get updated. Okay, so working on and troubleshooting several Linux servers, either
as a Linux engineer or administrator, or even on test environments, may require having to know several passwords for different systems, alright? So it is even very possible for one to forget the most important password of a system, which is the root password. I remember one time, a period when I was on site with my team. We were to deploy several servers, and my team and I had completed the deployment. We tried to log into one of the Linux servers to continue with the configuration, and we were denied with an error message of incorrect password, right? The best option was to reset the root password for the deployment to continue at that time. Of course, I could have reinstalled the server since it was a fresh deployment and nothing was on it, and we had not even handed it over, but that would be a long process, alright? And also, if I were in a production server or quality assurance servers that's got critical information, will you have to reinstall the system? So that's a capital no. So that's why you need to actually know how to reset the root password as an engineer or an administrator, okay? So I have different methods of how to reset the root password. I have about 4 methods here, alright? I'm just going to show you the first method. Just as like I've said, I'm going to be dropping the link to this website in the description section below, so that you can actually go through it if you want to reset the root password. More so, if you want to understand what is happening while you're resetting the root password, I've explained it here, understanding the process of how to reset and recover the root password in Linux, right? What happens, how you break in, what happens to the init RD, alright? What happens to the CH root, what happens to the multipath and other drivers on the system, alright? If you just want to learn more, you can come to this website and learn that. I'm not going to be explaining this in this video, right? So in the next video, I'm going to just show you the step-by-step process of how to reset the root password with the first method, alright? So thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, welcome to the next section of this lesson. In this video, I'm going to show you the step-by-step process of how to reset the root password on a Red Hat 8 or CentOS 8 system. Quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LFCX exam, just come to this website and click on the type of exam practice questions that you want to write, okay? I am going to be dropping the link to this website in the description section below so that you can easily navigate. To recover or reset a root password, the first thing you need to do, of course, is to restart the system. So let's power on the system, okay? So what we need to do is to boot the system into the single user mode, alright? So as soon as the boot process gets to the grub menu, we need to interrupt the grub menu by pressing the E key on the kernel that we're using. So we're using the first kernel, alright? So I'm just going to edit this kernel, and on the line Linux, I'm going to edit this parameter. So let me just make this screen big so that you can see what I'm doing pretty well. Alright, so I'm going to edit the line RO, which means read only, to read write, okay? Root file system permission needs to be changed to read write for root to be able to make changes. So this is going to be read write. We did this in the previous chapter, alright, so this shouldn't be a problem. Read write init equals /sysroot, okay, /bin/bash, and we press the Ctrl X key to boot the system into the single user mode. Alright, so we'll wait till the system gets to the single user mode. Now that we're in single user mode, let's mount the reroot partition. Alright, to do that, we're going to use the command chroot/sysroot. Okay, so now we can edit the root password. So I'm just going to change the root password. I'm going to give it a new password. Okay, so the root password has been changed. The next step is to relabel SE Linux context to make the changes permanent. So in one of our previous chapters too, I talked about SE Linux. We've learned SE Linux as well. So I'm just going to use the command touch dash then followed by dot auto relabel, and we'll press the enter key. Alright, so now that this is done, we can unmount the reroute partition by pressing the exit key. Okay, and also we write the command exit to log out of the single user mode. Alright, so now we can reboot the system. Okay, so you can see that the system is being rebooted for login. Alright, so this is how you're going to reset the root password on a Red Hat 8 or OS 8 system. This also cuts across a Red Hat 7 system as well. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Oh, I'm just waiting. I want it to fully come up. Alright, so I guess the system is fully up. Alright, so let me just wait till it shows me the login prompt. Alright, here we go. So the system is fully up now. So thank you for watching once again. Bye bye. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at how to configure NFS on Red Hat 8 system. NFS, which is an acronym for Network File System, is a distributed file system protocol, and NFS is server client based, where the NFS server will be configured and clients can access files on the server over a network just as if they were on the server. Alright, so NFS is one of the file system standards for network attached storage, NAS, and it can be used as a storage solution. So for example, if you're looking for if you don't want to spend much on the storage solution, you can use NFS. And of course too, you wouldn't be able to do much on storage when you're using NFS. Alright, clients can always access and update the NFS shared files depending on the permission given on the files. So in this lesson, we're going to configure NFS with two systems. One will be the NFS server and one will be the NFS client, and the NFS client will be able to access the NFS server. Alright, so quick one, if you're going to be writing the RHCSA 8 exam or the LFCS exam or the SUSE Linux exam, you can look at my my cursor. You can just click on this RHCSA 8 exam practice questions to practice before you write the exams. We have few questions there, and we have over 100 questions that we're going to be updating it with. So from time to time we're going to be updating it, and at the end of every of our articles we also have the RHCSA 8 exam practice questions pertaining to that topic. So you can always click to, alright, and practice. Okay, and I'm going to be dropping the link to the website in the description section below so that you can easily navigate if you want to. Alright, so this is going to be the NFS server. So we're going to set this up as the server, and the first step to take is to install the NFS utility, and to do that we're going to use the command yum install NFS utils. Alright, so you can see that the package is already installed. I already have it installed here on the system. Alright, so if yours is not installed, it's going to install the package. And the next step is to verify the status of the RPC bind. If it is not running, you start it, and if it is running, you just leave it. Alright, you can see that RPC bind is running. Alright, and if it is not running, you just start the service. And the next step to take is to start the NFS server service. So to do that, you use the command systemctl start NFS server. All right, so the service is started. You can just confirm. Alright, so you can see that the service is active and it is running. Alright, so if you're using a Red Hat 7 system, to start the NFS service, you use the command systemctl start NFS. Alright, so I'm using a Red Hat 8 system. Okay, so the next thing to do is to create the NFS shared directory. In this case, the NFS shared directory that I want to create is software download. Alright, so you can choose to use an existing directory depending on the directory you want to share. So in this case, I want to create a new directory. I'm not sharing an existing directory, and to do that, I'm going to make that directory. So I can just use the command make directory, and I'm going to call the directory software download. Alright, now I have the software download directory. So the next step is to edit the etc export configuration file. Alright, which I'm going to do, and I'm going to add the client IP in the file. So let me bring up the client. So here's the client, and I'm just going to get the IP. So the IP is 192.168.170.171. Alright, so I'm just going to add it here in the export file. Alright, so like I said, I'm going to be dropping the link to the website in the description section below. Alright, so you can just I'm just going to copy and paste it here, what I'm going to be adding here. Alright, oops, sorry, that's the client, so this is the server. Okay, so I'm using this read write option, sync option, no root squash. So if you've gone through the RHCSA 8 course, in one of the lessons we learned about fstab file and the parameters that we can have in the fstab file. So we've thought about that. All right, so I'm just going to save this file. Okay, and then I'm going to restart the NFS server. Restart NFS server. I'm also going to restart the RPC bind. Alright, so I'm going to allow the NFS services in the firewall rule. Alright, so because if the client wants to access the server and the service of the port is not allowed in the firewall rule, alright, you will not be able to access the server. So I know that in one of our lessons, our previous lessons, we've talked about firewall. We explained everything about firewall. So if you don't really understand how firewall works in Linux, you can just go through that course and learn about firewall in Linux. So I'm just going to copy and paste this from the site as well. Alright. Okay, my firewall is not running. I need to make sure that it is running. I'm sure I must have stopped it while I was doing some configurations. Alright, so I'm just going to add the firewall rule. So that's a success, and I'm just going to reload the firewall as well. Alright, so now we're done with the NFS server configuration. So let's set up the client. On the client, I'm also going to install the NFS utility. Alright, so I already have it installed. Alright, if yours is not installed, it's going to be installed. So the next thing to do is to check the RPC bind status. Oops, bind. Okay, so you can see that RPC bind is running. Okay, so the next thing to do is to verify the NFS shared directory from the server. Alright, so we're going to see if it is available on the client or not, and to do that we're going to use the command show mount -e, the name of the IP of the server, and of course if you're using FQDN you can use the FQDN name. Alright, so let me just bring up the IP of the server. So the server's IP is 192.168.170.173. Alright, one 68 170 173. Okay, so you can see the export list here, which is software download, alright, from .173. so you can see that the client can access the server and the shared directory can be seen. Alright, so I'm going to create a mount point for the NFS share. Right, I can call the mount point anything I wish, so I can just still call this mount point software download. Alright, so let's just call this software download. Okay, so the file already exists anyways, so what I'm going to do next is to mount the NFS shared directory, and to do that I'm going to use this command. Alright, so I've just copied it from the website as well. You can do that too. So I'm going to use the 173, so I'm saying that mount this NFS shared directory, alright, from this NFS server on the path software download, and also mount it on the NFS client on software download. So whatever directory you create here, or the mount point you create here, be it Victor or Technid, you're going to be mounting it here. So I have created software download, alright, and that's why we're going to be mounting it on software download. So let's confirm if it is mounted. So you can see that the directory is mounted. So the directory from the server here is mounted on the client. So which means that whatever thing I want to do on the server, I already have it mounted here, and I can always access the NFS shared directory from the server. Alright, so whatever thing I'm doing on this directory, I'm just doing it. It's on the server, but I'm just doing it here on the client as if I am on the server. Alright, so what we can do as well is to make the mount point persistent across reboot, and to do that we're going to be editing the fstab file. Alright, so we're just going to do this. I'm going to edit the fstab file, and I'm going to add this parameter in the fstab file. Oops, so I already have one here. Okay, I must have done this while I was preparing the article on the website. Alright, so this is one here. So this is the parameter that you're going to add, alright, which is the IP, the server's IP 173. Alright, then software download and all these parameters. So like I've told you, we've learned about all of these parameters that I can add in the fstab file when we talked about storage management in the course of this study. That should be one of our previous video in the RHCSA 8 course. Alright, so I'm just going to save this. I'm going to do mount -a, so which means that when this system reboots, alright, this mount point will be persistent. Okay, so that's how you're going to, that's how to set up NFS services on Linux, whether that's 8 system or CentOS 8 system. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of technique.com. Today we're going to continue with one of our lessons, and we're going to be looking at how to use AutoFS to mount NFS shares in Linux. In one of our previous lessons we've talked about configuring NFS in Linux. So we've looked at how to configure NFS server. Alright, So we've looked at the step-by-step process of how to do this. We've also looked at how to configure NFS client, alright, and we've ascertained the fact that we can make NFS shares persistent with the use of fstab file. So in this lesson, we're going to look at how to mount or make NFS shares persistent with the use of AutoFS service. If you're the type that always configures NFS services, you must have noticed this, because it has happened to me many times, whereby when I have the reason to reboot the NFS client, you will just notice that during the reboot process, the server doesn't boot to the full operating system. It just stops at maintenance mode. And when you check the reason behind this, you will notice that one of the entries in the fstab file is not referencing the NFS server, and that's because the NFS server is down. Alright, but with the use of auto mount like AutoFS service, all this kind of problem has been eradicated. Alright, so you can actually make the NFS shares persistent in Linux without putting an entry in the fstab file, and that is why auto mount or AutoFS has a better performance compared to using the fstab file. All you need to do is just to install the AutoFS service. Alright, after installing the AutoFS service, and you configure the AutoFS service by creating a master map file in the AutoFS service, one of the AutoFS service configuration file, and then you create a map file. Alright, and after which you then start and enable AutoFS service. And when you do this, anyone that needs or any user that needs the NFS share, alright, the AutoFS service knows how to present the NFS share to such a particular user. And the good thing is that it will be on demand, like it has been written here, that NFS shares can automatically be mounted on the client whenever it is required, and be unmounted whenever it is inactive. So this is automatic. AutoFS just knows how to do this automatically. And one thing I also need to mention is that when configuring auto mount, of course we would need to make use of one of the AutoFS configuration files, which is etc/auto.master. But what I'm going to advise you is that it is better you create a drop-in file and not putting your parameters in this configuration file, because when there is an update, you all know that sometimes, okay fine, if you don't know, if there is an update on a service, it is possible, not all the time, but it is possible that the files in the configuration files may be overwritten, and that is why it is always recommended that you create a drop-in file. And even when you look at this configuration file, you can see this line which says include here. So it means you can create your drop-in file in this directory, which is the etc/auto.master.d/, but the file that you're going to be creating would have a name that must end with an extension of .autofs. Alright, so this is the format of what is going to be in the file, alright, which is the master map file, and this is the format of what is going to be in the map file. Alright, so the master map file will reference the map file, or the map file will reference the master map file, as the case may be. So having understood all of this, let's see the step-by-step guide of how to auto-mount NFS share in Linux, and we're going to use this example to do that. So in the next class, I'm going to show you the step-by-step guide. So thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this video, and in this video we're going to see the step-by-step guide on how to auto-mount NFS share in Linux, and we're going to be using this example that says configure auto-mount on NFS client HKdev1 using an indirect map and /software/site1 as the mount point for the client, and it says the NFS share /software download. Similarly, we're also going to use a direct map on /direct/software as the mount point. Alright, I don't know if I've mentioned it that during the course of the study that auto mount maps can be direct or indirect. Alright, so master map file entry, you can either configure a direct or an indirect mount type, but as we go on in this example, you would understand better what I mean by that. the first thing we need to do is to verify if you can access the NFS share on the NFS server, and that simply means that we need to configure our NFS client. And of course, we know that we need the RPC bind services to be up and running. Alright, so let's verify if it is up and running. So I'm going to do systemctl status RPC bind. So you can see that this service is active and running. By default, the service is always enabled and started, but it's also a good idea for us to verify that it is. Alright, so now let's verify if you can access the NFS share on the NFS server. And to do that, we can use the show mount command. So I can say show mount -e on the NFS server, which is 168.170.172. So you can see the export list for the NFS server, and we can see that we have the NFS client to be among the export list, and it is shared on this directory, which is /software download. And of course, that's what the question has told us, that the NFS shares /software download. And also, if you're trying to access the NFS share on the server and you're getting an error when you run this command, I know I've also gotten that error a couple of times, RPC bind blah blah error. So what you can do is to just mount, let's do this. So we're going to mount the root directory 172. Okay, we're going to mount the root directory of the NFS server, but logically we are not actually mounting the root directory. It's going to show us the NFS shares on the NFS server, so that's what it's going to do. It's not going to show us the whole root directory of the server, and we're going to mount this on /mnt. Okay, and now that we've been able to mount this, let's confirm. If I go to cdmnt and I do ls, so you can see that we have the shared directory, which is software download. So that means we can access the NFS server, which is we can access our NFS share on the NFS server, which is what we want to confirm and verify. So that's good. And the next step we now need to take is to configure auto mount. All right, and to configure auto mount, like we've said in the previous lesson, we need the AutoFS service. So we can just install the AutoFS service. I can do dnf install AutoFS. So I already have this service installed on my system. If you don't have it installed on your system, it's going to install it. Okay, my network is a bit slow. I can just do this. Let's verify. Let me just show you that I have it installed on my system. So I'm going to verify. You can see that I have this package already installed. Alright, so what you need to do is to install that package by using this command. Okay, so when you install this package, this AutoFS package, the next step we need to take is to configure AutoFS by creating the master map file. So we're going to create a master map file for an indirect mapping. Okay, and like I've said, you should always create a drop-in file. I think it's better that way. Alright, we've mentioned the reason why you should do that in the previous lesson. So this is going to be etc auto.master.d. So I can call this technique. I can call the drop-in file technique.autofs, and I must make sure that it has the extension of autofs. Alright, let's create an indirect map file first. Okay, so this is going to be /software, alright, /etc/auto.technique. So you can see that we created the master map file to be technique.autofs. So when you're putting in the entry should also take the name of the master map file. Alright, it's very important to do that. So what we're saying is that, hey, AutoFS, look into this file. Alright, so whatever configuration or whatever thing you find in this file, okay, by the time this directory is active, okay, mount whatsoever configuration you find on this file on this directory, and this is the parent directory. So since this is an indirect map file, so we are saying, okay, let the mapping begin from /software, and that is what we have specified here. So the next thing we need to do is we now need to create this we now need to put in the parameter for this file. So we need to create this file actually. Alright, so I'm going to save this. So let's create the file, which is etc auto.technid. Alright, so I'm going to put in the entries for this file here. So it's going to be site 1, okay, then read write followed by sync. So I'm saying synchronize the write immediately when it happens, okay, on the NFS server, which is 192.168 on 170.172, okay, and the NFS shares software download. So this entry is just as when you put an entry in the fstab file. Alright, so this is the directory where the mount would take place for the NFS server. So because it is an indirect mapping, it's going to be /software /site1, and this is the option mount option, which is a read write followed by synchronize. If you want to put this, you can, and if you don't want to, you can remove it. There are other options which you can specify. Okay, so this is just the basic option, then followed by the server. Followed by the server, which is this. Alright, and this is the NFS share. So let's save this file. So, let's enable and start AutoFS service. Enable AutoFS. So you can see that a symbolic link has been created, and so that means that the service has been enabled and of course started. So we can test our configuration. Alright, so let's go to the directory, which is software. Alright, so software site 1. So you can see that we don't have anything here, so we need to specify the subdirectory, which is site 1. Alright, so you can see the content of the NFS share here. So that means the configuration is well done. So I can just do cd software /site1. Alright, so this is nice, and let's do that of a direct mapping. So let's do that of direct mapping. So for direct mapping in the master map file, we need to specify that in there. auto.master.d/technid.autofs. Alright. Oops, this is the wrong directory. etc auto.master.d. Yeah, I actually have issues with my dot key. Alright, so for a direct map, what we're going to do is we're going to say /dash, okay, on etc auto.technid as well. So like I've said, what we are saying is that AutoFS should look at this file. Whatever thing that is defined on this file should be mounted or should work when there is an activity on this directory. So this is a direct mapping. So we are saying that whatever thing we define here has to be absolute. It has to be the absolute directory. Alright, so let's save this file, and then let's prepare the configuration file, create the configuration file rather for the map file. So that's going to be vim etc auto.technique. Okay, so this, since this is absolute, so this is going to be /direct/software. Okay, read write sync. Alright, so this is fine. You can save this file. So what I'm going to do right now is to start and enable AutoFS. So since it is already started, I'm just going to restart. I'm going to restart AutoFS. So let's test our configuration. If I do cd/direct/software, alright, so you can see that we already have the content of our NFS share in here. So that means the configuration is well done. So it depends on your preference, it depends on what you want to do. When you're configuring AutoMount, you can either create a direct map file or an indirect map file. So it depends on what you want to achieve. Alright, and I should also mention that you can use wildcards for the AutoMount. So in the master map file, we can, define this here. Alright, and in the map file, we can define this. So this is a wildcard. We are saying anything starting from this directory, which is /software. Alright, then on the NFS share, anything starting from /software/download, and that's why we're putting ampersand here. So it depends on, like I've said, it depends on what you want to achieve in your environment. And then if you can also come to this website and see, you can just do this example by yourself in your lab or in your environment using the wildcards for AutoMount. Alright, so it's just going to follow the similar configuration. And also you can also use AutoMount. Another scenario where wildcards rather can be useful is if you don't want to specify the number of home directories in one reference file. So let's say in this map file you need to specify like user one, this, you need to specify this other parameter, you need to specify this other parameter. Alright, if you don't want to do all of this, just use the wildcard and say okay, for all, okay, which is user one, which is user 1, user 2, user 3. Okay, don't forget that this would already be specified in the master map file. So you are saying for all, okay, let this be the share, which is /home/ampersand. So if it is /home/user1 /home/user 2, this should be 2, and /home/user3. So this is going to work. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of technique.com. Today we're going to continue with our course and we're going to be looking at using Kickstart in Linux. Alright, quick one, if you're going to be writing the RHCSA 8 exam or the SUSE Linux exam or the LFCS exam, you can come to this website. Alright, so you can scroll down and click on the exam practice question. Right, we're going to be updating this website from time to time with a lot of practice questions pertaining to each exams. Alright, so it's better you subscribe to this channel or to our newsletter to always get updated. I'm also going to be dropping the link to the website in the description section below. Okay, installing one or two Red Hat systems may seem a little bit easier, right? You can just get the ISO image and you do your clicking and then you get your system installed. Alright, how about installing about 40 to 100 Red Hat systems? Are you going to have to do this one after the other? Alright, so doing this kind of task one after the other is going to be onerous. So that's why there is Kickstart installation in Linux, in Red Hat, to simplify this type of task. Alright, and Kickstart in Linux is used to carry out unattended Red Hat system installations in which a user or an administrator does not have to take charge of the installation, provided the installation configurations or parameters are defined in the kickstart file. Alright, so with a kickstart file, the Red Hat installation will be automated with the kickstart file, and the kickstart file will answer the installation questions, and this works for both the physical and virtual environment. Alright, so let's see how we can create a kickstart file in Linux. So kickstart file can be created in many ways. Alright, one, you can use the Anaconda file of the already installed Red Hat system. So what do I mean by this? The Anaconda file is a file that is automatically created by the Anaconda installer during system installation. Alright, so it collects the necessary installation information and creates it as a file after the installation is completed. And the Anaconda file is found in the home directory of the root user, right? So when you do ls in the home directory of the root user, you're going to see the Anaconda file, which is anaconda-ks.cfg. okay, this is the Anaconda file that was generated when this system was being installed. So you can use this file as a kickstart file. Alright, you can also edit this file to suit your kickstart, your environment for your kickstart installation. Alright, so for example, if you look at what we have in this file, you would see that you have the basic information that you use to install the system. If you were the one that installed the system that you're using, you would see the basic information, alright, that you used while installing your system. Everything is stated here, and if you don't want to use this kickstart file for a kickstart installation, you can edit this file. Okay, so for example, you can see the time zone here, you can see the username, you can see the password, and all of the parameters that you used while installing the system. So it's going to be generated by the Anaconda program, and an Anaconda file will be generated, and you can use this file, okay, for your kickstart file. You can also use this file, initial setup ks.cfg. You can edit it to suit your environment for kickstart installation. So another thing you can do is to install one Red Hat system as an example of just the way you want to install the other systems, or the way you want the other systems to be installed. Alright, and you can then use the Anaconda file as your kickstart file. Alright, so we're going to look at how this Anaconda file can be used in the next video. But before that, let's see the other way the kickstart file can be created. Another way a kickstart file can be created is by using the Red Hat kickstart generator. Alright, so this is a kickstart generator. The Red Hat kickstart generator is a program developed by Red Hat to simplify the creation of kickstart file. Alright, so it is a very powerful program to help select different options and parameters as to which, or as to how you want the OS to be installed. Okay, so for example, you can see the basic configuration, the default language, you can input it here, the keyboard, the time zone. Alright, the clock, the password, the target architecture. Alright, so from basic installation to the partition, to the bootloader, to the packages that you want to install, to the authentication, to the network, to the security, to the display, to the pre-installation scripts and post-installation scripts. Alright, so this is what the kickstart generator can do for you. Alright, if you want to get the kickstart generator, I have the link here on the website, so I'm going to be dropping the link to this website in the description section below. So you can just click the link here and it will take you to the kickstart generator. It is a very simple program to use. Alright, so in the next video we're going to see how to use kickstart for automatic installation in Linux. Alright, so thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, welcome to the next section of this lesson. In this video we're going to look at the step-by-step process of how to use kickstart for automatic installation in Linux. Quick one, if you're going to be writing the RHCSA exam or the SUSE Linux exam or the LFCS exam, you can scroll down to the end of this website and click on the exam practice questions that you want to write, or you just scroll to the top and click on the exam practice questions. We're going to be updating this website from time to time with a lot of practice questions, and it's better you subscribe to our newsletter or to the YouTube channel to always get updated. Alright, in this lesson we're going to be using the DVD or ISO file and the FTP server as the installation source. Alright, so let's start the OS installation with the ISO. Okay, alright, so you can see where it says press tab for full configuration option on the menu items. I'm just going to press the tab key. Okay, so after pressing the tab key, I'm going to come to the end of this line. Okay, so let me try and expand the screen so that it can be very clear enough. Okay, so this seems to be better. Alright, so at the end of this line, I'm going to put in KS, which means kickstart. Okay, and I'm using the FTP protocol, which I'm going to be pointing to my FTP server. So the FTP server is 192.168.170.172. So you can also use the FQDN if your DNS resolution is alright. Okay, so I'm going to be pointing to the Anaconda ks.cfg file. So this Anaconda ks.cfg file is a file that is in the pub directory on the FTP server. You shouldn't have problem with this because we've talked about the FTP services in one of the chapters in this course. Alright, so when you're done with this, the next thing to do is to press the enter key. Alright, so let's see what happens after pressing the enter key. So I'm just going to broaden the screen again so it can be wide enough. So we'll just wait for the system. So you can see now that the installation has started automatically. Alright, so you can see what is happening on the system. It's saying user Oluwatomisin will be created because that is what I have in the kickstart file. Alright, so and this is how the installation is going to be completed using the kickstart file. Alright, for effective automated installation of mass deployment, Kickstart most times is always used with other services such as PXC, NFS, alright, HTTP or FTP, which we are using. So the PXC will be used for pre-built execution, alright, and the installation source can be the NFS server or the HTTP server or the FTP server that we are using, alright, while the DHCP server will be used to dish out IPs to the systems that will be installed. Alright, so thank you for watching and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course and we're going to be looking at managing layered storage with Stratus in Linux. Quick one, if you're going to be writing the RHCSA 8 exam, you can come to this section here on this website and click on the RHCSA 8 exam practice questions. It's going to take you to the collection of practice questions that we have. Or at the end of every lesson, you can click on the link here. It's going to take you to the exam practice questions. Alright, it's better you solve enough questions, solve as much as possible questions before you write the exam. So I'm going to be dropping the link to this lesson in the description section below. So let's look at what Stratis is. Stratis is a new local storage management technology in Linux, and it was introduced in RHEL 8 to further simplify storage solutions. In one of our previous videos, we've looked at the storage management via the standard partitioning method. We've also looked at storage management using the LVM technology. And in LVM, we saw that we would need to create a physical volume. Then we create a volume group from the physical volumes, which are created from block devices. And after creating the volume group, the end result of the LVM technology is the LV, which is the logical volume. And then we can format the logical volume and then format it to any file system that we like. So in Stratis is also taking that concept, that LVM concept. So in Stratis here, you can see that we have block devices, and the end result of Stratis is the Stratis file system. Alright, so when you have a block device, it could be 1, 2, or 3 block devices. From that block devices, you're going to be creating a Stratis pool. Alright, so after creating a Stratis pool, then on the Stratis pool, you can create 1, 2, or 3 or more Stratis file systems. Alright, but in Stratis technology, you do not create anything after creating the Stratis file system, and by default, the Stratis file system is going to be formatted with the XFS file system. So that is one of the shortcomings of Stratis for now, and Stratis is still in its preview state. Alright, so as time goes on, it's believed that it's going to be more flexible than this. Stratis is very cool, and the main difference between Stratis and the LVM is that when you create the Stratis file system here, if the file system is getting filled up, it automatically extends itself. Alright, so provided that you have enough space here on the Stratis pool, when you have data filling up this file system, it automatically extends itself. Unlike LVM technology, where if your LV is getting filled up, you would manually extend the logical volume. But in Stratis, you don't have to go through that stress. It's going to do that by itself, and that is why it is an advanced storage technology, and it has been introduced in RHEL 8. Stratis is very cool. If you know the LVM technology, you would also know the Stratis technology. So if you want to know more about Stratis, you can come to this website. Like I've said, I'll be dropping the link to this website in the description section below. So now, in the next video, I'm going to show you how to configure Stratis technology in Linux. So that's going to be the action time section. We're going to see the step-by-step process of how to configure Stratis in Linux. Alright, so thank you for watching, and please don't forget to subscribe to this channel. Bye for now. Hi everyone, welcome to the second section of this video. In the first section, we've looked at what Stratis in Linux is. We've looked at the Stratis file system. We've looked at the concept behind Stratis. We've also looked at the differences between the Stratis technology and the LVM technology. So in this lesson, we're going to be looking at the step-by-step process of how to configure Stratis in Linux. And quick one, if you're going to be writing the RHCSA 8 exam, just scroll down to the end of this website and click on the link here. It's going to take you to the collections of the RHCSA 8 exam practice questions. It's better you solve many questions before you write the exam. I'll also be dropping the link to this website in the description section below. I'll also drop the link to the previous section in the description section below. So we're going to use this example here, which says create a file system from the devices STB and STC using Stratis, mount it on /data22 and make it persistent across reboot. Stratis runs as a daemon called Stratis D. So the first thing we're going to do is to even verify if Stratis D is installed on the system, and to do that we can use this command. We can query for Stratis D, and we can also query for Stratis D utilities, which is Stratis utilities, which is Stratis CLI. Alright, so you can see that these packages are already installed. If they are not installed, you're going to use the command yum install Stratis D. Alright, Stratis CLI to install these utilities. I already have it installed, so it should tell me that it is already installed on my system. You can see here that it is already installed, okay, and there is nothing to do. And the next step is to verify if it is running, and to do that you can use the command systemctl status d. Alright, so you can see that this service is running and active. If it is not running, what you need to do is to start and enable Stratis D. Alright, and to do that, to start and enable it at the same time, you can either do systemctl start Stratis D and systemctl enable Stratis D, or you can just do this enable now Stratis D. Alright, so it's going to start and enable Stratis D. So the next thing we're going to do from our explanation is that we need to create a Stratis pool from block devices. So let's see the block devices that we have here. We have, if I do lsblk, you can see that I have free SDB, free SDC, and free SDD. But we're going to be creating a Stratis pool on SDB device and SDD device. And to do that, I'm going to use the command Stratis pool create. Okay, let me call this technid pool. Technid pool. I'm going to create this on device SDB and on device SDC, SDD rather. All right. So you can see that the pool has been created. To confirm, I can use the command Stratis pool list. So you can see the pool, the Stratis pool being created, which is 5 gig, because the combination of these 2 gig and 3 gig is 5 gig. All right. We can also verify the block devices the pool was created from. You can use the command Stratis block device list. Okay, so it's going to show you this pool that the technical pool was created from the device SDB and the device SDD. You can also see the sizes, their sizes there. All right. You can also do is, if you know that you have a lot of Stratis pools, you can just specify the name of the pool and say, okay, I want to see the devices for the technical pool, and you're going to see it here. And if you do lsblk, you can see that Stratis has been created on these devices. The SDD device, you can see it here, and here, which is the SDB device. Okay, so after creating the pool from the explanation in the previous video, the next thing you're going to create is the Stratis file system. All right, and to create the Stratis file system, you're going to use the command Stratis file system create. So the name of the pool. All right, then you're creating a file system on this pool. I can call this technid. Let me call this technid file system. I'm going to press the enter key. So it's taking time to create the file system. So it's been created now, and I can now do Stratis file system list to see the file system, to see the Stratis file system. You can see the pool here. You can see the Stratis file system. This is technid f_fs, which is under the pool technid pool. And the next step to take here is to create the mount point, because the question says that we should mount this file system on /data22. So we need to create that mount point. And I also want you to notice something here. You can see that the device is on. Look at this path is on /Stratis/technid pool/technid file system. So it's taking this path actually. Okay. So now let's create the mount point. I'm going to do mkdir on data22. Alright, so I already have this mount point. So if you don't have it on your system, it's going to create that mount point. So I need to mount this device on that mount point, which I'm going to do mount. So you can see the device like I showed to you on /Stratis. Okay, on Technic pool and on Technic file system. I'm going to mount this on data 22. So if I do df-h, I should see it as a mount point here. Okay. It doesn't seem to exist here. So what could be the issue? Let's see again. I'm sure am I correct with the command? Mount, oops, sorry about this, on Technic on data 22. So let's do df-h again. Okay, it's fine. It's fine. We can do dev adm settle. Okay, and if I like, I can restart. I can even do path probe, but let's see again. I'm sorry, df-h. Okay, now so you can see that it has been mounted on this Stratis file system. And don't forget that the Stratis file system is automatically formatted with the XFS file system, just like I have explained in the previous video. Okay, so to make this persistent, we will need to input this in the fstab file. Okay, so let me just clear my screen. That means I will need to get the UUID of the file system, and I can use the command block ID -p on Stratis /Technic pool on Technic file system. So you can see the UUID here, which is this. So this is what I'm going to use in the fstab file. I can also use the lsblk command to get the UUID. So I can just do lsblk output. So use the one that is more comfortable for you, equals UUID, and I can do on Stratis. I don't know why tab isn't working for me. Okay, so let's just type this out, because tab isn't working for me. I'm going to do Technic file system. So I can also do this to get the UUID. So I can copy the UUID and I'm going to put this in the fstab file. So I can do this. So this is going to be UUID equals the UUID, which is this, and this is going to be on data 22. XFS. You just do this. Then default. Just going to put it here, X systemd. So you need to put this entry in the fstab file. That systemd requires Stratis D service. Okay, Stratis D dot service. I'm going to put this as 0, 0. So I'm going to save this file. Alright, so I can, let me just increase my screen so you can see what I did here. So you can see what I did, so it's big enough now. Okay, so I'm just going to save this file, and I can do mount -a, so I don't have any error, which means that whatever I have in my fstab file is okay. I can confirm the file, the mount point again, so it's mounted on /data22, and I can also, or what I can do also is to do the lsblk command, so you can see that, you can see my Stratis file system, you can see it on data/data22. So let's quickly do a test. I've told you that the file system automatically extends by itself, unlike the LVM technology where you have to extend the LVM if it's getting filled up. So we're going to put this into a test now. So what I'm going to do is to create a file. I'm going to call this technique file. I'm just going to say echo, this is technique file, file 1. Alright, I'm going to put this in data 22. I'm going to call this technique file. Okay, so let's see technique file right now. Okay, so you can see that technique file exists. And let's verify the used file system. So to do that, we can just do stratis file system list technique pool. Oops, stratis file system list technique pool. So I'm going to grep for the technique file system. Okay, so you can see that we have 546 MB which has been used. So what we're going to do now is to add more files to this file system. So I'm going to add about 2 gigabyte file. So I'm just going to use this dd command. This is a common command. So this is a device. I'm just going to do random. I'm going to do this here, and I'm going to say put it on data 22 and technique file. So I'm going to do for 2 gig. Count 2048. Okay, so let's leave it for a while. So now let's check. So you can see that it has automatically extended by itself. It has extended to 686 MB. So what happens is that as the file system gets filled up, it automatically extends itself. And if you can also add to the pool, you can add more block devices to the Stratis pool. So if you need more space in the pool, you can always add a block device in the pool. So in the next video, I'm going to show you how to add more block devices in the Stratis pool. I'm also going to show you how to create a Stratis snapshot. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the third section of this video. In the first and second section, we've looked at what Stratis in Linux is. We've looked at how to configure Stratis in Linux. We've looked at the differences between Stratis technology and the LVM technology. So in this video, we're going to look at the step-by-step process of how to extend the Stratis pool and how to create a Stratis snapshot. And quick one, if you're going to be writing the RHCSA 8 exam or the LFCS exam, just come to this website. At the end of every lesson in this website, there's always a link that will take you to the RHCSA 8 exam practice questions. So it will take you to the collection of the questions. So it's better you solve as much as possible questions before you write the exam. It's very important. We have been able to configure Stratis in the previous video. We created the Stratis file system. So in this video, we're going to be adding a block device to the Stratis pool, or rather we're going to be extending the Stratis volume. So to do that, let's confirm the block device that we want to add to the Stratis pool. So on this system, I'm going to be adding the SDC block device to the Stratis pool. Okay, so let's verify the pool again. So I'm going to do Stratis pool list So I want to be adding the SDC block device to the technid_pool. All right. So and to do that, I can also, before I do that, let's like we did in the previous video, let's see the block devices that are attached to this pool. So I'm going to do this to technid pool, and you can see that we have the SDB device and STD device attached, which is 2 gig and 3 gig, making this pool 5 gigabytes. So now I'm going to add the SDC block device to the pool. To do that, I'm going to use the command stratis pool add data on technid pool with the device SDC. Okay, I'm going to press the enter key. You can now verify if the device has been added to the pool. So I'm going to use the command stratis block device list. So you can see that the SDC device, which is 4 gigabytes, has been added to the pool. If I do stratis pool list, you can see that the pool has been increased, it has extended. So this is how you're going to add a block device to a stratis pool. So now let's see how we can create a file system snapshot using stratis. So let's of course verify the technid file system, which we know that it exists. Okay, and I'm just going to do the command stratis file system list. I'm going to grab this on the technid file system. Technid. We created this in the previous video. So we created technid file system. So what we want to do now is to create a snapshot of this technid file system. And to create a snapshot, I'm just going to use the command stratis file system snapshot. I want to create a snapshot of technid file system. So it's going to be technid pool technid file system and the name of the snapshot. So I can call the name of the snapshot technid snapshot. So it's creating the snapshot now. It's taking time. Alright, so it's created it. So let's verify if the snapshot has been created. So to do that, I'm going to use the stratis file system list. I can grab this to technid snapshot, but let me just list everything so you can see the technid snapshot here. Let me widen my screen so you can see it very well. Alright, so you can see okay, here it is, technid snapshot. Alright, so this is the snapshot and it has the exact copy of the file system. So of course that's what the snapshot will do. It will create the exact copy of the file system. So depending on your environment, depending on what you want to do, you can mount the snapshot if you wish, and if you don't want to do that, you might not do that. So if I want to mount, for example, I can make a directory and I'm going to call this directory technid. Let me call this technid snapshot. Alright, so I can mount this on technid snapshots. I can just do mount. I'm going to copy the path, which is here, just the same way we did when we were configuring stratis in the second video. Alright, so I'm going to mount this on technid snapshot, so we can confirm that it is mounted. So this is technid snapshot. So guess what? You know, we had a file on data22. So let's see if that file is on technid snapshot. So let me just cd to technid snapshot. And let me do ls. So you can see that file here, technid file. It is also in technid snapshot. Okay, so that was the exact copy of the file system. be configured in the second video. The first or second video, if I'm correct, we also have that same file here. Okay, and to delete a snapshot, you just have to unmount the mount point and then use this command to delete a snapshot. It's the same thing, the same way you're going to delete a file system. Alright, so if you want to learn more about Stratis, you can come to this website. I'll be dropping the link to this website in the description section below. So I also want to mention something. You can't remove a block device from a Stratis spool for now. As of when I'm doing this video, that can't be done. You can also click on this link on Redhat's website link to see the discussion around this removing the block device from a Stratis spool. So thank you for watching. Please subscribe to this channel, and bye for now. Hi everyone, my name is Victor and I am one of the authors of technique.com. Today we're going to continue with our course, and we're going to be looking at how to install, configure and manage video in Linux. In one of our previous lessons, we've looked at a lot of storage technology. We've looked at the basic storage management, which has to do with the standard partitioning of block devices. We've also looked at the LVM technology in Linux. We've looked at Stratis technology as well. So in today's lesson, we're going to be looking at video technology. So the video technology is also a storage technology, and what video will do is that it will help you to save space. So video, which means the virtual data optimizer, is a storage technology that is used to maximally optimize storage space. So for example, if you have files, a file 1, 2, 3, 4 files that are of the same thing, that has the same content on a storage device, if that storage device is using video, so video would compress and eliminate the duplication of that data on the storage device, thereby saving space for you. Alright, and that is what we're going to look at in this lesson. We're going to do an example. We're going to create a video volume, and we're going to put in files. We're going to put in files of the same data on that storage device, and we're going to see how video would compress and deduplicate the data on the storage device. Okay, so without wasting much time, let's look at the examples that we have here. So we're going to look at the step-by-step process of how to create a video volume in Linux. We are going to create a video volume with a logical size of 100 gig and with the name technique_video from the dev SDC device, and the volume should be formatted with the XFS file system and mounted on video_data, which must be persistent across reboot. We need to verify if video is running on the system. If video is not running, we need to start and enable video. And if video is not installed on your system, if you're using a different distribution apart from Red Hat 8 or CentOS 8, then you can install video on your system. Alright, you also need to make sure that the K-video module is also installed on your system. Alright, and so we can verify if video is installed. We can use the command rpm. You can query for video and also K-video. Alright, so you can see that these packages are installed. Alright, so if any of the packages aren't installed, you need to install this package by using the yum install, then followed by the name of the package, or you use the DNF install followed by the name of the package. Okay, so you can also verify if the video service is running. You can use the command systemctl status video. Alright, so you can see that video is running and it is also enabled on the system. If video is not enabled, you need to enable video. Alright, and to do that, you're going to use the command systemctl enable video. So now we need to create the video volume on the SDC device according to the question. So let's even verify the block devices we have on the system. So we're going to be creating the video volume on SDC, and to do that we're going to use the video create command. So in on the website here I have different we have listed the different commands that we can use for video, how we can enable video. So this is how you can create a video volume, okay? And we also have the commands for how you can stop video volume, and how you can start a video volume in Linux, and how you can also delete a video volume in Linux. So if you want to learn more about how you can use this command, you can just come to this website to look at it here. I'll be dropping the link to this website in the description section below. What we can also do is to look at the man page for video. Alright, so I can look for examples and see how video can be created. So we can see this example here. I'm just going to copy this and I'm going to paste this here, so I can use this format to create the video. So to create the video, I'm going to do video create followed by the name of the video. So this is going to be technique underscore video. Alright, on which device? On dev SDC, right? Then the logical size of the video would be video logical size. Okay, so this is going to be 100 gig. You should note that a video volume is a logical volume and can be specified to be larger than the physical volume it to be created from. So this physical volume that we're creating this video volume from is a 10 gig, and we're going to create a video volume of 100 gig. So if the video size is not specified, okay, the video volume will automatically take the size of the block device, which of course will make the video performs better. And on the other hand, if the logical volume is larger than the block device, alright, so there will be a larger space like it is right now. Of course there will be a larger space for your data, but lesser performance compared to if the logical volume is the same size as the physical volume. Alright, so it depends on what you want to achieve in your environment. So you can now see that the video volume has started. Okay, starting video technique underscore video, and it is ready at dev mapper technique underscore video. So we can also look at it, verify if it has been created by using the command video list, and you can see that this command will list all the video volumes you have on your system, and we can see our video volume, which is technique underscore video. Alright, and we can also verify the video status by using the command video status name technique. So it's going to be technique underscore video. So you can see that you have a lot of information here. So what we can do is to verify if compression and deduplication are enabled. After all, that is what we want here. That is what we want video to do for us in this case. And so we're going to do video status name technique video. We can grep for deduplication. We can also grep for compression. So you can see that they are both enabled. And the next step we need to take is to format the video volume. So according to the to our example, we're going to format the video volume with the XFS file system. So we can do mkfs.xfs on dev
mapper technique video. It's taking time to format the volume. We can now create the mount point, so we can do mkdir video underscore data. Okay, so it's saying that this mount point already exists. Now let's map the video device to the mount point. So we can do mount dev mapper technique video on video data. So let's verify if it's been mounted. So I can just group for video data. So you can now see that it's been mounted. Okay, so it's been mounted on video underscore data. So what we need to do to make this to be persistent is to input the device UUID or the device information in the FS-tab file, and to do that we need to get the UUID. So to get the UUID, I can use the command blkid and do this on dev mapper technique video. So I'm just going to copy this UUID and put it in the FS-tab file. So this is going to be here. It's going to be UUID equals, going to paste it here, and this is going to be under the mount point. So let me check the mount point again from our example. So the mount point is video underscore data. And this is going to be xfx. It's going to be default. So I'll just add this information. Systemd dot requires video service. This can be 0, 0. So I'm just going to save this file. I can do a mount -a to confirm that my FS-tab file is fine. Alright, so that's fine. And I can also reboot the system if I wish, but let's reboot the system and see if what we've done is okay. The system should be back by now, so let's restart. I'm going to log in. Right, so we can also look at the mount point. So we can see that the volume is still mounted. So this is how you can create a video volume and make it persistent in Linux. Okay, so let's do our test now. I mentioned that video manages files or data that are the same by compression and deduplication. So in this test, what we're going to do is that we'll copy files of the same data multiple times to the technique underscore video volume, and we'll verify the initial saving percentage before copying and the saving percentage after copying. Alright, so what we're going to do right now is to verify the initial space of the file system, and to do that we're going to use the command video start, the human readable form, and you can see the size of the video, of course, which is 10 gig. You can see the used size. So video has already taken 4 gig. Okay, so you can see the available size, which is 6 gig, and you can see the used amount in percentage, which is 40%, and you can see the space savings to be 99%. I have a file called file1. Alright, so I'm going to copy this file1 to the video device. So I'm just going to do copy it to directory file1. I'm going to copy it to the video device. This is going to be video data, and I'm going to call this file1.
So now we can verify rather the statistics again. So you can see that the space savings is now 28% and the used size is now 4.2 gig. Alright, and the available size is now 5.8 gig. So we're going to copy the same file one to the video device again, and let's see what video will do. So this time around I'm going to call this file 2. Let's verify the percentage again. Okay, so you can see that the saving space, you can see it to be 54%. Instead of this decreasing further, you can see that it's increasing, and you can see that the used size still remains the same, which is 4.2 gig, and this just keeps increasing. So we're going to copy the same file again, and let's do this. I'm going to call this file 3, and let's verify again. You can see that the saving space has increased and the used space is just the same. It remains to be 4.2 gig. So this is what video would do. It will help you compress and deduplicate data of the same files of the same data. Alright, let's check this again. Oh, you see, it has increased to 72% right now. The saving space keeps increasing while the used space still remains the same. Alright, so we have just 2 topics to go. We have managing containers and KVM to go. Alright, so thank you for watching once again, and please subscribe to this channel. Bye for now. Hi everyone, my name is Victor and I am one of the authors of Technique.com. Today we're going to continue with our course, and we're going to be looking at creating and managing basic containers in Linux. Container, or rather containers, are set of one or more running instances isolated from the system. So for example, if I have my system here, alright, so a container is a running instance that is isolated from the system. Okay, and container uses namespaces for its isolation. The container technology is quite similar to virtualization, of course, except container is isolated. So if you look at this diagram, you can see the virtualization concept, where you would have the infrastructure, which is the hardware, and on the hardware you have the operating system. Alright, and on the operating system you have the hypervisor, and on the hypervisor you can spin up VMs. So this is a VM, for example, this is a guest OS. You can see the VMs that has its own binaries and libraries, and from the VM you can have applications running on the guest OS. Alright, this is application 1 and this is application 2, and you can see that application 1 is using the binaries and libraries of the guest OS as well as application 2. So if you make changes to these guest OS binaries and libraries, of course it might affect the applications running on the guest OS. The same thing is applicable to this guest OS as well, for application 3 and 4. If you make changes to these binaries and libraries, it might affect the applications running on the guest OS. So you know, we want to avoid all of this, hence why there is the birth of the containerization technology. So when you look at the containerization, for example, you can see the infrastructure here, which is the hardware, and on the hardware you can see the operating system. So for containerization, you know, I said it is an isolated running instance. You can see the container here, and the container of course has its own libraries from the image, and you can see that the application can use the libraries of the image or of the container. You can see that. So the same thing is applicable to application 2 here. So if you make any changes on this guest OS libraries, it will be isolated from the container, so it won't affect the applications running on the container. All right, so that's the difference between virtualization and containerization. And again, before you can create a container, you need a container image. All right, and a container image can be gotten from registries. So if you look at this diagram right now, you can see the containers here. So you need a registry, all right, and you can get the image from the registry, and from the image, of course, you can create your containers. There are a lot of image registries out there, all right, the paid and the unpaid ones. So you need to be very sure and trust the registries before using them. So a registry is a repository, just as how you get your packages from your repositories. And Red Hat distributes container images from two locations, all right. So one which is the registry.redhat.io, and the other which is registry.access.redhat, all right. And if you want to access this registry, which is registry.redhat.io, you would need to register with Red Hat. Okay, so this needs registration and authentication. So if you want to get a 30-day trial subscriptions, you can click here on this website, all right. So you can be able to get the 30-day trial subscriptions. And also, if you want to sign up for the Red Hat developer program, you can also click here. So I'll be dropping the link to this lesson in the description section below, so that you can click on it and it will bring you to this page. You can also get the more information about registries and their content here, all right. And okay, so let's look at the format, an image format, all right. So an image is always in this type of format. You can see here, this is registry.redhat.io/rel8/httpd-24 column 1-122. You might begin to imagine that what is all this, all right. So let's break it down. You can see here, this is the registry, which is registry.redhat.io. So after the registry, then the next parameter is going to be the image username. So this is the image username, which is rel8, all right. Then followed by the name of the image. So this is the name of the image, which is httpd-24, and followed by the image tag, all right. So the image tag is always after the image, and there's going to be a column here, and you can specify the image tag. In an advent where you don't want to specify the image tag, by default, you're going to be getting the latest image tag from the registry, all right. And also, if you're creating a container and if you don't specify the container name, by default also you're going to get a random name. So you can see the scenario I pointed there. I said, so for example, if I build a container image, so I might want to build a container image, all right, and I can decide to call the image web app, all right, and the image username Victor, because I built the container, all right. And I can also decide to put the image in a registry called registry.technic.me. Sorry, registry.technic.me, all right. So if I want to reference the image, I can reference the image as registry.technic.me. So this is registry / because I built the image, I can say Victor, all right. This is the username, image username, and this is the image, which is web app, all right. So this is how you would always see an image. It comes with the registry name followed by the username, image username, followed by the name of the image, and followed by the tag, all right. So in this case, we have the tag here. In this case, I didn't put the tag here. So of course, like I said, it's going to take the latest tag. As we go on in the action time section, you would understand this better. You see how we're going to be creating containers, how we're going to be specifying the image tags, and how we attach storage port to containers. So well, before we get to that section, I just want to be very sure that I've covered everything I need to explain here. All right, so let's move on. All right, so this is okay. All right, so you need tools to create and manage containers in Linux. So I think I'll just break it down here, and in the next video we're going to continue with that. We're going to look at the tools that we can use to create and manage containers. We're going to look at how a basic Linux containers work, alright, and we're going to look at how to install container tools module and many other information about containers. Alright, so thank you for watching, and please subscribe to this channel. Bye for now. Hi everyone, welcome to the next section of this video. In the first section of this video, we've looked at what a container is. We've looked at the difference between virtualization and containerization. We've looked at what a container image is. We've looked at how to get a container image. We've looked at the registry. We've also looked at the format of an image. Alright, so in this lesson we're going to continue with looking at the tools that are used to create and manage containers in Linux. Alright, and one of the tools you can use to create container is the Podman tool. Alright, and if you also want to build a container image, you can use the builder tool, and you can use the Scopio tool to inspect and do other container management activities. And you should also know that the Podman can actually do more than creating containers, but for the scope of this study we're going to use Podman to create containers only. Alright, so let's look at how a basic Linux container works. Alright, so a container leverage on the kernel. Alright, like we've said, I said a container is an isolated instance. It's a running instance that is isolated from the operating system. Alright, so and the way it is isolated from the operating system is that it leverages on the key components of the operating system. Alright, so for example, a container will leverage on the kernel, and another key component the container will leverage on is the SLinux, which is used to protect the container processes from each other and from the host machine. Alright, so the container will also leverage on the namespace and the C group and the seccomp. Alright, so for the namespaces, those are used to make the isolation of resources and containers possible. Alright, so it isolates the containers from each other and from the container host, while the C groups, that is the control groups, on the other hand manages the system resources, and it regulates containers from using up the resources on the host. Alright, so from this image you can see the container running in an isolated environment, which is different from the host operating system. So you can see the container in a different namespace which has its own binaries and libraries, and you can see the host operating system on a different namespace with its own binaries and libraries. So the services that is going to be running on the container is going to be different from the services that is going to be running on the container host, and you can do that by just doing ps-ef. That's just to check the processes running here. So they're going to have different processes. They're also going to have different names, because they have different libraries. So this here depicts that a container, of course, may need a storage device depending on how the image was built. Alright, so for example, if the container needs a storage device, we would need to attach the storage from the container host to the container, and that's why you're seeing this arrow here. Alright, so for example, if the mount point is var www, it's going to be attached to the container, and also a port on the host might need to be forwarded to the container. Of course, it will have to be forwarded to the container. So for example, if this container is an Apache web server, and there is a user somewhere there that needs to talk to this service. Alright, so the user can talk to this service by using this port. Alright, so this port on the host is going to be forwarded to the container. So whenever this user calls this service via the port, alright, so the port on the host is going to be forwarded to the container, so the user can be able to talk to the container. Alright, so what else do we need to talk about here? So this is a summary of all of what we've been saying, that creating a containers requires logging into the registry, which we've ascertained that. So we need to log into the registry, download the container image, alright, and then create the container. So that's the summary of everything that we have been saying. All right. And before we can create the containers, we need to install the module that contains the container utilities. Okay, so we need a tool, all right, to manage containers, and we need to install that module that contains the tools, and the module is container tools. And to install that, we need to do yum module install container tools. All right, so this is how we're going to install the container tools module in Linux. And to log into the image registry, we use of course, we've talked about the Podman command. We do Podman login registry.redhat.io. So this is the registry, all right. And to log in, we just use the command Podman login, and we put in our username and password. And then we need to download the container image, just like we've said. To download the container image, we use the command Podman pull, followed by the registry name, followed by the registry username and the image name and the tag. And I said that if you don't specify a tag, of course, the latest tag will be used, all right. And then we can run the container by using the command podman run -- name, the container name. All right, so these are all of the activities that we're going to be doing in the next video, which is the action time. All right, so this is a way you can restart a container. This is how you can search for a container image in Linux. This is how you can search for image tags in Linux. All right, so most of these activities are what we're going to be doing in the next video, which is the action time, which is the step-by-step guide of how to create a basic container in Linux, and we're going to be doing that with an example. So in the next video, we're going to do this example. We're going to see how to create containers, how to download an image, all right, and how to do manage container, the basic management of containers in Linux. All right, so thank you for watching, and please don't forget to subscribe to this channel. And also, if you're writing the RHCSA 8 exam, you can just come to this website. I'll be dropping the link to this website in the description section below, all right, and click on the RHCSA 8 exam practice questions. We have enough questions, more than 100 questions, but we've been solving it bit by bit, so it's better you solve as much as possible before you write the exam. And I can guarantee you that when you do that, you're of course going to pass the exam. So thank you once more. Bye for now. Hi everyone, welcome to the third section of this video. In the first section, we've looked at what a container is. We've looked at the container image, we've looked at the registry, we've looked at the format of an image, we've looked at namespace, seccomp, we've looked at SE Linux, how you can use SE Linux, how container leverage on SE Linux as one of the key components of the operating system to work with. All right, so in this video, we're going to look at the step-by-step guide of how to create a basic container in Linux. All right, and we're going to be looking at this question, which says that create an Apache web server container with the latest tag from registry.redhat.io/rel8/httpd-24 named techr and should be accessible on port 8080. All right, and the question further says the service running on the container should be persistent, and on the host, create a file /techlink/html/index.html and attach it to the container as www. All right, and quick one, if you're going to be writing the RHCSA 8 exam, you should come to this website. All right, so you can either scroll down and click on the 8 exam practice questions, or here on the website you can click here to get to the page where you can see the exam practice questions. So we have enough questions, over 100 questions, and we're going to be solving it bit by bit. So it's better you do a lot of practice before you write the exam. It's going to help you a lot. All right, and I'm going to be dropping the link to this website in the description section below, so you can easily navigate through. So let's solve this question. Okay, so the first thing we need to do is to install the module that contains the container utilities, and to do that we're going to use the command yum module install container tools. Okay, so I already have the container tools module installed on the system, so it should tell me that it is complete and there is nothing to do. You can see that there is nothing to do because the module has already been installed on the system. Alright, so after installing the container tools module, we need to log into the registry so that we can get the image from the registry. I would like to create the container as the user Victor. You can see now that I'm logged in as Victor. Alright, so to log into the registry, just like we've said in the previous video, we're going to use the command Podman login and followed by the name of the registry, which is registry.redhat.io. okay, so it's prompted us for the username. We need to put in the username. Okay, alright, and the password as well. So we can see that we've been able to authenticate successfully. Alright, in the previous video too, we talked about how you can register, how you can get credentials to this registry. Alright, so if you need to get credentials to this registry, and if you have not checked that video, you need to check that video so you can you can register with Red Hat. Okay, I showed you the links to click on so that you can get the registration done. Alright, so now that we've been able to log in into the registry successfully, we need to download the image. But before we download the image, it's going to be a good idea for us to even inspect the image that we want to download. And to do that, we can use the Scopio command. So I'm just going to say Scopio inspect docker followed by the registry followed by the image, which is httpd-24. so it's pretty large, so I'm going to pipe this to more. You can see the different image tags that we have. You can see the 1-112 tag, you can see the 1-118 tag. Alright, if you scroll down, you can see the latest tag. Alright, so you can see the different image tags that we have, just as I've mentioned in the previous video that after the image, then you can specify the image tag. If you don't specify the image tag, like I said, it will automatically take the latest tag. Okay, so the question says that we should create an image from this registry with the latest tag. Alright, so the next thing we need to do is to download the image since we've done the inspection. So to download the image, I can use the command. Let me just clear the screen. I can say Podman pull from the registry, which is this registry.redhat.io followed by the image. Alright, so I can either put the latest tag or I just remove this. Okay, so I'm doing the same thing because I've told you that if you don't add the latest here, or if you don't add any tag there, it's going to get you the latest tag. Okay, so if I wish, I can put the latest, and if I wish, I can put the latest. So since the question did not give us any specific tag to use, the question just says we should use the latest tag. So we can do this and we can remove it, because if we remove this, it's going to also give us the latest tag. Okay, so let's just add it, and I'm going to pull the image. You can see now that it's trying to download the image from this registry. Alright, it's copying the blobs right now. Alright, the image is done downloading. So the next thing we need to do is to prepare the storage that we're going to attach to the container. And the question says, according to the question, it says that create a file called /technique/html/index.html and attach it to the container as var www. So let's prepare the storage by creating that directory. I'm just going to make this as parent on technique html All right, so let's put a file in index.html. So I can just put anything here. This is a test. I'm going to redirect this to technique.html. I'm going to call this index.html according to the question. Okay, so now that we've been able to create this directory, we need to make sure that the others have the read permission on the file and on the directory. So let's check for the file first. I'm going to do this on the file, on the directory rather, so you can see that the directory has the read permission, and of course it also has the execute permission. So let's do this same thing on the file and let's see if it has the read permission. So this is going to be index.html. So you can see that the file too has the read permission. So that's great. That's what we want. So the next thing we need to do is to create the container. Okay, and to create the container, we can create it in a detached form, or we can call for an interactive shell while creating the container. When you look at the question didn't say we should create an interactive container. Neither did the question say that we should create a detached container. But the thing is, if I create an interactive container, which is by using this command, I'm going to specify the -it option. Okay, so for example, I'm going to use the command Podman run. This is the name of the container. Alright, so there's a typo here. I'm supposed to give the option -it, which means I'm called for an interactive shell, and I'm going to specify the type of shell I want, which is /bin/bash. Alright, but the problem here is if I create the container this way, if I exit out of the container will stop. Okay, so because while creating the container, I'm creating the container and I'm asking for an interactive shell. So the thing we can do is to, or the best option we can take in this scenario is to create the container without an interactive shell. So we're going to be creating a detached container, which we're going to be using the -d option, which means detach. So I'm saying detach this image, and if I need to interact with the container for whatsoever reason, I can then use this command to call for an interactive shell. Okay, so I can then do -it. So if I call for an interactive shell this way and I exit out of the container will not stop because I started the container using a detached command. I didn't call for an interactive shell. Okay, so in this example, we're going to create the container with the detached option. And while creating our container, we're also going to use the -v option, which means volume mount. Alright, you remember that we created this directory. So this is the directory we're going to be attaching to the container as var.ww, yeah, but not HTML in this case. Alright, so we also need to add the column capital Z option, which means that we need to set the directory type context to the right SLinux type context, which is this. Alright, so we also need to specify this option. We need to put this while creating the container. And for the port aspect, alright, so we're going to be forwarding the port from the host, which is 8080. In this case, in our example, we're going to be forwarding the port to 8080 as well. Okay, before we create the container, let me mention this as well, because in the question we were not asked to create an environment variable, but if you're asked to create an environment variable, you need to add the -e option. You need to add the variable with the value. So if you're asked to create more than one variables, you also need to add -e option and then add that environment variable and the values as well. So to create the container, we're going to use Podman. Alright, we're going to say run. I want to detach the container, which is the -d option, and I'm going to say, okay, I want to name this container tech-har. Don't forget that in the previous video we mentioned that if you don't give a container a name, it's going to give it a random name. All right, so this is -p, which is the port option. So I'm saying forward port 8080 on the container host to 8080 on the container, and this is the V, which means volume option. So I'm going to be attaching this directory, all right, technid. All right, so I'm going to be attaching it to the container as var www, okay, and I'm going to add the Z option for SC Linux as well. Then the last thing I'm going to put here is going to be the registry followed by the image. So this is going to be registry.redhat.io followed by rel 8 httpd-24, okay, and this is going to be latest. So you can see that the container has been created, and this is very fast because we already downloaded the container first, okay, and that's why we're able to create the container very fast. If you did not download the container first and you just run this command, the command will need to go and download the container first before it creates the container. All right, so now that we've created the container, we need to verify if the container has been created, and to do that we can use the command Podman ps. So you can see the name of the container, which is TechHour. It's been created. So most times I usually run this command 2 to 3 times, because if you do not create your container very well, like if there's an error, the container might start and it might stop later. So let's confirm again. So you can see that the container did not stop. So in an advent where you create a container and the container stops, you need to check the log and see the reasons why the container has stopped. So in the previous video, just check that documentation. Just like I've been showing you, you would see how you can check for the logs of the container. So for example, to check for the logs of the container, you can just do podman logs. Then this is going to be TechHour, which is the name of the container. So you can reference the container by the name of the container or the ID of the container. This is the container ID. All right, so if I do this, it's going to get me the logs of the container. Excuse me. All right, so this is how you can trace and see what might go wrong with your container. Okay, so the next thing we need to do is to verify that we can access the storage that is attached to the container over port 8080. Okay, don't forget that we forwarded that port to the container, and to do that, I'm just going to use the command call, and I'm going to say on localhost I want to see this, so you can see that our container was well created. So this is the same content we have on the storage, and we can also access this on the container over port 8080. So the thing is, if we reboot our system this way, our container will not start across reboot. So everything that we have done, the container that we have created would go, and that's because we didn't make it persistent. All right, so to make this persistent, we need to go through some steps. First of all, we need to create a systemd directory where we would generate the user's unit file. So in all essence, we need to configure this container as a systemd service. All right, so if you can configure this container as a systemd service, then this container service would start across reboot. Okay, so the first thing we need to do is let's create a systemd directory where the user's unit files will be generated, and to do that, we're going to use the command make directory. All right, so these are the steps I've also shown to you in the understanding the subject matter section. You can see how to make a container persistent in Linux. So you need to create this directory, and you need to generate the unit file in this directory, after which you would need to enable the linger feature. All right, and then you can start and enable the container as a service. So that's what we're going to do right now. So this is going to be make directory here, which is going to be .config systemd. Alright, followed by user, and we need to generate the user's unit file in this directory. So I will need to change directory here so that I can be able to generate the user's unit file in this directory. So this is going to be systemd user. Alright, so now that I'm here, I'm going to use the Podman generate command to do that. That's to generate the user's unit file. So this is going to be Podman generate systemd followed by the name of the container, which is techr. Alright, then I'm saying I want it to generate the files here. Okay, so I can confirm if the file has been generated. So you can see that the file has been generated, which is container -techr.service. Alright, and the next thing we need to do is to enable the linger option for this user, and to do that I'm going to use the command login_ctl enable linger. Okay, so you can see that the option has been enabled, but I can verify that. So to verify that, let me just do login_ctl. I can say show user Victor. Alright, so you can see the linger option. You can see that it's been enabled for this user Victor. Alright, so now that we've been able to do this, we need to start and enable the container as a service. But before we do that, let's stop the container. Alright, so you can see that the container is running. So let's stop this container. So I'm going to do podman stop techr. Okay, so I'm sure that the container, of course, is also archived. So we're going to remove it from the archived file as well. Okay, so to do that, I'm going to do podman remove techr. Alright, so let me confirm that as well. So you can see that the container is not started and the container is not archived as well. Alright, so now we can now start and enable the container as a service. So to do that, I'm just going to do systemctl -- user daemon reload. Okay, and I'm going to enable, just as you would enable a normal service, a normal systemd service. So I'm going to do systemctl -- user enable now container-techr.service. Alright, so you can see that it has created a symbolic link. Alright, so that's the way a normal enabled service would do. Now we can verify if the container is running. So if I do podman ps, you can see that the container is running, and I can also verify the storage as well. So if I do call on the local host, you can see that I can access the storage over the port 8080. Alright, so if I reboot the system now, the container, the service, the Apache service is going to be started. The container will start across reboots. Okay, so this is how you can work. You can create a container, stop. We've looked at how to stop, remove a container from archived file, make a container persistent across reboots. Alright, so thank you for watching, and please subscribe to this channel. Bye for now.